Good morning, how are you?
Fine, how are you?
Good. Ready for another one?
Yes! Ready for the catch boxes, oh yeah.
I know, it's gonna get a little crazy in here.
Yeah, we will see.
They're just chucking it all the way down. Alrighty. Good stuff. I'll see. I will see you in a bit.
Yes.
So Steve said you could just unplug stuff. But this is connected to HDMI. How won't something break if we remove the HDMI?
I don't think we should unplug stuff.
No. It's better to leave that. And,
Yeah.
I think I'm the only one who would actually have to use a laptop. So I might just skip over my demo.
Yeah.
Yeah.
Yes.
So we don't. It's just. I'm a little bit short on time as well.
So just skip the demo because demo gods are always.
I recorded. But I still have to play the video and can't do that in
In the PDF
the
slides.
system. Yeah. It's just too much fumbling around. I think if it's
Yeah.
I'm the only one, then we run everything out of this.
Yeah.
I can switch presentations using my special powers via my laptop, and then we should be able to present here. Right?
Yeah, I think so.
Like,
Just going to.
oh,
No, other way.
should you draw some obscenities?
Yeah.
You can just go like this. Yeah. Yeah. This is pretty good, right?
Yeah.
You have just a small version of your slide. You can.
I think I'll just sit in the back and watch the chat
Yeah.
and the shared notes, so
Yeah.
I can
And just
see
have the cache box.
the cache box and have it sitting next to me.
Yeah. No, that'd be right.
Yep. Sounds like a plan.
Yeah, it's sort of weird to like how do you present to people over there? But I guess they will be seeing the video. Yeah.
I guess.
This is a funny shaped room. Yeah, it'll work out. Jesus Christ, this is. I'm glad there's a person controlling all of that. Hey!
Take it one time.
Hey, how are you?
What's up?
Ready to roll. Look at the tech.
A lot of tech. All that tech and you can't plug in your own laptop.
Yes. Well, no, you don't need to. You can, but.
I don't want to present from like a PDF deck. I want to have my own animation and all this stuff.
Somebody can take control and sharing screen. I think, yeah. The sessions are so short that any, like, you start filming the stuff, it's just eats up most of the time.
We did that.
Yeah. I think, yeah, so we did have you speak about it. Yeah.
And we had like a tiny video switching, so you had multiple HDMIs. To like flow in, prepare like.
Okay. Yeah. Yeah.
So, how have you been?
Good.
Nice. I talked to Jan in the plane.
Yeah.
And you trained the way here?
Yeah,
I ran my train to.
And the plan was going together to Vienna, but the block game. John canceled the train, so we had to go by car. Had luck with a cool ass guy at the 6 counter who gave us a BMW M3.
What did you get? Like a little box of chocolate?
It's
I think this is for
Is this a speaker gift? What is it?
yeah.
I'm not really small.
I got two, but I'm going to share it. I'm going to carry other notes.
I'm curious because I was talking to Jan about like the thing where we were going to the hard drive thing down. Yeah. And like what is dangerous to the Europe? Like what do you what templates? know if he's not the one to ask. He's the sound guy.
Yes, there is something from the
We don't have the yes, we don't have the L2, L3. Are they there?
There's some people from E3.
Okay, I'll go out or L1. Okay, I'll go try to find it. Okay, so we have to switch over to
I think you told me
I was like, I can go with
yeah. Okay, so and so you ended up and the model was not here, I could even put your address or things. Yeah. You are going to be around until you are for the time,
sure.
Is that a quick Actually, there is an interesting topic about DPIs or scalar and other. I mean, I can sound here for file. I wanted to ask Andreas if you could be logging and trying to read just in case. Oh yeah. I actually did that last time. Exactly. If you can do that again. Yeah, and DPP is actually it's not very power efficient. I remember last time you have two laptops. One is mostly died, and one was mostly died. I hope this. Yeah, hope they optimize that.哦，有点影响。我们见过吗？
没见过，
但是我没
找到，
没见过。当时是那个聊 restore 这个，然后问我想说这和一个 VDI 有啥区别，然后实际上是跟 VDI
我忘了
似乎没什么区别，我还记得比较清楚。我觉得你的一些点还是挺对，但是还是有点区别。对。Ready?
Yes. Absolutely. I'm so hyped. I'm so much fun. 你现在在哪？
I didn't have anything. What is it?
在基本
但是你记得你，但是我不记得是哪一波了。我肯定是认识你的。Sorry.
Have you seen the Tutsen track? I got the Tutsen track is a bit longer.
哦。对。华为的人太多了，有的时候大家名字就记不住。那华为很多人还见。你现在还没有？
Yeah, I don't know how I saw them, but I was online.
所以我们只是网友。我去过几次，咱们吃过几次饭。
哎，好。
你好。
忙是不是很经常在 Rust 的历史，但是我是上面开始学 Rust。I want to picture that他们不是开始从一个开始。对，然后他们推一个 GSV 派，自己做了个 prototype。
I also don't remember because I was.
那你发出来了吗？
我没发出来，因为我们 manager。
I guess Munich because I told Munich is on energy. I was told Munich was on
对，我知道。也经常见你发派时大玩
我没想到上班。
对，我是基本上就是那个 VGPU 嘛，对，我是和 VGPU。对，那 Intel VGPU 是我推的，然后英伟达现在也要推 VGPU。
哦，那现在
Yeah, so like
有些 feature，然后基本上就 hardware 有些 feature，
那你的 server 架构还是跟以前
？server 架构是一样的，对，就是那个 firmware 没啥的。
哦，那就是就是把你开源了。设计稿。怎么会设计？
过两天你会去这边报吗？
one instant, we just I didn't even reply to that. But then I spent dinner. I had dinner with him in the day. And then after
怎么弄我也不是很清楚。
he was like, yeah, so he's sorry.
到底还是那个静态分割吗？
He was like, so he tells me the problem that he. I think
对，还是
Wilson was trying to explain.
因为我们做暗显器的嘛，就是最总会想的。
So Wilson was trying to have like
这种好像不太靠谱。
educational
这个
material
可以
class.
替费事儿是可
What's
以
almost
的，
like
因为其实
they after having worked on that many years, right?
他能做他没做，
But they were expecting like
他能做
to
他
be
没做
walk through the thing, and they just saw the file, and they didn't understand anything, and therefore they were like, this we cannot do this, we cannot understand. But I was trying to explain that, you know, like we I think like step by step iterations, but you're not seeing those, you're seeing the final thing, you don't understand from class, and of course it looks like alien, right? I was trying to put that, I think it's a good idea,
对
but
吧？然后你还
I
有
don't
一
think
个
he's
大大的，
literally really against
因为
it.
这样的是没有的。
Happened in the video.
对对对对，他们很多时候就是说，因为他们是大事嘛，这样的，基本上都是客户的他是学问，就是不是说你跟说一句这个我们要这个这个东西真的跟这个要这个东西，
He doesn't see that.
他是这个样子。
He thinks the problems are going to be the logical
反正
problems.
看吧，这
So
个开源
that's why he doesn't want the complexity and he wants to be the
更好一些吧，
It's complicated to
是
be
拉
like
参与进来。
late.
看到这个，因为这个开源的应用档里面有的时候有些时候是处于这样，我们比如有大佬是挺上心的，这样，对，大佬是想推这个东西，因为照我们这个开源跟那个红帽他们搞得不太
A
好，
way to learn
他们那块儿
how
其
to
实
write these
到现在还没什么进展，我们是比较快的，我们今年
material to compare. I told him already about the value
准备这个
the value fits the
主要是还是讨
I
论，
told about
开始我们是7月份开始做，
interaction today. I already know him, but hey, you can come with another one.
这样，这周吧，看能不能发。
哦，这时候发啊。
Yeah, no. I mean,
大佬要来嘛，对吧？大佬要来，
well, when you see it from here,
大佬，
这样是。
like
当然还挺上心，
some years, couple years,
大佬是挺上心，有的又不行，你像做 CC 的就不太行，做 CC 的他们就我靠，你
这
让
些他就是挺是认真的，
啊是。
是认真的，这样你还说，
I want to say the problem.
认真的话就该。
So he feels like we can see it.
就是你想开源测试这个太难了，基本不行。
But then it's Google companies pushing for. Yeah.
反正基本上就是那种状态。你现在还是换那个，
I mean, I saw it as a positive thing, but
啊对。
你现在主要干嘛啥呀？我看以前网上都特别底层的东西啊。
There was no like
就忙一个那个
about
放心的话呢，
啊对对对，然后对对对 ，people 也知道，吹反样的。
so I agree that like
还没有到。
stands in front. I mean, if he was there, he would do the thing, right?
你考虑在那个 pack 上，就上讲一讲，
As usual, I didn't say one way or the other. The only thing that he didn't say
讲一讲。
I want this in.
他那个好像换了好几次了。
So he was saying, I want this.
so what's going to happen is he's not going to give you he's not like I get out of the free cut for that, but you can do it if you want. But you don't have to take some money.
Yeah, I know, but then I talked to him. We didn't drive it out there. Sign up with the one that
对以前那个
said
那
that
个
we can do it. And not just to
就是以前也是那个万豪，你知道吗？对，万豪一开始也是比较
to be
比
around.
较那个大势点的。其实
I think it's one time. Just the way I see it,
没有说很骗你，就是一定要对那个对头，然后把意思讲明白了就行。
and it doesn't matter if you break it.
现在已经不换这个，现在当然不换这个。
It doesn't matter.
对对对。
他这是哪儿？
他在腾讯，我就是前两天去那个这个叫什么？去那个香港跟那个大佬聊天，我还发了个这个照片出来。
必须的，我们他是比较喜欢的吧？
我特别喜欢逛大佬的，就是上次就是当时他在然后来自中国嘛，我靠，这个一堆的 trip 想办法让他们拿照相，这个我
不，这次香港也是。
香港是第二次，
Okay, don't hold to the other side.
中国现在处理还在那里。
Are you going to be around for the I will
just 这边
I will take
我是，但是我们会很多
I said help you remember conferences to be organized or whatever program. But we don't have questions, I will talk with you. And you're around.
你们是未来的之前大家想未来的你想做的 Windows 嘛，Windows 好像是已经有 LPC，但是这个不是我给的，知道就行，应该是这个因为 Apple 专利情况下它可给是有的，但是不知道是什么，他们肯定有一些 RC 的几个。但是我不负责那块，我知道，我还是 Gas 的，
就是WSR 里面。
对，WA 那个数据
啊，
在微软现在。
对，在微软。
但是 WSR 微软多上。
So what's the first step of 上新？怎么样？微软是这样的，微软我觉得现在它有新无力的，因为它的那个 Linux 的做的特别开，很多产品里面都用 Linux。但是呢，其实是
It's on the
这个当然的这个科诺的打包可以不在我们组内，但是科诺的 feature bug 不在我们组内，就是说相当于是只有中级小组10到20个人看那个 feature bug，其他的人都是怎么打包啊、测试啊。
tutorial 好多人在跑那个本来是在微软的，还有看过 I thought it was
Windows 才是，但我还不会还没有。它跟微软相对来讲，它就只有CPU 调度、中断。
不，其实很简单，这有些厂现在没有啊。
是啊，但是也有人做这个适配的，就是你看看，现在我们只有10几个人，这个韩国的干的很多是开着上面 WSA， 然后除了还有一些八分的东西，就这10几个人在直接如果说我们突然间换了一个，我突然间比如我们像现在 QEMU， 那势必说原来的开播的人，还得要招 QEMU 的人，还得招那个QEMU 的干子的人。这个，所以说我们也觉得是。
4 months since the last it's like this game was so I went to a shop, guys, right? And had my stuff, and then got it. We really like to see the full thing, so when you put your priority, so when you go build we froze it all, then it's like I put something and
张毅说，所以我们知道很多人就是韩国人开，我们先从
非常高兴这样子。
OK，
可以。
你在北京吗？
没有，我在北京，我在放森林。
哦，那你跟他记。那你原来在一块儿是吧？
对，我现在一块儿。
发现这有个 WiFi 叫做王叔叔蒸菜。
啊？菜鸡王叔叔。
It should be here. I think. Let me see.
这个好像是那个一个梗是吧？
我也不知道，反正我就是以前打游戏给我菜鸡，给我这个，我一直用这个。
我得。
It's really about clearing out misunderstandings.
you know what we're talking about? Yes, I know him very well. He's my neighbor as well. Oh, he mentioned there was like 5 so close. And, yeah. Oh, yeah. Okay. I didn't knew that you're Denmark. And Ricardo or some of like those
We'll see what happens. There is tension. There is tension.
Do you have some of the talks?
This year I just have the panel.
So in Android and Rust strongly
So I have to say a couple of things when we start now in a couple of minutes.
Yeah.
Yours are already uploaded and processed. Okay. Hello, everybody. Thank you for joining the Rust MC one more year. I have to say first a couple of things. One is to thank you to the sponsors that you see here in the slide. Without them, we wouldn't be here. So again, thank you all the companies that support LPC. Also, a quick reminder. We have a code of conduct in the conference, so strong technical discussions, arguments are all fine, but of course, please keep things civil, and yeah, please read that slide. I will leave it there for a few more seconds. Yeah, and we are going to start today with tooling, with Coccinelle for Rust, that Tathagata is going to present in a moment. Yeah, please, as a reminder also, MCs, maker conferences in LPC are meant to be, discussion-based, so there is going to be presentations, but please feel free to, unless the speaker says no, please feel free to interrupt the speakers and have a discussion. That's very, very useful for us, and to have a Rust MC next year as well. So with that, let's get started. Tathagata, if you're ready. Thank you.
Good morning. So I am Tathagata Roy. I am currently a first-year master's student at VU Amsterdam, and I'll be talking about Coccinelle for Rust, which is a tool which I've been developing with Dr. Julia Laval. So before I get into what it is, I'd like to speak about why we need it. So huge code bases such as the Linux kernel have a lot of code. Linux kernel, for example, has 23 million lines of code, and more than half of which is just drivers. So one of the main challenges is collateral evolution, which is when a main part of the C API changes, the Linux drivers need to update automatically, and if more than half of the half of the kernel code is drivers, it would be hard to manually change everything, especially in a timely manner. So Coccinelle for C was made to help with automating the process. It provides semantic patches which give a form of generalized view of the diffs we get, and it applies them to each and every file in the repository. So there's a small example, and Coccinelle for Rust is the version of Coccinelle for C, but for Rust, as the name implies. So this is an example commit in the Rust C repository. Here, as the commit says, it changes, it just changes calls of type of into bound type of. So if we analyze the patch properly, we see that there's two main diff lines, and if we see them even more properly, we see that the actual change is just two function calls in the highlighted lines, which is this. And now if we want to show this as a semantic patch, we are going to have to generalize this even further. So this, for example, just shows the first difference in the patch, but we want to generalize it for all diffs in the repository. So for that, we notice that type of is being called from a variable, and it also passes another set of arguments to it. So we define two meta variables, tcx and arg, which can match any other variables with the with itself. So for example, here tcx can match any variable, or in this case an expression, and arg can also match any other expression inside it. So this just says that it removes everything of the type expression dot type of expression, and then it records what tcx is and then replaces it with tcx dot bound type of arg subs identity. And in our example, this patch updates over 200 call sites, which is like about 60 to 70% of all the actual things in the diff, but yeah. So the latest developments in Coccinelle for C, in Coccinelle for Rust are is the CTL engine, which is the same engine that Coccinelle for C has. What the advantage this has over the previous ad hoc kind of matching is that it gives a mathematical and clear way of proposing what changes we want in the files that we want to transform. But the problem with that is that Coccinelle for C, which is made for C, the control flow is quite simple comparatively to Rust. Yeah, comparatively is the keyword. So for example, this is a simple C program, and as we can see the corresponding CFG. So here, if you notice, the F call here is just one single line in the CFG, which makes sense for C code, that there will always be like a straight line of computation when calling fcall. But the moment we switch to Rust, things get messy. That is, we can have if expressions inside function calls, which since if expressions are an expression, since most things in Rust are an expression, and this, though it causes problems there, it will help us later, which I'll show. So we had to find a way to actually incorporate the Rust AST, to convert this into a proper control flow graph. So yeah, and Rust can get really weird. So for example, this is a completely normal piece of Rust code which compiles. Yeah, that's weird. So we have to account for all this sort of, I don't want to say nonsense, but yeah. So the So the job we want to do is represent the Rust CFG from the, not represent, to represent the Rust CFG from the Rust AST, which is, without remaking the compiler again, mainly because the Rust language is very new, comparatively. Please don't kill me. So the language changes very frequently. So if we make a handwritten parser, we may have to. Is it okay? Yeah, so it changes continuously. So we don't want to continuously build Coccinelle for Rust and a parser with it for Rust, which was actually what was done for Coccinelle for C. But C is an old established language. So so for example, how do we convert this AST into a control flow graph? So the algorithm for that is actually pretty simple. We just recursively iterate through each of the children of the nodes, and just like for non-branching nodes, we just sew them after one another. So the control flow goes like this through this AST. And this is a CFG for this specific statement, and for a normal statement like fcall 10 without any branching instructions, the CFG is just straight. So not a problem. But the problem arises when we want to do things like this. When there is a branching statement inside fcall. And again, this is just an if, but you can also put while expressions inside function calls, which again makes no sense, but because while always returns units, irrespective of how we break out of it, so it should, it doesn't really matter in that case, but we have to account for it because it's a part of the AST. So this is an example AST of the given if condition, and we want to form a CFG out of this. So to do that, we modify our algorithm slightly, which is here. While iterating through the children, we check if the current expression is an if expression, and if it is, we use the fixed Rust AST if expression anatomy to branch it. So for example, it always branches at the condition, and there's a true branch and an else branch, and after it branches, it goes to two branches and merges at the end. Since if is an expression, it always has to return something, so the control flow at the end merges into one, as it's shown by the second blue circle towards the end, and it branches at the first blue circle. So when we combine this together, we get what we want. For sequential nodes, we get a straight line, and for branching nodes, we can just branch it like this. We just put different conditions for the things we want to check, if it's an if expression or while expression, something like that. So yeah, and we can do the same thing for loops and jump statements, really like any other control flow that we want to do, if we have the AST, which we do, since we are parsing it. But there are a few problems with this approach. One of the problems is, since Rust is a function, I don't know if I can say Rust is a functional language, since many things in Rust are functional, the AST gets really long and really complicated. So for example, this simple piece of code has this control flow. Yeah, not pretty, but, and as you can see, there's multiple lines from the same node. I'll just come to that in a moment. But yeah, one of the challenges is to, like, this is just for a small piece of code. So for huge files, the AST becomes really complex to store and navigate through. So one of the ways to mitigate that is compressing the ASTs. So in Rust, there's these thin branches we find for different nodes, and we can just losslessly compress them into one single node, and like this thing becomes path expert path segment name ref ident can all be compressed into one node, and anything that comes after this, if it's branched, you can just branch them as children of this compressed node. So yeah, and the second problem we find is how to represent meta variables. That is, yeah, so let's say we have this piece of code. The control flow of this code will be this. would ideally be this, but we add some extra edges to it. Yeah, we call why I'll just come to it in a moment. The blue edges are what we call sibling edges because they do not go to the children of the AST, so do not go to the next AST per se, but go to the next children of the parent of that node, which is a fancy way of saying siblings. So, and if it doesn't have siblings, it just goes to the next cousin node. So for example, here the sibling of F would be H, the sibling of G would be this comma right here, as we can see. Why this helps us is if we have to match a patch like this, if we match F, we match, since we match by control flow graphs, we match F and the open bracket, that's fine. But when we match X, X matches with G20, but the next node it tries to match, according to the semantic patch, it's a comma, but according to this graph, it says it's G20. But that doesn't match because we want to match a comma. But since X is a meta variable, we take the special node here and match the comma. So the key takeaway here is meta variables need a more complex CFG to navigate through. It is possible to backtrack and check to the red nodes, but that makes no sense. Yeah, so the other point is when I talked about CTL formulas, the mathematical formulas which show which represent the semantic patch, they can get really complex really fast. So for example, this earth-shatteringly complex piece of code, which looks like, I don't know, it makes some huge computation or something, is just this. Yeah, not really very complex, but it is when we want to debug it, since thankfully the Coccinelle user doesn't have to go through debugging this huge piece of code, but we have to so that is kind of a challenge when there's one term missing in all those. So we need to find a better way to show these CTL. So some of the other developments are ellipses. The ellipses match an arbitrary number of nodes between two given nodes. Why which it has to be like given that the two nodes are reachable by a path in the control flow graph. But why do we need this? So let's take this piece of code, for example. We make a buffer. We had a buffer previously, and we had to flush it each time we write something to it. But let's say in the new version of the code, we have a buffer which flushes after every character. So in that case, we would want to remove all the flush statements because that would be just extra statements. So, or it may even break in some cases, I guess. So for that, we would use a patch like this. So for the first two statements, we remove buffer make and replace it with make auto flush. Again, this removes all statements of this form, since this has meta variable I and expression options, so it doesn't matter what is in here. And then we use ellipses, which takes an arbitrary number of path and which takes an arbitrary path to the node I dot flush, which is the same variable as here, and removes the whole line. That is, it would remove all versions of a dot flush that come after buffer make auto flush, given that there is a path to reach it. That is ellipses, and the final new feature that we'll discuss here is disjunctions. This is not new per se, but I will come to it. It is a conditional matching construct, which means that it can match a bunch of statements, either or a bunch of different statements you want. What I mean by that is, for example, if we have these two pieces of code, we have the same thing as before. We have a buffer, but this time we want to flush it after each new line. So all the statements with a.writeLN which write a new line will get flushed automatically, but the ones which do not have an ln may not get flushed. So we have to flush them each time we write something. Please feel free to interrupt me if there's any questions. So this is the semantic patch for Coccinelle for Rust to modify these two statements. So the first two lines state that we change all buffer make instances to buffer make NL flush, that's new line flush. If we find any right, and after that we go through ellipses, and if we find any I.write x, that is, if we find any write without an ln, we add a flush. If we find a write ln with an I flush after it, we delete that because ln flushes it automatically. And if we have just I.write ln without I.flush after it, it's just okay. We don't change anything, we only change this stuff in case of the last branch. So there's three possible patches here, three possible paths, and it matches any one of these. So the thing about disjunctions is that it, like in this example, it applies this patch on all the on all the possible paths that match, but it is possible to, I mean, not yet in Coccinelle for Rust, but in Coccinelle for C, it is possible to just take the first occurrence or something, or maybe the last occurrence, whatever we want. Yeah, so, but this was like old news, it's like 1 year ago. So the new things that we developed is that previously disjunctions could only be, how much time do I have? Disjunctions could only be expressions or groups of expressions, which severely limited the number and types of disjunctions we could take. So for example, we couldn't have disjunctions of types. So yeah, this is what we could do previously. We could only put expressions or groups of expressions in disjunctions, but now we can put, for the most part, tokens if they make sense in the whole disjunction. Like if they make sense branch-wise. So this would mean T1, T2, T3, T7, and this branch would make T1, T2, 4, 5, 6, and 7. But yeah, this asterisk is important here. So previously, since we used Rust Analyzer to parse the Coccinelle, the .coxi file, because again, as I said, we do not want to remake the parser again. To parse the Coxi file, we had to do some weird stuff, like to parse the disjunctions, we had to put in if statements instead of the disjunctions to make it parse to be able to read the thing and put it into Coccinelle. But that wouldn't work in cases like these because you can't exactly put let x if something, then type 1, if something else, then type 2. Does not make sense. Similarly for function arguments, especially with the ones with different numbers. So yeah, this syntax makes no sense. So we had to find a way to actually incorporate this. And I know that I generally scream profanities at macros all the time, but macros help us here because just like everything, macros are an expression too. And as I said before, expressions can be put almost anywhere in Rust. And as an added bonus, macros can also represent types. So one of our problems is solved that way. Yeah. So for example, this thing turns into a macro here, and since the macros can have anything inside them, we also get access to nested disjunctions, which is helpful. Again, the only problem is parsing them again. The only problem is forming the semantic patch out of the weirdly parsed macros, but at least it makes it possible to parse the stuff. So what we do is we take a disjunction like this, and we turn it into a huge macro, and then get all the possible paths from the macro branches and parse them separately, and then use an algorithm to merge them all back into one big parse tree, and then turn it into a and then use Coccinelle for Rust on that. So, yeah, but we still can't do some things. For example, disjunctions can't be put in place of attributes. So, yeah, we can't do things like this, or we cannot put it in enum variants. And again, this is not really hugely necessary right now, but we are considering other alternatives to this. Yeah, and just as a side note, disjunctions are still a work in progress. So some things are breaking, but it should hopefully be fixed soon. But disjunctions is the only thing that's causing problems. All the other things work fine. So some of the challenges that remain are, as I said, macros. They're a pain in the AST. I've been waiting to make that joke for some time. And the main problem with that is because macros aren't formatted properly by rust.fmt. I don't know if any other stable tool does it, but we have not found any tool that could do that properly. So we are kind of confused what we should do, and any suggestions are welcome as to how we should format macros there. We did find a bunch of rules to format all macros like a general way, but it was not very good for some macros. So yeah, we are not sure about that. And parallelization is another problem because the Rust Analyzer library we uses the Rowan syntax crate, and the syntax nodes it provides are not thread safe, which means they do not implement the send and copy trait, which makes it really hard to parallelize since, again, we are using the Rust Analyzer crate, so we'd have to modify that. And now I come to the possibly an interesting part of the presentation. One of the possible applications of Coccinelle for Rust would be to address the problem of evolving Rust code with the changing C code. The Rust code in the kernel depends on the C code, so any changes in the C code must represent or must reflect the changes in the Rust code, in the Rust bindings and the abstractions, such that they keep up with the newer constraints. And maybe it is, and maybe we can say that it's hard to know who would make the changes in the Rust file once some major breaking changes are made from the C side. So Coccinelle could potentially help with solving this issue, and it would reduce the burden on both the C and the Rust developers. So what we propose is, this would be the ideal workflow here. The C programmer makes some major breaking changes, and that creates a bunch of diffs, and then a specific tool or a human analyzes all the diff files and creates semantic patches out of that, which are then again transformed, which are then used to transform the Rust code with Coccinelle for Rust. But the problem with that is that, again, while this is an ideal scenario, a tool which successfully infers the semantic patches just from the diffs would be very complex and formidable, if at all possible, to make. So instead, we settle in a midway position. Whenever the C programmer makes some changes, that creates a bunch of diffs, but the C programmer would also provide a small file called the diff description. I'll just come to what that will contain in a bit. And then that diff description file, along with the diffs created, are analyzed by a tool or a human to create semantic patches. And those semantic patches are used by Coccinelle for Rust to change the Rust files. So that would help with not going through manually and changing the Rust files each time a breaking change is made in the C side. So what I mean by the diff description is our newer constraint set by the C code. So for example, if some FFI types are changed where the constraints of a particular pointer is changed, for example, let's say we want the pointer, we want to tell Rust that for the pointer to never be null, or maybe we can only dereference it a couple number of times so as not to break any borrow checker rules. So we have to find a way to encode that in a diff description file, and then we input that to, for the first few patches, it would definitely be a human who would check those diff descriptions and the diff files, and then they would create a bunch of semantic patch files for Coccinelle for Rust, which would then be fed into Coccinelle for Rust, and it would change all the files in the Rust side. But a problem with that is that we are not Rust for Linux developers, so we do not have a lot of idea on what are like the major types of constraints that are required to enforce type safety in the Rust bindings and abstractions. So we would kindly request the people in the audience who have experience with making Rust bindings and abstractions to maybe provide us with some examples or changes that occur more frequently in the C to Rust code, so that we can assess the feasibility of such a tool to evolve Rust code along C code in an automated fashion. And at the end, thank you Collabora for supporting the development of Coccinelle for Rust. You can find the links of the tool in the page mentioned here, and please feel free to reach out to the contacts at the end if you have any questions or questions or suggestions. Yeah, thank you.
Just as we can use Coccinelle for also checking for grammar for correctness on Linux, can you use Coccinelle for Rust for similar things in the Rust code as well too?
What do you mean by grammar?
So like we have rules to check for APIs. Is there a directory that allows us to also write Coccinelle patches to check for consistency for agreed upon rules that we establish?
Yeah, like if there's specific things you want to check that I don't know, maybe there's some function calls you want to be there to maintain consistency after other things, something like that. Yeah, that's what it was made for. So, yeah.
But do we have that in the kernel right now for Rust?
Right now being used?
For most stuff, we don't need to, because we can encode all of that stuff in the type system. So when in C, you would have to we have to call this before this. In Rust, we can just make it not compile if you don't.
Couple quick questions. Sorry, go ahead.
Go ahead.
Okay. So I see that you are using the same as Coccinelle for C expression identifier and so on. How do they compare to the things that you have in the macros, like ID or TY, and whether it's possible to, in the future, maybe to use the same things that you have in macros also in Coccinelle patches?
I'm sorry, I didn't understand the question.
You have identifier, and in the macro you would have ID, or you have expression in macro, you have EXPR. But in Rust macros, you have also like the types, so TY, path, and so on. I was wondering if it's possible to add more things from macros to the Coccinelle matching.
Yeah, we could.
By the way, there is seats around here if people want to join here. So quick 2 things comment. One is, do you expect to have this have you talked to the Rust project or to Rust app or whatever for distribution so that people can start maybe using it easily, or?
No, we have not started any discussions on that yet. Okay. But if anybody wants to test it right now, they could just compile it from here. But again, it would be better if there's a way to easily get it. So, yeah.
Another thing you said, human or tool. I guess you tried already to use an AI or something to generate the semantic patch from the.
No, not yet, because we don't have a lot of good examples for the changes that the C changes that actually break the Rust code, and so we don't have a lot of good examples for that. So as soon as we get our hands on some of those examples, we could try to start making a tool, which would. I mean, Coccinelle for Rust already automates some tasks. If you also want to automate the automation, sure.
Yeah, that's what it was.
Yeah.
Okay. Thank you.
Thank you.
So next we have Benno with an introduction. If you are new to Rust, it's going to be a nice topic to hear about. Sorry. Oh. So I can see you, Benno.
Does my mic also work?
Yeah, perfect. It works perfectly. You want the presentation, right? Not the handout. Presentation, right?
Yeah. Yes, I want the presentation, yes.
Okay, can you see? Let me see.
Yes, I can see, but I think you have to give me a presenter.
Yeah. Can you control now? Perfect. Yeah, it works.
Seems to work.
Okay, so the next topic is going to be an introduction to Rust. So if you are new to Rust, this is going to be very, very nice to watch. So thank you, Benno, for presenting. Benno was meant to be here in person, but he, due to the transportation crisis we had in Vienna, he couldn't join. So sorry, Benno, you have to again present virtually. Take it away when you want.
Yeah, sure. So thanks for being here. So first, I'm going to give a bit of introduction to Rust, because well, we of course have some very important goals to achieve with Rust. And first of all, aside from the memory safety promise that we get through Rust, we also hope that Rust is able to reduce the number of logic bugs, as well as reduce the number of mindless checks that reviewers have to go through that might not be easily checkable by other automated tools. And also to simplify the work of driver authors, so they don't have to think about more complex patterns. And so there are a couple of things on the Rust side that help with achieving these goals. For example, replacing manual coding conventions by compiler-enforced guardrails. So we essentially give the users an API that is hard to abuse or to misuse, and then they can easily use the API without having any problems. Exactly, designing robust APIs with good types and hard to misuse. And additionally, also having good documentation is something that we strive for with Rust, because the kernel is famously poorly documented, and often is said like, just read the code because it documents itself. I don't know about that. First, here's our outline, or here's my outline for the talk. I'm going to introduce some Rust basics. Then we go over enums, because they are very great in Rust. The enums are one of the best features. Then I'm going to talk about encapsulation. That allows you to hide implementation details, unlike C, where essentially everything is public. And then I'm going to go over traits and for further concepts. I might not have enough time for the whole talk, so if I run over, Miguel, just stop me. And if any of you have any questions throughout the talk, just feel free to ask them, because this is designed to get you to understand and learn Rust. And if I'm unable to explain them to you, then just ask the questions. First, here we have some C code. I've decided for 2 different color schemes for C and Rust, so you can easily differentiate the 2. And we want to have a struct foo with an int value, and in Rust you just declare it like this. You have the field name before the type, and in Rust we have something where we are able to associate functions to a type. So we now have this new function here, which you also might have on the C side, some constructor function, and we can call this function then with foo : new, and this allows us to better namespace the functions and associate functions that make sense for only one type to that type, without having to prefix, for example, this foo new or something like that. And there's also an alternative way to declare a struct. This is called the tuple struct syntax, where we don't have named fields, but rather the fields are just sorted by index. And we use this when we only have one field, for example, or fewer fields where it doesn't really make sense to give it a name. We also have now the same function that we have in C. This foo value is now the value function here, and it takes this ampersand self. This is a reference and essentially the counterpoint to the C pointer, although references have much more requirements on them. For example, they must point to valid memory, and it must be dereferenceable, have to be aligned, and more conditions for that. And then to access the single field that we have here, we just use .0, and the field here is just has the name 0. To call this function, we have the advantage that since we impl this on foo, we can call it using the dot syntax here. So because we take here the self parameter, which is before we had just ampersand self, which is actually a shorthand for self : ampersand self, because this is very common to use. And using self here is highlighted in a special color because it's a keyword, and this is the receiver type of this function. And this is what allows us to use this syntax. So this is essentially how people might recognize it as a method syntax from object-oriented programming languages. But in reality, this is just syntax. So it doesn't have to do anything with inheritance or any of the other object-oriented stuff. It's just using this syntax, which is very convenient if you associate functions to data. If you want to see more, then I have included links to the Rust book. So in this case here, this will lead you to one of the introductory chapters if you want to read more about Rust basics. Now to go to enumerations. If we start off with our enumeration in C, we have some driver state where we are either disabled or active. And we have a do work function where we take our state and maybe change it. And then we have this name function here. It might not seem very obvious to take here a pointer to the enum in C, but I wanted to mirror the Rust side where we do want to take a reference here. And here we just do a switch on the disabled and return the name of the current state. And in the Rust side, we declare it in a similar fashion. We have enum state. We do have different naming convention here to not use the screaming snake case, but instead just this case. And for the name function, instead of the switch, we're using the match statement in Rust, which essentially does the same, but is more powerful because it is allowed to match arbitrary patterns, which are very important in Rust. So now this looks, I would say, rather similar. And if you just see that, like, we have these arrows instead of colons and so on. And also you might notice we're returning a string here, but there's no explicit return statement here. This is just because the last statement in a block can also be an expression, and in this case it's just a match expression, and it returns the string here. So there's an implicit return statement which we don't have on the C side. Now, if we want to introduce a new state to our enum, then we can just add in the C side. You have to add it in the next variant, because otherwise you will mess up with the potentially with that active is now not value 1 but value 2. But in the Rust side, we can just insert it in the middle without problems. Now we have added our waiting state. But let's imagine that we did update the do work function, but forgot the name function because it is somewhere else. And then in the C side, we implicitly now return unknown state, which is probably not what we want. In the Rust side, we're going to get a compile error because the waiting state has not been covered in the name function. So you're not able to forget that if you add a new state to your system to handle it. If we now add waiting here, then the compile error goes away. And in the C side, you might forget this for different enum matching enum matchings. Yes. Rust enums also have an additional benefit, which allows them to carry data. If we add a reason for waiting in the C side, so then we have to switch to a struct for the state, have a state kind, which was our state from before, and a wait reason, for example. And now we have the state kind, and if the kind is waiting, then you can use the wait reason to determine why we're waiting. And this is a bit problematic because you can also access the wait reason even if we're not waiting. On the Rust side, however, this looks like this, where we have our wait reason inside of the waiting state. And you're only able to access the wait reason if we are actually waiting. If we're disabled, we don't have access to this field. So if we now look at what we in do work, if we match our state here, then if it inactive and disabled, we don't have the reason field, but waiting, we actually do have access to it. And lastly, I'm going to go over the two most important predefined enums from the Rust standard library. The first is the option enum. This is to make a type nullable. So if you don't have an object of type T, then you can use option T and express it by that. And as you have seen before, if you match an option, then you only get access to the value if there actually is a value. If you have none, then you have to check for that. And also there are a guaranteed optimization. So if we have a reference which is guaranteed non-null, then option of that reference is still pointer size because the non variant can just take on the 0 bits. The second most important enum, or rather, is the result enum. We're using this for error handling, and it has two variants, OK and error. And again, we can either have the result that we expected from the function, or have an error returned. And we cannot forget to check the error because the compiler warns if we forget to handle the error variant. And if you're coming from C, then this might feel similar to the error Perturb API, because there you also can essentially encode two different values in one type. And if you want to read more, then you have some links here. Are there any questions at the moment? All right. Next up is encapsulation, and this is known in Rust as visibility. So if some piece of code is visible to some other piece of code, and everything is private by default, so you're not allowed to access fields of a struct in a different module, and you have to explicitly opt into exporting items using either pub for a global export, or pub crate to only allow the crate that you're currently in to access the item. Structs can only be constructed if you have all fields are visible to the current module. So for example, if we have a module config, in which we have this struct config where we have a public size but a private name, then if we have a different module that uses this module, then we cannot do this. This will be a compile error because the name field is private. The way we solve this in Rust, if we want to have a struct that has private fields and we still want to construct it outside, is if we just create a public constructor function that takes in all of the fields that we want to set, and then returns the value here. Note that this self here is a special type that always refers to the current implemented type. So self in this case is a type alias of config, and here as well we can use self here to construct config. This is particularly useful if you want to then just rename the config and you don't for example have access to an LSP. Then you can just rename config here without having to rename the field here. And also later, it will become more obvious why we actually need a self type. But now we can use this function instead of using the direct construction method for structs, and the error will go away. And then we have this. Also note that here, again, we're using the implicit return without a return statement. With this added visibility, we're now able to take a look at the new type pattern, which is rather important to be able to. So we are wrapping an existing type in a new struct where the single field is private, and we explicitly choose which operations are exported because the field is private and you can't access it from outside. And we are also able to add new functions and methods to this type, so it enhance the capabilities. So, for example, if we have a struct handle here, which exposes two operations like foo and bar, then we can create a new type of this handle. So this is a private field because there's no pub before it here, and we're for example only exposing the foo method, and bar we're not exposing that. So you now can't call bar on this type. This might be useful if you want to have an opaque API where you return something and the user can only do something to the value that you want to do it. So, for example, if you return some file entries that you want the users only to write to, for example, then you can remove the read functionality using the new type pattern. And another thing, so yeah, here's the link if you want to read more. And another thing that the new type pattern allows us to do is mark data untrusted. So this is something that came up at our previous conference at Cangrejos, and Greg, I discussed this with Greg. We want to mark external data, so that is untrusted from hardware, for example, or from user space, so that people don't use it without validating the data first. And we can use the new type pattern in this case. We just have a generic struct, so this T here means that we have that you can insert any type here, similar to templates from C++. And then you have the field here private, and we have no way to access the inner value publicly. And we have a creation function for the value. And then we have something that we have a validate function where we return a validated object here or an error using the result type. And this generic V here is constrained by a trait, validate, which I will cover next, what traits are. And using this, we access the value here. So this is inside of the untrusted, so we can access the self.0 here, but outside, no one is able to access the value. If you want to take a closer look at the current patch set, it is linked at 5, but I haven't rewritten it yet to use this exact way to do it. And now to go over to traits. Traits are the way to define shared behavior in Rust. They can be used to require that a generic type offers a certain operation. So, for example, our validate trait, we want that every type that implements this trait exposes a function called validate, which takes untrusted data, which is of the type T that we create here, and it returns the type that is implementing it. So in this case, self does indeed have a bit of different meaning because it refers to the type that is implementing this trait, and maybe we also allowed to fail validating this thing. So now if you want to implement a validate for your type, then you, for example, take data from just a slice of U8. So this is referring to just some amount of bytes in memory. And then we can put all of our validation logic here. Reviewers will be able to scan for that and have our untrusted data marked in the code. Using traits also is done for different purposes. For example, there's the send trait from the standard library, which is used to mark which types we can send between different threads. And also there's the sync trait, which allows you to share data between the threads. And using those two, we can prevent that locks are unlocked on the different threads that they were previously locked on. So these are also quite powerful tools. And for example, we use traits also for instead of vtables, or rather turn traits into vtables to put them into the C side, because they allow to bundle shared state, or rather shared behavior into a type. Then I still have some further concepts that I want to brush upon. We have ownership on the Rust side that allows us to only ensure that values are used once, or rather, if we have ref counts that certain objects own a ref count, we can express that in Rust. Then there are lifetimes in borrowing, which means, for example, if we have an object that lives for a specific amount of time, the compiler is able to know that it lives for the specified amount of time. And if the object is used afterwards, or after the object has died, then the compiler will emit a warning. Then we have declarative and procedural macros, which are very powerful, but probably difficult to go through in a 30-minute talk. But they allow us to extend a lot of our functionality and are very magical if you learn about them for the first time. And then we have something in the kernel. You often need that objects have a stable address. For example, mutexes. There is the concept of pinning in Rust to facilitate that. And finally, we have documentation that we are able to put directly into the code to make it easier for people to understand those things. In addition, we also have examples in the documentation that are converted to K-unit tests. So we ensure that our examples are not stale and continue to compile, as well as enhance the documentation. So are there any questions about these topics?
Hi, so I was going to ask about, if there's any plan, like, we can improve the readability of the Rust code for C developers. Because for me, I'm a C developer, and I learned Rust actually last year, I would just say. So what I notice is is need a very large amount of the time to ramp up actually. So mostly I have to make careful notes, and if I didn't come back for 1 week, I totally forget what I learned from the last week. So there's a gap of ramping up. So what I was thinking is is there any plan we can keep a boundary on top of that boundary we're trying to think of readability for C developers so that they can easily understand what they are doing there. And, I think that would be much more helpful for people, who don't have a lot of time to ramp up. Because for me, I spent 2 weeks, and then I finally start to understand, okay, what the code is doing, and, and then I start to write my own kernel modules, doing all this magic thing. But I would just say, it's still a huge gap for ordinary C developers to really get into Rust, I would just say. Yeah, so that would be my first question. And the second question is there's a lot of components actually reviewing the mailing list right now. So I was thinking is there any plan for the unit test, or Rust can do this by itself, the compiler can generate all these unit tests by itself. Yeah, so that's my question. Thanks.
So for the first one, I'm having a bit of difficulty exactly understanding where you're having difficulties with. So is it the syntax, or is it just the complexity of the language in general, or where are the pain points?
Yeah, I think it's mostly the language grammar, actually. And then after I manage that, I think he's fine. So I can like write modules and know how to write all these bindings and expose whatever I need. And then I try to get deeper and the Rust kernel memory allocator and all these things. So, but still there's a lot of magic macros in the Rust in Linux. I'm not totally knowing like what they're doing. So there's a huge gap there, right? So, and also like I noticed like when reviewing patches or patches check-in, so like there could be different way to write the code, right? So, but if you write it in a very like shiny and magic way, so it's super hard for people who don't have any background to understand. Yeah, go ahead.
I just want to make a comment about the macros. I think you should approach them in the same way as you approach C macros. They are magic and can be difficult to read, and you sort of have to wrap your head around it. Good thing is, like, if you have a proper editor set up, you can put your cursor on it and say expand, and you can see what code it generates, similar to C.
So I think that we can, for example, have like a cheat sheet if you think that that would help. So, for example, writing how you would write something in C and then have the same piece essentially rewritten in Rust, how you would do that. But I think that also has like certain things in Rust. You have certain things you only have in Rust. For example, pattern matching. That's not something
I agree.
that you have in C.
Yeah, because I really like
So
yeah. Go ahead. Sorry.
No, go ahead.
Yeah, because I really like the language. I would like to see it, to be successful in the kernel, right? So I was just thinking from the, from my own experience, actually. So, yeah.
So I don't know. Have you read the Rust book, or how did you learn Rust?
Actually, I read the Rust book first, but for each chapter I have to make notes. So I noticed, like, maybe many people have similar experience like me. Like, next week when you come back, or you are busy on something, next week when you come back, you totally forget what you learned from the last week. So in the end, I decided I have to spend like at least 1.5 hour per day and make notes. And then like I reach like the 9th chapter, and then after 9 chapters, I start to really feel like, oh, I can read, I can write Rust code in the kernel like that. So that's the gap actually from my personal experience. Yeah. So because I was thinking like how to. Yeah. Go ahead.
Maybe we also want people to take notes, because maybe that helps the learning process and not do that for them. I don't know. Maybe it would also help to give them notes, but in my experience, when learning, it always is better if you take your own notes, for example.
Yeah, I was just thinking like how to attract C developers as well. I mean, at least let them understand what the what the patches they're doing. I mean, so I like the technology. I know what kind of problem is solved. It's really helpful, I would just say. So I was thinking like if we can improve in marketing, I would just say, right. Thanks.
I would say also, don't be afraid of, in the beginning, now that we don't have yet any Rust users, don't be afraid to put code into the kernel, make mistakes in the beginning. I think it's part of the experiment, part of the learning process that we all have to do. So I would encourage people to play with it, and that's how it comes. We have also...
So you asked about unit tests. So I just want to quickly make a note that we have 2 kinds of tests. You can mark functions with tests, and then they're executed as host procs. So if you have stuff that's not tied into the kernel, you can run it on the host and test. We have all of our examples in the documentation are executed as KUnit tests. So you can go make KUnit or whatever the target is, and if Rust is enabled, KUnit is enabled. All of those are run as KUnits.
We run a bit of a, RustDoc for user space does that. So we have something that David Gao was going to take. We convert magically the examples into KUnit tests, and they run in the kernel. And for the other one that Andreas mentioned, we plan to also run them in the kernel, so that you can also run call kernel APIs as well in those other kinds of tests. So it's a work in progress, those other ones, but it will be there. And we have a question from the audience. Can you, I don't see the name, sorry. Jenny, can you please turn on your camera and speak?
Yeah, sure.
Yeah, thank you.
Yeah, I'm starting the webcam. Hello, Ben. Thanks for your talk. I'm not a user of Rust, but your talk seemed interesting to me. So I would like to ask if Rust has the concept of pointers, and if yes, how can we relate it with?
So you're asking about different kinds of pointers that Rust has?
Yes.
Okay, so Rust has several different kinds of pointers. I already mentioned references, but also, for example, box for data that you want to keep alive indefinitely, because references are always tied to the lifetime of the object. But with box, you store the data on the heap, for example. But we in the kernel also have other kinds of smart pointers. For example, arg is using the kernel ref count t to ref count the value that it has. So you're able to share values throughout the program using arg. We also have aref for types that are reference counted on the C side already, and that you want to reference directly. So we have many different kinds of pointers. If you do you want to know more, or does that answer?
Thanks for explaining.
Any other question? This is the chance to. Sorry. Any other question? This is the chance to ask an expert on Rust.
Yeah. So you mentioned in multiple cases in your examples of the implicit return statement not being necessary in the code. Have you found, in my personal experience, I've found that code tends to be harder to debug and harder to reason about. So I prefer to put explicit return statements. Have you found the same thing, or do you really like the implicit return statements?
So I really like the implicit return statements when designing the slides, because I rarely code in C. I forgot the return statement in C because I think it makes it essentially it removes a bit of noise if you only have, for example, a single line that returns something. Then I think it helps. In certain other cases, it might be difficult to learn. For example, if you're starting out to see where the return statement is. But if you have some experience with functional languages, then I think it will. You already know about implicit returns because there you rarely have return statements. I don't think that it has led to many problems in the real world for us at least.
Yep.
But also I could imagine that if a subsystem really wants to have explicit returns, then I think it wouldn't be a problem to allow them to have that.
So I missed the beginning of the talk, so forgive me if you've already talked about this, but could you go a little bit into how different kernel Rust is from STD and how different the tooling is? So like, does Clippy work? Do we use Cargo? How many of the core types are implemented?
Yeah, Clippy works. We don't use Cargo. I think if you want to know more about the build system, you rather ask Miguel because I'm not an expert on that. But we're directly using Rust C. Rust Analyzer works somewhat. It has some problems detecting certain errors at the moment, but I think we have some people working on that. But for example, auto-completion and jump to definition work also across different files. So that's nice. It has certain differences to standard or user space Rust, because in user space you, for example, don't have any allocation errors. You just panic if there's not enough memory, and that of course is unacceptable for the kernel. So we have to use a different allocator trait. At the moment we're in progress of removing the normal allocator crate and writing our own, because we also have to put allocation flags to the different allocations, because that is also not standard in user space. So kernel Rust is quite different to user space Rust, but I think the same is true for C. You also have a very different style of C in the kernel compared to user space. So I would say it's very similar to those differences, because we also have many different smart pointer types compared to the user space, and also, for example, mutexes because they have to have a stable address, they have to be initialized using the pinned init mechanism, and that is also something that user space might not need to use, because mutex in the standard library of Rust is allowed to be moved around, so it does not have to have a stable address.
So when you talk about the special mutex type, I assume that's wrapping the kernel's existing mutex type. Is there any scope,
yes,
like, to eventually have Rust, like things like Rust-only mutexes?
I don't see why we would not do it, but for the moment we use the stuff that is available from the C side.
And sorry, one more thing. Could you, I guess the answer to this really is like look at the code, but could you, as a cheat sheet, could you give some examples of cases where the need for failable allocations changes the API? I assume that there must be some core, like, very common types that behave quite differently because of that. Is that true?
Yeah, well, if you allocate, you get a result of the thing that you try to allocate, instead of just getting the thing. So you just have to handle the error. For example, just bubbling up using the question mark operator or something.
Thanks.
Okay, maybe we take one more. By the way, Benno is going to be available, I think, right, Benno, on the hack rooms during the conference, in case you want to ask more questions or get help on something Rust related.
Also on the other days, I will be there.
Yeah, following on from the previous question, how much of the Rust standard library is being used in the kernel versus how much are you finding you have to redesign it or roll your own implementations?
So as I said before, we're currently in progress of removing the standard alloc crate. So that is the allocator stuff, for example, and also certain collections that the allocator crate provides. For example, the vector, as well as the box type, and so on. Instead, we have to roll our own in that case, because we need the allocation flags as well as rather fallible allocations, because the Rust version is optimized for the infallible case. There are some unstable features to enable the fallible cases, but those are not properly, or rather, those don't really work well together with the vec type, for example, and our allocation flags. But we are using the core library, so essentially the most trimmed down standard library version of Rust. We don't even, so we never use the standard, so STD, which includes a lot more stuff. But we did use alloc, or rather at the moment are still using alloc. But yeah, we're not going to use it in the future. So we have to write quite a lot of new stuff for that.
Yeah, I just want to add to what Benno said. So we basically only use the core crate of the Rust library, and we are also moving from using our own. From the core crate, we are also going to move from the using our own atomic implementation kernel. Yeah, for those that don't know, core is all the things that are not really depending on operating system allocations or anything, like result, option, these kind of things are there. Okay, so thank you, Benno. Again, there are seats over here in case for the people in the door, you have some seat here. Next, we have Daniel. I hope it converted correctly your slides because it's ODP. I hope BBB does the conversion on server side, so I hope the ODP to PDF work. If not, you can also use your laptop. If you see a mistake here, I'm sorry.
Can I just go through all the slides first? How do I?
Yeah, of course. So you can just I think.
Yeah, Miguel, sorry for taking too long to.
No worries. No, it works. For whatever reason, it goes back to. Maybe you can click. Maybe that's safer.
Sure. I just want to see whether the code boxes are working. I'm not sure further down. Like this thing. Yeah, it works.
Okay.
It works. But is it like full screen already?
Yeah. Whenever you want to start it.
Sure. Can I get started? Can you guys hear me?
Okay, we may take a bit from the break, 10 minutes from the break to give Daniel time. We have a slightly longer break, but you will be able to still go to the share break with other MCs and so on. So yeah, please start with it. Thank you.
For those of you who don't know me, my name is Daniel Almeida. I work for Collabra. I'm Brazilian. I was here last year also discussing codecs and video for Linux and how exactly we can use Rust for that. So yes, just a brief recap of what the problem is. Just believe me when I say that in order to decode video using, in order to decode video using a hardware accelerator, let's say an H.264 file using a hardware decoder, this hardware decoder will have to ingest a whole bunch of untrusted data from user space. Just believe that, because otherwise we would take too long to explain this. And the current issue is that nowadays we have a very ad hoc, let's say, validation process in the kernel. So basically the validation process is going through the specification PDF and seeing whether some data have bounds on it and manually implementing these checks in C. And of course that does not cover like literally all the cases, right? It's a best effort kind of approach. So last year I was talking to Mauro and Hans and other people, and I was also here trying to maybe see whether we could write a whole driver in Rust. Let's write a decoder driver in Video for Linux using Rust, and how whether this is possible. And this was met with a little bit of pushback. And the reason there was pushback was basically, if you will remember, from Wedson, he linked to a presentation where people were also asking about the layer of bindings and how this layer of bindings would actually work, who would have to maintain that. If we change something in the C code and we have a binding in Rust for that, who will make sure to update that? You see, that's a real problem. We had people talking about Coccinelle today as a way to maybe bridge this gap. So for the Video for Linux people, this was a little bit of too much of an unknown for them to proceed with a full driver, a full codec driver in Rust, basically. So I know it's not proper to put a whole lot of text in slides, but I really wanted to have this because I think that just reading this guy PhD thesis, the abstract, can speak so much more than what actually I can say. So Willie, actually his PhD thesis was writing a tool that can basically put out a valid, in a sense that FFmpeg, VLC, those programs will actually be able to read it, but a video file that's malicious. And if you read that video file, it can actually lead to all sorts of vulnerabilities, basically, that you can then exploit. So very en passant here, if the second paragraph says, a video decoder ecosystem is obscure, opaque, diverse, highly privileged, largely untested, and highly exposed, which is a dangerous combination. So they introduced this tool, H.264, which is a domain-specific infrastructure, i.e. a program for analyzing, generating, and manipulating syntactically correct but semantically spec non-compliant video files. So using this tool, we uncover insecurity and depth across the video decoding ecosystem, including kernel memory corruption bugs in iOS, memory corruption bugs in Firefox, VLC for Windows, and video accelerator
and application processor kernel memory bugs in multiple Android devices. So clearly, I'm not the only person seeing that there's an issue here that needs to be solved. There's people, actually, researchers, investigating and figuring out that there's a problem, right? So they had a case study where they created a bunch of videos, basically, and they say, in all, we identified a memory corruption vulnerability, a use after free and hardware accelerator VLC video playback, insecurity, disclose of uninitialized memory of prior decoding state, accelerator memory corruption, and kernel driver memory corruption and crashes. So, as I said from last year, that did not fly well with the Beautiful Linux people because, again, this layer of bindings was a problem. So in order to have a driver, you need to have a layer of bindings from the C code, from the Video for Linux framework that your driver can then use in Rust, right? And who's going to maintain that? And if you change the C stuff, what happens to this binding layer? So my plan now is, what if we could, instead of having a full driver, what if we could have Rust code for codec drivers in the kernel without having this binding layer at all, therefore sidestepping the entire issue? Is this possible? And turns out that that's possible if we convert a few functions at a time to Rust, and we carefully select which functions we want to convert. If we identify a self-contained part of the kernel which exposes a very limited API, and we then convert only these functions to Rust, then we do not need to have all these layers of bindings. Therefore, we sidestep the problem completely. Hopefully this makes sense. And the reason why I'm here today is I want people to give me feedback on whether they basically dislike this, whether they see any sort of issues. I'll be talking more about what this approach is, and whether they see any obstacles in general, not only in Video for Linux in particular, because I may have overseen something. So feedback is always welcome. So I'll speak a little bit more about the actual implementation of this. How do we do what I just said? How we convert just a few functions to Rust such that we do not have this layer of bindings? This call me from C function is a Rust function, and the only difference from a regular Rust function is that it's annotated with 2 extra syntactic elements, one of which being the no-mingle directive on top, and the other one being the extern C that comes before the function token. And basically what this means is it tells the Rust compiler to generate machine code that can be called from C. So in the object code, you basically will have a symbol with the machine code for a function. And once that machine code is there, there's no telling where it came from, right? There's no telling whether it came from a Rust compiler or from a C compiler. That's just machine code. And it's using the C calling convention. Therefore, any other C code can call it. And if you put that machine code in the kernel, it turns out that the linker will actually link against your function. And at runtime, you will have a switch from C into Rust. Again, hopefully this makes sense. If that doesn't make sense, please ask. But in general, it's a function like any other function. So at runtime, you basically switch from C to Rust transparently. So we have to have this no-mingle thing on top because we have to be able to name the symbol, right? So Rust actually uses the name of the symbol much like C++ does to encode a bunch of things. So generics, namespaces, closures, all these kinds of things, they use the name of the symbol to be encoded. And this is a problem, obviously, because you cannot call that function from C, right? Because it has a bunch of extra information. So you have to disable mangling, which means we lose access to generics and et cetera, which is not a problem because C also does not understand generics and et cetera. So we're not losing anything. And we need this to be callable from C, hence the extern C token. So that's it. If you do that at runtime, you call this function, you will transparently switch from from C into Rust. And the whole plan is, again, to identify a self-contained component, let's say a small kernel library or something along these lines that exposes only a few functions that you can just convert into Rust. That's the idea. And we need to expose this new API to C somehow, right? Because as I said, the Rust compiler will generate the machine code. So far, so good. But just like C, you also need, in the same sense that C needs a header file, right, with the function declaration so that you can call a function, you also need a header file that you can pound include into your C code so that you can call the function that has been compiled by the Rust compiler. Okay, and you can handwrite this this header file if you want to. So for this very trivial function, well, it's trivial, right? You can just say like void and call me from C, and that'll just work. But that's only for like extremely trivial stuff, because as soon as you have anything more complicated that you have to hand type, this can get pretty nasty, pretty badly, because now you can mess with your type ABI, you can make mistakes, and this can get out of sync, and this can get very hard for you to debug. And the good thing about this is that there's a tool, right? And this tool is cbindgen. And cbindgen is widely used for Firefox. It's actually something that Mozilla came up with to use on Firefox, on Servo. So it's maintained by Mozilla, and we can use that just fine. We can probably incorporate that when building the kernel to just run this tool, and it's actively maintained. So the idea is that cbindgen will take all of your Rust function signatures and convert that to a header file that you can then pound include in the C code and use that to call into Rust. Again, hopefully that makes sense, right? So let's go back a little bit. First, we identified functions that we wanted to convert. Then we write Rust code for that. We push this new function signature with no mingle and extern C. We run this cbindgen tool. We get a header file. We pound include this header file into our C code that we want to call Rust from. The Rust compiler will generate the machine code. The linker will link that. And at runtime, you get a transition. That's the entire process. Notice how I did not say bindings at any point whatsoever. So if your function takes arguments, so let's say your function takes a pointer to a struct, or takes a struct or an enum, cbindgen will also convert that and generate a Rust equivalent, a C equivalent version. And this works because we can instruct the Rust compiler to generate types that adhere to the C layout. Like using this repc annotation, you can basically tell Rust C to, hey, every time you see a struct, please lay out the members of the struct exactly as a C compiler would. And this is what makes it possible to interoperate between C structs and Rust structs, this repc annotation, basically. And you pound include the header, and that's it. So for potential targets for conversion in Video for Linux, again, I said this has to be a self-contained component that exposes, hopefully, a small public API. And now for Video for Linux in particular, this means like codec libraries. And for those of you who do not know what codec libraries are, whenever you're writing a codec driver, most of the work will be offloaded to the accelerator, right? But some work still has to be performed by the CPU. And we essentially did not want each and every driver having the code that's running on the CPU. We did not want drivers to roll out their own code, their own functions, right? Because this comes from the spec for the codec. So we basically had one implementation in a library, and then all codec drivers basically call into this library implementation. So these libraries with a few functions, a few codecs-related functions that run on the CPU, it's these libraries that I want to start converting to Rust, basically. And why? Because they expose a very small public API, basically, and they're very self-contained. They do not touch any other part of the kernel. It's just data in, some processing, and data out. Doesn't touch other parts of Video for Linux or the rest of the framework or other parts of the kernel, basically. So I think this is a good candidate, basically. So basically, I have a proof of concept where I took this VP9 library, so the library for the VP9 codecs, which are used for some VP9 codec drivers. I'm sorry, for all VP9 codec drivers in the kernel. And I wrote a Rust version for that. And the thing is, we have a tool, we call it a Fluster. And Fluster is basically a Python script that automates two things. First, it runs the canonical implementation for the codec. So like for VP9, that's libvpx. So libvpx will take a VP9 video file and decode that using the CPU, right? Then it will run basically your hardware decoder and also get a decoded file back. And then it will compare bit by bit, like the two files, and see whether they match. And to the extent that these two files do not match, the file from libvpx and the file from the hardware accelerator, if they do not match, you have a failure. That's basically how it works. Because the libvpx for VP9 is the canonical implementation. So we have this testing tool. I used this testing tool both for the C version and for the Rust version, and I had 0 regressions. I had the exact same results for both versions, proving that this works. And by the way, if I get the same score using this tool, as I've been working with this for a little bit, I'm actually confident that it will perform just the same for any VP9 video. You know, that's because I really trust this Fluster tool and this testing process using the canonical implementation. And it was basically a relatively pain-free process. So to wrap it up, I met with the Video for Linux maintainers Monday, actually. And my proposal was this, to merge the code, actually, and gate that behind a kconfig, such that you can choose on whether you want the Rust implementation or the C implementation. And we could run the Rust implementation on some CI using this Fluster testing tool I talked about to check whether we have any regressions in the future, which again, I don't really think is going to happen, because otherwise we would have caught it in the first place when we run Fluster for the first time. So that's the idea. Hopefully, if we do not get any regressions, we can hopefully deprecate the C version later on. So just to update you guys, last time I talked to Mauro said he was fine. Also, Hans said they were fine with merging that into staging. So this is good. This is more progress than what I had last year. And the idea is that we have all these CI initiatives going on for in the kernel in general, and also for Video for Linux, this media CI stuff. And the idea was to, well, let's try and test that using some CI and see where we go from there. That's the latest updates. So my question is, does anybody hate this? This is your turn to basically complain.
Hey, how's it going? Great talk. I actually really appreciate that you're extending the olive branch to C developers, kind of giving them, what they're used to. More of a question than a suggestion. I think this is great. I don't hate it at all. More of a suggestion. So C developers need headers. BindGen is more of a dynamic thing. So I'm wondering if it makes sense to have the C headers run BindGen and then just do some basic verification that the data structures haven't changed between the static C header versus the generated one. And that way developers know that they're still interfacing with the same calls, using the same structures and that sort of thing.
I did that, by the way.
Oh, you did? Okay.
For my proof of concept, I actually went line by line. But actually, if that wasn't the case, it would have broken Firefox and a whole lot of other softwares out there.
Absolutely. I'm just thinking for commit by commit sort of check-ins and that sort of thing. But that's really good. Thanks a lot.
Any other questions?
Yeah, just to follow up there, I think it's a brilliant idea. Definitely think this is a kinder way in, given, bindings are the really nastiest part of Rust to be dealing with as a new developer. Echoing, basically, it would be really nice to have the C header visible to all of the tools that deal with C headers, rather than, just being a generated part of the build process. Or if it's a generated part of the build process, make sure that things like the generated C header can still get pushed through the kernel doc process, so you can generate C kernel documentation for it. Have it be something that, you know, a C developer doesn't need to wait and do a build before they can see that header to use it as documentation.
Makes sense. Makes total sense. Okay.
Yeah, so proposal suggests to have two implementations in upstream for a while. And to deprecate C implementation, we would need to have all architectures to support Rust, right? So, but it can take indefinitely long. Is it a problem?
So yes, I was actually asked that by Mauro and other people. So yes, I think the so we have, like, GCC is actually working on this, but for now I don't think we support all architectures, right, Miguel?
Yeah, for deprecating C code that everybody uses, we still have some time ahead. I mean, we have the GCC Rust is coming along, but that will take a few years still, I think. We have the GCC backend on Rust C that already compiles the vanilla kernel, you know, without changes. So that could be an option, but it's experimental still. There is people using the GCC side, sorry, the C side of the kernel compile with GCC, and then compile the Rust C with the LLVM backend. That works. We don't really. We did it as a proof of concept, but people apparently like it and they use it. So we will see. But yes, to remove actual C code, it still will take a while. We cannot just remove C code that somebody is using so far.
I don't think there's too many people running Codecs on M68K or any of those crappy architectures. So I think this area is probably not applicable. Like, the architecture thing is a bit of a scary thing, but it's not real. The amount of people that run code, we're not going in, like if you're rewriting the core kernel, that might matter. But for this, it doesn't matter at all. But I had a question. Did you consider writing a driver without ever saying the word binding to anyone, and just writing a bunch, like we've considered this a couple of times, and writing just the C chunks of the interface, like, and using that, you know, like, so when you have like a struct with all the function pointers in it, just doing that bit in C, and then having all the function pointers be Rust things. I know you don't get the full advantage of Rust, but it gets, like, I also think it's a good way of scaring, because they still have to refactor things then, but you're still using the C API, so they don't have the excuse about the refactoring thing. But if they actually look at the code, they would still have to change Rust code. But I just wonder psychologically whether it would have a difference than having these bindings that they have to commit to. It's just one driver that does all of it inside the C interfaces.
So the driver is still in C, and then you pipe everything to Rust, basically.
Yeah, so you have like you have C interfaces for all of the driver entry points. I see. And then the rest of it's in Rust.
That's eventually where I want to get. Like, this is something I may look into. Like, this is a little bit like what you're saying, actually, you know? So long as the part that actually transfers all this data to the hardware, like the data used to program the hardware registers and everything, so long as this is in Rust, I think this is the core of everything, you know? If we can get that in Rust, I'd be way more quieter, because that would solve a whole lot of the safety issues.
Cool.
Hi, Alice.
Yeah, so, I mean, when you want to do this kind of thing, there are some areas, like you don't want your Rust code to be littered with calls into C. If you're doing that, then you're giving up most of the advantages. But it is possible to do this, and I do this in Binder. We have Binder.fs in C, and then Rust has this C interface it exposes, where I define a file operations constant, and then I have a bunch of Rust functions that take a bunch of raw pointers, and then they call into the real code. So you can do this. Just be careful to not put C calls all over the place, right? Because I really made sure that these functions that deal with the raw C pointers, like, they immediately convert them into Rust types and then call into safe Rust. And so if you're careful, you can definitely do that. Yeah.
I just had a simple question about your path into the kernel on this. It sounded like you briefly mentioned you were planning on putting this into staging. is the plan to get this out of staging as quickly as possible? Or is this something that we want to languish in staging until we're ready to just flat out replace C? I mean, it's already tied behind a K config, so.
I don't think I'm in a hurry to actually move it out of staging. My plan is that we go like slowly so that everybody can get used to having Rust and seeing whether everybody agrees to it. You know, I don't really have a reason to push through this like as fast as possible, because I know this is going to create some pushback actually.
Yeah, I was just mainly curious. I mean, as the Fedora maintainer, my policy is I don't turn on staging. Now there are some exceptions, but very rare. Just thinking if we can get it out of staging, or if we did away, we've got Kconfig, so we don't have to go through the staging route. But of course, I can also change my policy.
Yeah, I mean, staging is the only thing I got from Auto, so that's what I have to settle for now.
Hey, so you spoke about how using bindgen works, and you can call the Rust functions from C. How about the other way, calling C functions from the implemented Rust implementations, just to check your headers, or kind of the opposite of what was just mentioned, using boilerplate or framework Rust code to call into C, and then convert that C code to bring that C code into Rust one at a time.
So actually, I'm working on a driver for ARM GPUs, which has nothing to do with this presentation, and that's what we're doing. Basically, we have a tiny driver in Rust, and we pipe everything to C, right, and then we convert a little bit at a time. Note that everything is a little bit experimental, right? The Rust for Linux initiative is like, I think, only 4 years or something. So everything, at least we're trying this that I know of. I think Nova and Panther and these drivers are the first drivers trying this. That I know, but I may be mistaken.
But it works.
It works.
So that's a good stepping stone as well.
Yes.
All right, thanks.
I have simple question. You mentioned that there is no degradation, but any hope to improve performance?
I think this question goes much beyond the video for Linux, and it's a question about whether Rust is as performant as C. This goes like beyond what I did, right? This is something for the Rust committee and other people to. But I do not know the answer really. Maybe Miguel can shed light.
Yeah, I see the point, but it's very convincing to have improvement for guys that use Codecs or something.
What I can tell you for sure is that there's no overhead versus calling a C function.
So we have the null block driver and an NVMe driver written in Rust, and there are performance regression tests available on the Rust for Linux website. There you can go and see how at least we do it in the block layer. The Rust implementations are 0.5% slower than the C implementation, as when it comes to throughput, IOPS.
I think looking at performance may be the wrong yardstick in some ways, just because I think C code is heavily optimized anyway, and there's probably no more performance benefit you can get from changing the language or changing something else. The real measure here might be the safety and the security that you're getting. And so if you want to measure that, like bugs over time, CVEs over time. Performance might already be optimal today, so.
Just on the, what we were just talking about, on the performance, I was actually wondering if you found, if you think you did all of these libraries, would you find any bugs in the C code? Do you think there is any memory safety issues in there, or do you think the testing tool that you have is probably already caught all of the memory safety issues in the C code? Or like as you've implemented more Rust across this, do you think you'll start to see there might be some memory safety issues in the C side?
Wait, so the question is whether I think there's issues in the C side?
Yeah, whether you think you've done one or two, you said, but do you think there's any that might be in some of these libraries that are already pre-existing that you might fix doing this?
I actually discussed this with Mauro and Hans and the other people, because they told me, hey, you're changing something that works for something that works. What's the point here, right? And like, how can you be sure that the thing we started with actually works? that there's no bugs, you know? Because if you knew there was a bug, you would have fixed that. Isn't that like logical? So by the very definition, if there's any vulnerabilities there, you do not know about them. Otherwise, you would have fixed them. So I believe we can probably be fixing things as we go. One of the things they wanted me to do was basically, hey, if you can run this H264 stuff that you brought, like this research thing, and you can prove that you can craft a malicious file and it crashes the kernel, and your Rust code prevents this crash, you're going to gain more points with us. That they told me this. So I may look into doing this year.
So at least statistically, there are vulnerabilities in the C implementation. We have some, there are some slides around listing different statistics on this matter. And the question that remains to be seen is if these issues disappear in the Rust code base. And I believe Google has published some stats on that on their security blog. And at least the empirical data that they have show that the bugs actually do disappear in Rust code bases. But I guess it remains to be seen, like how it turns out.
Okay. Thank you, Daniel. So we are on the break. We will probably start a bit later to give you time to catch coffee, etc. So thank you. See you later. Okay, 10 minutes later. What is that? 10 past o'clock?
Yeah, 10 past 12.
I just want to keep it as far behind.
Yeah, for the feedback. Yeah, sorry.
No, no,
Went in 6:12.
Yeah, it's in my treat now to go to Linux.
You are next, right? Yeah. So make sure. So we
I
have
have
to
no idea about
re-upload.
this system. I put them in the
So I have to.
LPC event site.
Yeah. So. Sorry, Larry. I have to. So we have to take it from here.
So you don't
Latest. Can you check it's the latest?
Yes, I enjoyed it.
So maybe you can also check it. So okay, this is one. Can I rename that? I guess it doesn't matter, but I don't know. This is the local file, but I don't know, just in case it appears somewhere. That should work, and now you can maybe check quickly, because it converts, does some conversion, you know, at server side. So, for PDF it should be fine. I don't know exactly what it does, but for ODP, for example, from Daniel, I can understand for PDF, so maybe you can check if. So, I don't know why, you
Is
know,
this screen the one that's broadcasted up there? Can you make it larger then? And remove this stuff? Because I have code in there.
I can ask, but I don't know if they want that we have a full screen. Maybe we are not supposed.
You know, the presentation is going to be a little bit stupid. If,
try not to use that, because for whatever reason it jumps here.
So what do I do?
Clicking. Yeah, or if you can find another. Hey Daniel, how are you doing? Maybe you can find another key that doesn't jump into the. Yeah, I know.
We can ask them maybe.
They just left.
Can
Yeah.
you see this?
The thing is, we are.
Ah, there you go. It's only full screen on my screen.
Yeah, that's why.
Yeah, there's something about they want the sponsors to be on in the break. Like how?
No, we need to put the break.
Yeah, that's what I mean. Yes, exactly. They want the. Yeah, man, good to see you again.
Hey. Is that your machine or is it the?
No, you have to present via the thing.
No, I think you can.
Yeah,
You can use a laptop as well.
I can.
Yes.
I mean, that's my idea for tomorrow because I'm doing a storytelling talk and I need notes.
Yeah.
And
you
But
can use
the email I got from James was like, no way, you have to use this.
yes, but then they also said you can basically use your own machine and just share your screen.
You need to connect to
Oh,
VV.
then you have to. Yeah, I don't,
you have to connect to VV and all that. So it's more complex, but you can do it.
Yeah, I don't want that. Okay. That was
You can do it if you connect to VV. You have
Yeah,
to
that's what I
be
want
in-
definitely. Yeah, because I want to have my speaker note screen
I mean,
thing.
because yours is in K Summit, right?
Mine?
Kernel Summit.
Yes.
So I mean, double check with Ted, but I think it's okay because it's everything the same for everybody.
Yeah, but I definitely need to check with someone because I want this. I mean, if I don't have my notes, I'm lost.
Yeah.
Because I'm talking like 40 minutes about.
Can you maybe print them? Just
Storytelling. Yeah, I mean, my backup idea was moving this aside, putting my laptop besides it, and then I have to switch on both machines, but that's annoying.
Sometimes I use the phone, like I have the notes in the phone. You know?
Yeah, it's too small. But I can put my machine besides that one, I guess, somehow.
I think it fits. I mean, maybe here. You put a hack double deck.
Just put it on top.
Yeah.
Now I really have to ask him to get this.
Also check maybe because in that track maybe they have another laptop or something. I don't know. Maybe it's bigger. This thing. I don't know.
Yeah,
what they
I need to figure it out.
Nein, nein. Okay. Ich bin über den Raum wieder jetzt zurückgegangen.
If you want to write a rate controller and Rust, and you want to tie to the existing role, let's say to the existing projects, you can do so in the streamer and use just the plugins RS, which is the Rust part of the streamer. You can just write your rate controller there. That's very well advanced, actually. It's writing a Rust streamer code in Rust is actually, there's a whole other of other elements already. So it's not going to be a problem to upstream.
What is Nicholas on?
He's not the one actually driving it. I don't think he objects. He's probably going to say that it's a good thing, but he's not the one directly involved. But we have a whole lot of people that's as high as Nicholas, let's put it this way, in terms of hierarchy or time that are very focused on Rust. Like Sebastian, he's been a distributor contributor for 15 years. Sebastian D-R-O-G. So he has been in a few years. We have other people as well. So if you want to write distributor code in Rust, you can get it actually.
So Daniel, I mean, so for me, I didn't really like contribute in upstream as well as stream. My viewpoint is coming from, I mean, our team maintaining this Chromium code. Using this program to our, we might have,
Why don't you turn off the audio for the catch box? Why don't you turn off the...
Here,
Achso, jetzt, okay.
Also jetzt ist es auf, bitte.
Genau. Richten kurz ab.
This huddle cam. Excuse me. I'm going to have some code in those slides. Miguel said I should ask you to have it full screen.
I don't think that we can do that. I'm not allowed to touch it. So everything that you want to do.
But if I full screen up there, it doesn't go full screen on this one.
Okay, I have nothing to do with that.
Who can do that?
I don't know, but I can try to find out something from my supervisors, but I'm not allowed to touch it.
Okay. You neither?
I'm here for the audio.
Okay.
And also I'm responsible for the whole layer.
So someone must be able to, because otherwise, like, the code walks through and so on. So I wanted that, but I couldn't, like, if I were to obtain one with then it was like
Yes.
like I'm having a code walkthrough, so like it's gonna be really quick. So Miguel said we're going to start 10 past because we went over time before the break. So sorry for that.
I started in the sense that I can put it with side from another. To build everything around it. No, yeah, it's not a problem. That's true. It's complimentary doing development. Yeah, exactly. No, yeah. I don't need them. You can use your laptop. That's the.
Do you know how I switch the deck?
So can you open the presentation? Let's see one. Okay, that one. Let's see if they come in.
You will see it, but if you don't want, you don't stay full screen.
Yeah, no, it's fine. I know what's on it.
Right,
so,
right. So you need to monitor that, and also.
Also, the slides are available, so I'm gonna have.
Do you know? Oh, did you guys do the download?
No, I put them on the LPC.event site, so people can go get them there.
Yes, but when you uploaded a slide, you didn't go in and say make downloadable. Because then anyone could download it. It'll put a little icon here and say download slides. So, anyway, yes, I did that in my training. That's okay. You didn't watch the training, I guess. Yeah, if you go into here real quick. Bear with me just here. What? No, I did it earlier today. So if you go here. Oops, cancel. And if you go through, which one's the one? This is the one you're doing?
This one, yeah.
You click this, enable download, and now this little icon appears, and you can tell anyone you can download the presentation.
Cool. Okay.
And you want to do that for every single one of them.
Yeah, I would.
But yeah, as long as you monitor for questions.
Is my cursor on this screen? Like, can I?
If you go like this, well, yeah, if you go like this, your cursor should be showing. It's a little tiny cursor. That's the only problem.
We had another one in a previous presentation. I tried to move it, but it was not this one.
Benno was remote. Maybe that's different.
Well, this is the one. If you're set as presenter, this should be the one that should work. Is it?
There's a little red dot.
Yeah. Yep.
I think we should get started. Yeah, it's a little past.
Half an hour. Okay, like normal. Okay, we are going to get started. We continue with more in-kernel Rust topics. So Andreas is going to present his HR timer Rust abstractions. So whenever you want, Andreas, thank you.
Right, my name is Andreas. I'm with Samsung, where I work on Rust in the kernel. I consider myself a plumber more than a language expert, and I leave the language compiler expertness to some other people. Just so you know my point of reference. So there is going to be a lot of code on these slides. So, and I don't know if the size is going to be cool, but there is. I'm told there's like a little download button in here, so you can go and get the slides if you want to, if you can't see it.
Nevertheless, even if we are full screen, please still write notes in the Share Note tab. The organizers wanted us to tell you that please encourage you to write notes in that tab. Even if it is full screen, you don't see it right now. Thank you.
And this talk is it's going to be centered around abstractions for the HR timer subsystem, but really what it's going to be about is a programming pattern called the intrusive pattern that Alice coined. I think she coined the name for the work queue. And so if you already know this pattern, then hopefully you can tell me if I'm applying it right or not, and we can have sort of a live review session. If you don't know this pattern, then you can learn about it, and you will have an easier time understanding the work queue bindings or the HR timer bindings, or maybe some other bindings that are using the same pattern to build the abstractions. Yeah, so that's it. Let's get started. Arrow key not working. Just going to click. Next. Yeah, so agenda is why do this work for the HR timers, what have been done before, and then I'm going to go into detail about the patches that are now on the list in version 2, and then a little bit about how we're going to handle allocating stuff on the stack that can't go away. The reason I'm doing this work is that the Rust block abstractions, I'm pushing those upstream, and one of the deals with the block community was we put in some null block driver, and they would like to see a feature parity with the C null block driver, so they can more easily compare between like what does a driver look in C, what does it look like in Rust. And that sent me building abstractions for a lot of subsystems that the null block driver interfaces. One of them is the HR timer subsystem for emulating IOs that have some kind of completion latency. And that's why I'm trying to interface the HR timer subsystem. There's some other stuff as well. Right now we have module parameters, and next up we're going to build config.fs abstractions. And as far as I'm aware, the HR timers are also a dependency for the Rust implementation of the virtual kernel mode setting, which is some GPU thingy, I think. So it's good, we are more that can use this work. So a little bit of history. I believe sometime last year, Bakun pushed some work in progress, kind of you didn't send it to the list, but you did do some timer work for the jitter-based timers, right? I put some, I sent the V1 patches 4 or 5 months ago, and then just as the block guys asked, oh, could you like feature complete this? The response on the, because I just implemented the part of the timers that I needed for my work, but then again the response was, could you please add a more feature-complete API for these timers? And so you see where this is going. Like eventually we'll cover all of the kernel, hopefully. There were some issues with the first version of the patches. And then of course the work queue is the code for the HR timers have a lot of similarities to the code that allows us to interface the work queue from Rust. So I want to credit that. Briefly, the C HR timer API, as I understand it, has these components listed in this slide. To use it, you allocate a struct HR timer that you have to initialize it after you allocate it, and you have to write a function pointer into the struct, which will be the function that's called when your timer expires. You then have to arm the timer or schedule it with one of the HR timer start functions. You can cancel the timer, and you can manipulate the expiration date of the timer. And that's sort of the interface we have for these timers. We're going to achieve this, we're going to have a few traits. I'm going to go into each of these in turn, and hopefully you'll get an idea of how we're trying to put these concepts into Rust. At any time, feel free to stop me and ask questions so we can have a discussion if something is not clear. First of all, we're going to cover we're going to wrap the timer, the struct HR timer, in a Rust type, just so we can allocate it safely in Rust and put it into our Rust structs. That's going to be the struct timer. Yeah, I'm going to go into each of the rest of these in one by one. Hopefully this code is big enough, but otherwise please go download the slides. We have a trait called hasTimer, which basically expresses that a struct has a timer embedded somewhere. We have two functions, one function for going from a pointer to the outer struct to the inner struct, and one from going from the inner struct to the outer struct. So basically, if someone gives you a pointer to the embedded timer, you can go back and find whatever struct it's embedded in. It's just pointer manipulation, but in order to do this safely in Rust, we have to express it in a certain way. But this trait just has these two methods, and then we have some safety requirements on those for how to use them properly. The idea is not that you implement this by hand. You will have a macro for implementing this for you. And this, if you have not seen Rust macros before, it's similar to, in some respects, it's similar to C macros. You have a piece of text that unfolds to another piece of text, more or less. And in this case, we have, I'm not going to go into each and every bit here, but in this case, we can put this impl hasTimer, and then it will expand to this code down here. And this code implements the trait that we just defined, which has these functions for going back and forth between the pointer to the host struct and the pointer to the embedded timer. And the important part is this one, where we just have an offset off. And we use this offset to just add and subtract, go back and forth. An important trick in this particular macro is that we re-implement one of the methods, and that makes it certain that we can only, this code will only compile if the struct actually has a timer embedded of the right type. So if you try to apply this macro on a struct that does not have a timer with this particular name that you give in the macro, you will compile fail. And you will never sort of inadvertently try to ask for a timer in a struct that doesn't have one. The reason for that is this function here that we override has to return a timer type, and when we're getting this expression here has to evaluate to that type, right? So it's type checked through that. If this expression yielded another type, you would get a type like a type mismatch, and it wouldn't compile. So this is an example of how you would use this. Up top, we have, I implement my, I want to have some kind of struct, and I want to put a timer in it. So I define my struct, I put a timer in it, and I call the macro like this, impl hasTimer for, now it's actually difficult for me to see on my screen, but hopefully you can see it. You invoke the macro like this, impl hasTimer of self, which is going to be this arc intrusive timer, and that you also specify here, and you specify the name of the field here. As you see, self.timer. If, like, I put self.flag, it would not compile. It would say, this is not a timer. You can't, like the offsets that I'm calculating is not into this type that you want it to be into. And so we don't, with the, yeah, so I put the expanded code down here just for reference, what it expands into. And this means we don't have to write any unsafe code in order to do this conversion between the pointer to the timer and the pointer to the containing struct. We can just put this macro and we verify that this unsafe code inside the macro is always going to be sound. So that's a manual check, but it's a check we only have to do once. And we've reviewed on the list, and we're certain that it's all cool. The next thing up is a timer handle. So a timer handle is what we're going to get back after we schedule a timer. So we call some kind of schedule method, and we get something back. This handle was not in the V1, the first version of the patches. The thing is, we're using, when we're scheduling this timer that we have embedded in this struct, we need to make sure that the struct does not go away while the timer is armed. Because then when the timer fires, we're passing it a pointer that we turn into a reference to the thing that was deallocated, and we have a problem. In the first version of these patches, we transferred the ownership of this pointer into the ARM timer, so that the ARM timer would have the ownership of this struct. While that was fine in some regards, but the problem is that if the last reference to this struct is owned by the timer, then we're going to drop the timer, the struct in the timer context. And some allocator people told me that you cannot run the allocator in a timer context because it's not a sleepable context. So that was a problem, and we have to make sure that we don't destroy any objects in this context. So instead of having the timer owning the reference, we're going to have return this handle that's going to own the data that the timer points to. And so as long as the handle is alive, we know that the struct that embeds the timer is also alive. And when we drop if we drop the handle, we cancel the timer, and then we're sure that when the timer can't fire and point to something invalid. Does that make sense? Okay. I put a safety comment up here stating basically that if you drop this handle, you must cancel the timer. Otherwise, and no, I didn't put the reason why, but just that you have to do it. So that when you implement this trait on a type, you wouldn't do that yourself, but the library would do that when implementing the timer handle. So we have a timer pointer trait, which is a thing that you are allowed to call schedule on. This would be like in our case, a reference to a struct that contains a timer. It could be a box, which we heard about earlier today, which is a pointer. It's like a C++ unique pointer. So it's something that derefs to a struct that has a timer embedded. It can also be the arc, which is, I don't know what the C++ one is, shard pointer. So a reference counted smart pointer that points to a struct that has a timer embedded. And we just have we have the timer handle, and that is the kind of handle you return. That would be different depending on what kind of pointer you point to your struct with. And you have the schedule method, which basically arms the timer. Now it says U64 here, but I forgot to update the slides. We actually now have a k-time, which wraps the I forget the kernel thing, struct for durations in the kernel, time t, k time t something. It's basically nanoseconds with a 64-bit resolution. We also have a trait for the C side to hook into. This is also something that would be implemented in the kernel crate, not by the driver users, but by the abstraction layer. And this exposes a C function with the C linkage that we can actually install into the struct HR timer function field and have the C code call. The safety comment on this is just like, don't call it from anywhere else, only have it being called from the HR timer subsystem. Lastly, we have this timer callback. This is what you would implement manually on your struct that embeds the timer. So this, for this, you just fill out the thing that's going to point to my struct is going to be an arc, or it's going to be a box, or it's going to be a mutable reference or something. And when the timer fires, I'm going to implement this run method, and that's what you're going to run when the timer fires. And so that's the only user-provided code to use the timer subsystem. And just to see how all of this would tie together for someone wanting to run a function on a timer, this is a code you would have to type into your driver. You put your struct where you embed your timer and whatever other logic you want to put in. And then you, here I put a constructor for my thing. This type of constructor allows us to construct this struct in place. That's not something that you can do in the Rust language. You have move by default, so that's something we added specifically for Linux. We call it, Benno did it, he calls it pininit. So just allows you to construct this type in place. We would also implement the timer callback trait for our struct, where we just put some stuff into our run method. In this case, we have in the struct we had an atomic, so we're just going to atomic boolean. We're just going to store true into this atomic, and then in our just for the sake of example, we are going to spin while we're waiting for this thing to become true, right? So we create our timer, we schedule it, and we wait for the flag to become true. When it becomes true, the timer has fired. So super simple. At least I think so. If it's not clear, please let me know. I will elaborate. This is all safe code. So this is, assuming we did the tricks we showed before correctly, this cannot have any memory on safety. That's the idea. So this is all great. When in this case we're using an arc, which is like a. There's a question down here, Miguel. Can you? Someone who has the microphone over there.
I just want to understand, because the plan is also to make all the interfaces more stable or more self-explaining than, for example, they are in the kernel. So my question here is this timer callback. You cannot have a HR timer without a timer callback. So is it somehow, I have no clue about Rust, no clue at all. I only know a little bit about timers. So my question here is there, it's somehow ensured that the timer always has this callback?
Yes, you cannot. Yes, by the in Rust we can put some bounds on the types that we implement traits for. So if you don't implement this callback trait, the timer callback trait, you will get a compile error. Okay. It's going to say trait bound not satisfied for this type. Okay. Basically, you can't.
Okay, thanks.
Yeah. Yeah, for, like if you're used to Rust, it will be you will know like first thing, I forgot to implement this trait. I'm just going to go do that. If you like coming straight into Rust, it takes a while to figure out like what do these messages mean. Yeah.
So the timer callback function, is that something that is like you generate a new version of the C bridge so that you call it directly, or does it go through some kind of vtable, like din in Rust?
Is it a vtable? So I'm not sure I exactly understand the question, but what's the thing that's going to happen is we have this thing called monomorphization.
Okay, yes, you answered already the question.
Yeah, so it's for the type. Yeah.
Yes.
Yeah. Yeah.
I didn't want to say the word.
Okay. Yeah. There's a question down here.
So Andreas, what's the intrusive part of this timer?
Yeah, so the intrusive part is at least in I guess in C code in general, but also in particularly in kernel code, we have this pattern where you, for instance, if you have a linked list node and you want your struct to appear in a linked list, you put a linked list node into your struct, and then you can sort of use that to thread into a list. That's the intrusive part. Like you put it into the handle into your struct. You don't put the struct into your handle.
I see.
Right. And so the timer is essentially the same. There is probably a list head in the HR timer that or maybe it's an RB tree or something that allows you to put it on the timer queue.
Thanks.
All right, so far so good. Now we can have timer. We can have these structs on the heap, and we can have timers in them, and we can call them. We also have, I didn't put it here, but I think at least, we can also, there's also some, I also built another API where you can just put a closure and it will allocate this timer struct for you. So you basically just say schedule function, put your timeout and then a closure, and then that will run at the specified time. But that one is also allocating at the heap for the struct timer. Now, what about stack allocated timers? We have the pin initialization that I talked about before can also allocate stuff on the stack. And in this case, we allocate the struct containing the timer on the stack, and then we schedule the timer and we wait for the flag to be raised, and it's all good. But the thing is, if we did not wait for this timer to fire, then the stack could go away and we would have a timer pointing to something that's not there anymore, right? So we have to put a pin in the stack and make the stack not go away. I thought about this for a bit, and then in the Rust standard library, there is something called, there's threads, and then there's something called scope threads, because when you spin up a thread and that thread takes references to the calling stack, you basically have the same problem, that it can go away, and then you would have another thread pointing to something that's gone. So we can do the same thing for our timers. Okay, I got ahead of myself. The first thing we can do is we can make the timer pointer trait unsafe, and just put a safety requirement that if you use this unsafe timer pointer, you have to make sure that your stack, the thing you point to, doesn't go away, and then it's up to the caller. But obviously we don't want this in our drivers, because that would mean unsafe code all over the place and like having to explain ourselves why is this safe, and that is of course prone to errors. Okay, so this is just demonstrating how to use this unsafe timer pointer. In this case, we put a safety comment here, and then we have the unsafe block here, and we say, okay, we promise the stack is not going to go away before the timer fires. And then this is actually sound to do. But again, if we remove this while condition, we would potentially have a problem. 1 second, Alice. So instead, we can have this schedule scoped, where we actually make sure that the stack does not go away by passing a closure to the schedule function, and then when the closure returns, we make sure that we block until the we make sure that we drop the handle and thereby cancel the timer, so it cannot fire onto something that doesn't exist, because it will be cancelled, and then the stack can go away. Now you can have your question, Alice.
Just to your point that this is difficult to do manually, I think you need an acquire load instead of a relaxed load for it to be okay.
Potentially. No, I guess it's fine, because it's like eventually it's gonna be okay, right?
Well, it depends on what is after the while. Like, this is correct.
Yeah, in this case it's right.
Yeah, in this case it's right. If you are doing something after the while, it may become acquire, of course, yes. Nice introduction to the next.
Yeah, and then, so if we do it like this, we can still do our allocation on the stack, and we can schedule. In this case, we use the schedule scoped function, and we pass in the expiration, and then this is Rust syntax for a closure. And then we can do whatever we want inside the closure, and we know that once we get out of the scope, the timer will be disarmed, no matter if it fired or not. And we're never going to have this issue of firing a timer that points to something that's gone. Yeah, so my aim here is to get some eyes on this patch set that I sent last night. So please go take a look, and even if you're not rusty, take a look, and maybe you can spot something that's not right. I already found a problem myself, so yeah. There's still some stuff missing from this patch set. There's a concept of sleepers, where you just take the current task and basically make it sleep for the duration of the timer. We also we don't offer selection of clock sources, and we don't have a bunch of introspection functions yet. But I think these can be added fairly easily after. Yeah, so this is all I have. There's a question down here.
This might be a dumb question, but can you embed 2 timers in a struct?
Not with this patch set, but as Alice demonstrated in the work queue, this can be achieved by adding a generic ID to all of the traits, and like basically an integer, and that will become part of the type and help you differentiate which embedded timer you fire on. I didn't put it because it puts a lot of noise in an already sort of convoluted system, so I wanted like this reviewed and understood first, and then put that later.
I just want to comment on the multiple timers. So other than what we do, what Alice does, we can also put an array of timers header in the struct, and it could be simpler to specify which timer you use to queue the timer, queue the whole struct into a timer list. That can be simpler to
put a ring.
No, put an array of timer head.
An array.
Yeah, array.
Yeah,
yes.
yeah. You could have an array. Yeah, sure.
That's.
But then you would, then it would be the index, I guess.
I mean, yeah. You can use the index function to specify which timer you use, which timer array structure you use, right?
Yeah,
and it's maybe simpler than have multiple field and using a type to describe that where the field is.
So. It might not be. It might be simpler to implement, but I'm not sure it would be simpler to use.
But honestly, like if you have multiple timer header, you probably want to handling the timeout yourself instead of relying on have multiple timer, I think.
If you have multiple timers, you would rather rely on handling.
Because you say you have like 2 timers and one fair before the other one, and you actually, well, I think the actual reasonable is just you have 1 timer and you have the logic that what if this timer fair first, and then what we'll do next into the code.
No, but you have the handle for the other one. You can just do whatever you want with it. Cancel it, extend it, forward now, forward later.
I don't know really, yeah. But yeah, just saying that we have like other ways that other than introduce what we do for work queue to.
Yeah, sure. Let's discuss.
I missed the part where you made the unsafe function, the schedule function unsafe. Does that also apply to heap allocated timers?
No.
So it's a different trait?
Different trait, yeah.
Oh,
different trait that you implement for, so the safe one you would implement for box and arc and aref, which are heap pointing things, right? And then you would implement the unsafe one for pin ref and pin mute ref.
Okay, so you can choose which one it is.
Yeah, and so basically what I did is I implemented the unsafe one for the 2 pinned references, and then I did a blanket implementation of the scoped one for all types that implement the unsafe one. All right, thank you.
One thing that I wanted to talk about is we now have we now have two structs, or rather essentially 2 types that need to use this intrusive pattern. And my question would be, if we were to do we need more? Do we have more things on the C side that require this intrusive stuff? And if so, we want to have a general pattern for that, for example, then we could have something like an intrusive attribute macro on our structs that would actually implement that. Then you wouldn't need to call this impl has timer for your struct.
I think it's great if someone can do some pattern matching here and extract the common bits. Then I chose to name my types differently from Alice's, so we can fight about that.
Ben, I think the future plan is to use the field projection for those intrusive structs. That we certainly have a lot. We have RCU, and we also have software timers and IRQ work. There's a lot of things that the list can go on now.
We don't just have 2 examples. The linked list also uses the same pattern.
Probably also the B tree, maybe?
It should.
Okay, it doesn't?
The B tree is not intrusive right now, because it's a very old abstraction, and it was written before we were doing the intrusive stuff, but it should.
Yeah.
And I just would rather replace the red-black trees with X-arrays and hash tables than spend the work on rewriting it for intrusive, but it certainly could support that.
Cool. Yeah, so if anyone is interested in coming up with like an overarching thing that can encapsulate all of that, it's really cool.
So if you come up with a generic thing, make it a crate like the pin-init that we can use from other projects that are trying to integrate Rust into C code, because the pin-init thing is beautiful.
Thank you, Andreas.
Thank you.
How do I find? I write upload.
There is a space, a lot of space in that side of the room, so please move there if you are looking for a seat.
Did you upload it here, the latest one, or not? Okay, so let me update that. I mean, probably so this is the, let me refresh. Hard refresh just in case.
Yeah, they changed that like 10 minutes ago.
Okay, so this should be. Double check that this is the latest one. I mean, Then we download. We go here. Okay, so Botune is going to talk about his atomic memory model work. So Botune, thank you. Whenever you want to.
Hi everyone. Yes, so I don't have much slides today. I'm just going to use this opportunity to kind of give you guys a status report of what I have been done for this particular area, and also the latest, like the API, what the API would look like, so that I can get some feedback, and we can eventually having those in kernel for Rust code. All right, so yeah, this is so we have some discussion in Congress host in previous conference. Also, there are some discussion in the email list, and I also have some discussions with Rust community for the which memory model we should use. Basically, the conclusion right now is just use the Linux kernel memory model, and the reason behind that is can be complicated. For one thing is that the Rust memory model, which the C++ one, doesn't really know the other memory model. So if we want to write a code in C memory model and then communicate with the code in C memory model, communicate with code in the Linux kernel memory model, then it requires like a lot of work to make that in theoretical work, and also require the work that compiler implementator will make sure that the synchronization actually works. So it's much complicated in that way. But if anyone has interest to do that, I'm happy to know. But right now in kernel, we stick to use our own memory model. And the other thing sort of coming to conclusion is that we in this kernel memory model, we have the thing called dependency ordering, which basically is some, if one the data has some ordering between normal, relaxed, read and write, then in kernel, we treat it as ordered so that you can use this ordering in your concurrent code. So it's naturally that since we use the Linux kernel memory model, then the Rust code will also can rely on the dependency ordering. But it's it actually requires more work. So you will need to require that compiler doesn't optimize code, and doesn't optimize certain code away. And you also probably need to put some tag onto your atomic access to make sure that the following atomic access will respect to this ordering. And also similar in C that we know for sure that there are some cases where the dependency will just break. And what we'll do is just we tell people don't write code in that way. So that could be the same case for Rust if we're relying on dependency ordering. All right. So the other thing I failed to discuss previously is about data risk rules. So again, Linux kernel memory model has a slightly different data risk rules. So we don't treat normal read and atomic read as data risk on the same object. And I think this is also the direction that Rust is moving to. And so since we implemented the atomic ourselves, so this is not data risk. And the other thing is that in C side, we have sometimes some code, I don't know who wrote that, but relying on normal write to be atomic. And for me, I think it's feel like unfair for Rust code to just, if you have a Rust code, which read the result from that write, then it's much easier to just assume that since C code treats that part as atomic, then you can just treat that atomic. Then therefore there is no data risk. Otherwise, you have to modify the C code to make sure there's no data risk. That sometimes can be really painful. So here is an example of what I mean. So in the bio case is to C memory access, and the one is normal read, the other is normal write, and below is 3 Rust memory access. So if we are using Linux kernel memory model, then the operation A and the operation, I'm not sure if this. So operation A is a normal read. It will not have data race with operation D because normal read would not have data race with atomic read. And but if we do a normal read, but you do an atomic write, the A and the E plus E is actually a data race because normal read can have data race with atomic operations. And the third case is if you have a normal write B, and which with the normal with atomic read, and if the C side relying on the normal write to be atomic, then this is not data race. But it's better that if you can rewrite the B into a write once, so that is atomic write. Okay, all right. Anyone have any question about this? It's maybe a little bit. All right. No, let's move on. Doesn't work. Okay, so I was sent this RFC like 3 months ago. It's basically just wire everything into C head into Rust. So the API looks like this way. You have a type, a multiple type, which is called atomic I32, and you have basically similar to a C function. You have the fetch add function, and you can use that as a user. So 2 things noted here is that first is that it's not a generic API, but it's similar to what Rust has in the standard library. It's not generic over the type. And the second part is that I use the same name convention as we use in kernel for fetch and add. So you have to use the suffix to specify the ordering variant. So this is what I did 3 months ago. And for myself, I think this API actually looks okay. It's a good starting point. But I got some pushbacks and saying I should do something differently. So let's move on. So yeah, right now it's what I have. So it's a generic type of T. So, but although it's generic, but it's not supposed to be put anything in T. It can only support only a list of types. And also, you can support like a new types of the basic types, and the user would look like this. Wait a second, did I mess something up? Let's move on. So the user would be like. No, I think it's my own mistake. So let me explain. So the first line user is basically just a generic type. It's basically looks similar in previous example, and you can do atomic operation on the variable. And the second is what I mean by new type. So you can basically define a new type of U32, and you say that it's a new type. And if you impose a trait called allow atomic, then you can use that. You can put atomic. You can put the new type into the. You can put the atomic new type and use that for atomic access, which basically can cover all the cases where I know of in the kernel. Honestly, like even without generic API, I think most of the cases in kernel are already covered. And yeah, so the actual thing I did for while I'm working on this generic API is that I make the ordering variants as one of the parameter of both as the type parameter and also as the function parameter for the atomic function. So if you look like this, so here we have a atomic read function, and in kernel we only support two ordering. One is relax, and the other is acquire. So it has a type. So the ordering we can put here must import the trait, either is acquire or relax. This give at least give users some idea about what the ordering this operation actually support. And the other function is fetch add, which actually support 4 ordering, acquire, release, relax, and fully order. And so so the ordering trait bound is all. So when user uses HPI, it basically will just pass, instead of using a suffix, it will just pass the this is actually a type, but it can use as a variable of that type because the type is 0 type. So basically, you instead of using a suffix, you pass in as a parameter, and that will just do the same thing, route it to the exact function that actually implemented the atomics. One thing to notice, if you put, yeah.
What kind of compiler error? Like, will it be clear that what we did wrong is we used a invalid ordering, or will it be like this trait is not implemented?
Right now the compiler error is not that helpful. It gives you a compiler error about type mismatch, and I think that would tell you that the ordering you are using here doesn't import the ordering required by these atomic operations. So basically, this part, so as here, so basically the foo doesn't import the acquire or relax trait, but it's not directly saying that you are using the wrong order here. So that part is, well, I don't know how to implement that, but it at least give you something. Yeah. All right, so this is my this is probably the last slide of my presentation, but I got some questions. So first, does anybody have any like a strong feeling about the generic and non-generic API? So for me, I prefer the not generic API, but I'm okay with this generic. So I would like to hear like opinions from users and whether this kind of API makes sense to anybody. Oh, it doesn't matter.
At least for the standard library atomics, I think you get a runtime error if you use the ordering that's not compatible, and that's not cool. It's way better to get the error at compile side. So.
Yeah, but if you use suffix, you also get a compile error that function doesn't exist. So.
On the standard library, I saw a thread yesterday that they are considering in the standard library of Rust to have the generic kind of API in Rust as well.
I guess my overall question is that I'm a kernel developer for quite a while. I just want to understand whether there will be complaining from kernel developers that the generic atomics may be too much. That's what I'm trying to know.
I'll weigh in as kind of a standard memory management kernel developer. And I saw this argument earlier, and I kind of went both ways. I don't think you can go wrong either way, but personally, I'm leaning toward the generics. Maybe I'm more comfortable with this C++ background long ago, but why not, especially if you have a new type. Obviously, you want to be more constrained in the kernel, but on the other hand, you may come up with a new type. We're fooling around with all kinds of stuff with DMA, APIs, and new types for struct pages. Maybe one of those wants to be atomic. If it's already generic, then we can just implement it as opposed to manually fooling around. So I would lean toward generics.
Yeah, it makes sense to me.
Yeah, I tend to agree. I think it doesn't really matter too much either way. If like the normal Rust standard library is not using a generic, that seemed to me a good idea not to use a generic. If they're planning to introduce one, that seems to be a good idea to introduce one. Could you have both? Just, have the generic and then have a type alias so people like me who are slightly scared of angle brackets don't worry at night?
Yeah, could we have both? Benno, I see you are here. Maybe you want to make a comment on this?
Yeah, sure. I can weigh in on that. So I think having both would be a bit like weird, because maybe people will then not be able to choose, or rather, people will be confused why there are two different ones, and then they see it's just a type alias. So I'm not sure if that is a good idea, because also like getting people used to generics, because we're using generics all over the place. I don't think that generics should be something scary. So I think if atomics force you to use generics, then I actually think that would be a good thing. But if we get too much pushback, then I think it wouldn't be a huge problem to add them. And I wanted to also to talk about the point that Andreas brought up about the error type. I just posted something in the matrix chat where there's an RFC for diagnostic attribute that already has been implemented in unstable manner, I think, where you can change the error message that when a trait is not implemented. So we could implement this on the trait, for example, acquire or relax, that we could implement the message and say this must be only acquire or relax, for example, and then improve the error that way.
Okay, that's great. Thank you. Yeah, Will.
Oh yeah, so this is more of a comment from the C side of things, I suppose. So I see how this maps really well to atomic T and atomic 64T. Mm-hmm. But for better or worse, in the kernel, as you know, we have rewrite once, we have exchange and comp exchange, and they work on bytes, 16 bits, 32-bit, 64-bit, and in some cases we have mixed size concurrency where you've maybe got an atomic and you use something not in the atomic API, but you might access fields of it. So is that something that you've deliberately excluded here, or how would that work with this kind of generic approach?
So for a couple of questions. So first, for compare exchange, if we only think about U32 and U64, we can just add it. And for the smaller size, like U8 and the U16, I think so. Actually, I put my code into, so this is actually linked. If you download the slide, this is actually linked to the branch. So in there, actually, I separate different atomic operations as different group. So we could only implement it like a normal read and store and maybe compare exchange for U8. And without introduce things like add and decrement for U8. In that way, and we can basically have, if people want to use U8 atomic, they can use it, but the usage will be very limited. They can only do like, for mixed size, you have to like calculate your own address and do those conversion casting, but that actually will, so the idea is that in the Rust side, we don't have the compare exchange API. Instead, we only have prompt API from the atomic. So you don't have like a read one. We will avoid to use read ones and the normal compare exchange and store SMP storage, SMP load acquire. Those things will be not used, but those functionality will be wrapped into atomic, and you can convert a pointer, a normal pointer, to a atomic reference, and you can just access that there. So that would be the plan.
Okay, thanks.
I have two questions. One is, can you use the new type also for enums? I think there is some rep U32 or something like that.
Well, currently there is no plan to support like enum in the generic atomic because there may be some soundness issue, and I just haven't figured out that what option is safe, what option is not. So currently, let me put it more clearly. So we have this trait allow atomic. It's an unsafe trait. So you cannot implement it yourself arbitrarily. And moreover, we also make sure that it's only the atomic model can import this trait. So the other user cannot import the trait, and well, we have to do this through like a review and some sort of like that guarantee. So.
Second question: have you also looked at like barriers and also the optimized barriers, like before atomic, after atomic?
So I think that would be introduced straightforward, just like a function to the C, function call to a C. I haven't really looked into how the API would be look like, so that part I haven't looked into. But I do have some idea that we can maybe have a relaxed atomic return type, which is called RMW, and you only can upgrade your barrier if you have that type. So that would be something like make sure you have the type system to check that you really upgrade your barrier with the correct like operation, but that may be too much, right? Maybe people will yell at me, that's too much. It's too much. Put too much in the type system. Have to be careful about that.
I like it. Doesn't seem like a bad idea. I don't know. Then of course you look at the code and you decide, but it doesn't seem like a bad idea.
So this has possibly been discussed before, but with this new implementation of atomics, will we be stopping people from using the old core atomics API, which has some limitations such as lesser architecture support for things like atomic U64?
So you mean, well, I'm not sure why. So Linux kernel atomics actually support all this, like even for 632 bits architecture, we sometimes support U64.
Yeah, so, but the Rust core atomics don't. So with this API being implemented, will we get rid of the core atomics so that no one can accidentally use that?
Right, yes,
break?
yeah.
We can do that probably with a clippy disallow thing that they have, or we try to get a CFG so that we really strip out the code entirely, maybe. I don't know if that would work, because maybe something the core library is using that internally, and I don't know.
All right. Any other question? Oh, input?
If I really want to just use core atomic, like inside, let's say I have something like Daniel, like a closed off codec kind of thing, and I want to use Rust atomics in there. Is that sound? Can I do that without breaking anything?
So you need to ask for a Rust C compiler engineer to tell you that, because the usually pattern of I trying to ask them question that whether I can use, so I really tried very hard to argue that we can just use Rust atomics in this kernel, but usually they either like, I don't have like a really guarantee that it would work, and also I also want to point that I also have point to them that there are some optimization that can in theory happen in the with the Rust memory model, but they said they basically told me that they won't happen. That won't happen. So, but in theory that could happen. So it's really like they have the right to explain that. So I don't really know that. If you want to rely on that, I think it's not. I don't know whether that would work or not.
I have a kind of answer to that. There's two cases. One is where you are just using atomics on something that is within your subsystem, and like your struct, nobody sees that. That's of course perfectly fine. Like nobody cares. If it's talking to something else, people will say that it is not good, but in practice, it's undistinguishable from kernel talking to user space. And in user space, you have no idea whether they're using a C memory model, ASM from the 90s or whatever. So it is like sound, even though nobody will promise that, but there is a problem, which is something that I think is also interesting for him, which is that nobody really knows what the compiler barriers are. Like, the compiler barriers exist, the signal fence in C, I don't know what they're called in Rust, but nobody has ever tried to define them. So personally, if I was writing the kind of stuff that Bokun is looking at, I would also want to put compiler barriers close to the ASMs so that the compiler knows that there is an acquire semantics there. But in order to do that, it would be nice to first have people agree on what the compiler barriers actually are.
Yeah, what about cross-language LTO would affect that?
That's something that you routinely do in user space between libraries or between kernel and user space. Like a Rust program that uses footaxes is talking to C code in the kernel that uses that implements footaxes. So he knows more. So.
Yeah, don't do it. Is what I would say. And that's not just to try to scare you. It's more that the compiler will have mappings from its memory model, the Rust memory model, whatever that might be, to sequences of instructions, right? For weakly ordered memory architectures, often there's a choice of the instructions the compiler might emit for this, and it's really important that everyone uses the same mapping scheme, right? So if the kernel has got some handcrafted assembly which is somehow subtly incompatible with what the compiler is generating, it'll probably work most of the time. But when it doesn't, you won't be able to debug it. It's as simple as that. So I would just avoid opening that can of worms if you can.
Thank you.
Another idea that we could do maybe is for the other thing that you mentioned, that core atomic. Perhaps we could eventually to use the third-party library that I think was your question, Andres, right? Using third-party code that uses core atomics, right? We could maybe try to map, so don't allow to use the core atomics in kernel code, but maybe we could allow to use the core atomics that call into your atomic types just for the purposes of third-party code that we may want to use.
So we can implement it core atomics with Linux kernel memory model. Yeah, I think we can do that. It's Linux kernel memory is really stronger than the.
Even if it is just the subset that we need for whatever library that we want to use.
Yeah. That's doable. Yes.
Or you just disable LTO on libraries like that forever. Yeah.
Okay, any other, there is no question online, right? Okay, so thank you, Betun. So we have a bit of time. We will be hanging around for 15 minutes that we have left in the session, so yeah. Thank you for joining the Rust MC another year. No, it's finished. For us, it's finished, yeah. So, we'll say, we have tomorrow, well, it's not live. It's not live anymore.
It is?
It is. By the way, as a reminder, sorry, we have the kernel summit tomorrow, so the Rust for Linux kernel summit tomorrow in the kernel summit track we have Rust for Linux, so if you want to join, please join that. Thank you. Yeah, we're done.
Okay, you're done. So that means we're coming back at 3 o'clock.
Yeah, but another set of people. It's different people. They will join.
Okay.
For us, we're done.
Okay.
Yeah. So thanks a lot for all the help.
Was it successful for you?
Yeah, it was successful. I think every year we get the room full. The thing is, this is a a bit of controversial topic, kind of, because it's something very new technology that we are trying to introduce.
Okay.
And then everybody in the room is probably people that want this to happen, but it's still controversial, it's still hard. So yeah, there is supporters. It's a bit of a special case compared to the rooms, you know. It involves everybody else in other rooms as well. So
Yes.
that's why usually people
Come in and okay.
so it's a bit of a special case. Yeah, but thank you for asking.
Oh, yeah.
It was very nice. And, it was very nice having you here. Other years when we did it in other places, you know.
Yeah. So this one is the best, of course.
I would say yes. I don't know if it is the best. It has been like 3 or 4 years I have been doing this.
Yeah.
This was one of the best. At least even the technical.
Yes.
You see the mix
very technical. Okay.
My personal opinion as not an expert in regard support of all these old architectures is sort of let's just get rid of them.
I'm very much the opposite.
Yeah, but I'm like, why? It's so much we drag it and it's man hours and like no one is building for it anyway. What does he think?
Thank you for being around.
Like this moment.
They have different kinds of origin. I think they want to expand this concept of architectures, but they don't have the manpower to do it.
I think it would be great if when there are working implementations,
Shit, I would do that.
There are times
It does have some. There's not that many. There are 2 big architectures. They have so much backward compatibility. They must spend a huge amount of I'd love to see, like, I'd love to have a glimpse inside a modern Intel CPU, like, emulation.
Because I checked that last night. I wanted to see what.
They have
Yesterday was the notification day.
maybe.
keep companies down. Sorry? They don't deserve donation. Don't delete the like statement of support. No, but they had layoffs. I don't know if you recall. Also, then they had layoffs again. Okay. But you're still around, right? Yeah. So that's good. But the director of engineering who supported like all the last stuff and of course he was laid off. Oh. I don't know how I expect from the undercover. And I thought about that. Yeah, very unfortunately. Yeah, I don't know. I try to keep with some time my best. I think it's the healthy thing to do, I think, if you're too burned out of leadership. Could be the same. It was not so much burnout. I mean, it was burnout, but not in the usual sense. It was more about the, you don't want the solutions I provided. Yeah. And he was also wanting to maybe change gears a bit also. So it's a combination of, it was not just the video, people saying, oh, what's okay? No, he's okay. He wanted to change a lot of things. He was not happy with the thing, and then what happened with the video. I'm not the presenter, I'm the shepherd for this afternoon.
from here I have to find the bathroom.
Yeah, I'll start by that too.
That sounds like a good start. Also have to wipe off the curry.
You got carried.
Yeah, I got
Carried away. We lost questions. Yes.
Oh, we lost Jörn.
What, where's Jörn? Yeah, he wasn't. He was eating lunch all by himself.
What should we actually do with the notes from the Rust people?
They must switch room on this one, right?
Do they?
I don't know. You can ask the.
Well, I think the Rust microphone is already over.
Yeah, but the notes are still in there.
Oh,
so do they have to switch room or?
Let's ask.
Yeah.
But I need to just upload this so we have the presentations.
Let me start the system on my
There. One session. I hope it's okay. Hey, are you fine with presenting from this one? I think this. I'm gonna switch presentation in control, sort of, the transit with from that one. Any laptop, and yeah, we'll get this. This is what people see, also on the online and yeah.
It means that it's smaller.
Yeah, it's just a little smaller, so yeah. I think we can close the chat, but yeah, we'll figure it out.
I can survive with this really small.
Yeah. Yeah, I think I think it has worked out reasonably for the others.
Hello, so sorry. He's ignoring you. Yes.
There's another space back there. I can sit over there if you like. No.
Oh.
Where did you
Well,
get
yeah, how do we manage this? That's interesting. I took the presenter for the Rust, but that's not working out. Yeah, so when I join, I don't know if you know how this works, but when I join now, I click on the Zone Storage entity, and I get into Rust.
I can help you with the microphones.
Oh,
Not
okay.
with the video. This is the E3 company. A guy was just here.
Okay. Because I don't know what we're supposed to do with the. Should start the other session. Now we're stuck in Rust. So I guess we have to talk Rust. The rest of the day.
Use the Danish student. He's attending all the Rust stuff and coding.
Not really, but.
And then Johannes can follow up.
Yes.
Yes.
We
Rust
can
expert.
we can show spinning Rust.
Yes. That one I know.
I just ate lunch with Andreas. He was also walking around, not being able to locate his sequences.
Oh, the two outcasts.
You can make it.
Wait, did you go outside for lunch or?
Yeah. I'm sorry, I totally didn't pay attention. I was just piggybacking on everyone else, and then we pulled up and I
Walked downtown looking for a burger place and then ended up in some cantina which was already closing.
Alright.
Wasn't the best choice. No.
That's fine. All good, all good. I lost track of, was Damien with you? I lost track of Damien. Somebody was keeping me in there. Didn't want to.
No, we just met outside.
Yeah. I should have just kept a closer tab on the Damien. Somebody with a higher position to pick up.
Everybody paid by themselves.
Oh, really?
Yes. It was like in Lund, cantina.
Oh.
Paid up front and
confused. Because there's a session per room, so it's not a session per session. So.
Not a specific session per session.
No, so we just continue where Rust left off. It doesn't matter.
Basically comparison ZNS with LPC and saying, both solutions are valid, both have their market, and started some conversations that we should uniform how we proceed with placement, handles, or generally like giving hints to the device. See the slide stack?
Just give me a second. I'll finish this first. Yeah, it's good if everyone's in the front and we can rotate. Take percent. LPC, okay. LPC speaker and LPC speaker. Two LPC speakers. This is the laptop for presenter. So we can go through on a break, and we can also should be able to switch presentation here to intro. See if that works. So this is your you have the last one. That's yours. Yes. I think I've downloaded all the right ones. This mic is pretty good. So yeah. And we should have a catch box. I hope. No, I think it's like this is this. I think does it sound good?
Sometimes
It depends on how the intensity of the answer. Listen very carefully. I will say this only once. Yeah, but the sound is awesome. Oh, there's one of these as well. So that's just doesn't work. Or off, on. No. Yeah, so Slava, when you change slides here, it's just, you have to actually push, like...
It's not button.
No,
it doesn't work.
I don't know why. So that should be, that's something will be hard to fix, I think. Yeah. It's easier if we just keep on this laptop, I think.
Anyway.
Yeah.
can't be seen like this.
Basically, from we got into the car until we were at the hotel, playing very, very loud Eminem all the time.
Oh, I would have been there.
He was using his headlights constantly.
Was that loud? Is that the Autobahn?
I don't think that's allowed how he was driving. But
No, there were signs saying road work and 60 kilometers an hour. So I'm pretty sure it wasn't allowed. But,
Okay. One driver license, two driver license. Fair enough.
Oh. Yeah. David, when you switch between, yeah, I can show you what's going on. I will start the presentation. But no, but you need to push that thing
next.
Yeah, because the arrows doesn't work for some reason. This thing doesn't work, but they seem to be working.
Or I can just say next and you push it.
Next. Yeah, I can take presenter and just control the whole thing from. Could do that.
Could do that too, yeah.
If it doesn't work, I'll do that. I can just do that when I.
So yeah, we really have to use the touch screen to well.
What happens if I do
slide?
If I do seriously. If I say take presenter here. Put it here.
The remote doesn't work either?
No. Oh, I can change from here.
It's fine, I can do it.
Yeah. But it works just in case things are messed up. I hope so.
Okay, so like, so I'm tech support for this session.
Okay, yeah. But so what I see here is like the arrows do not work. So we will have to click on this thing via the mousepad, and this thing doesn't work. Maybe.
The click work.
That's the only thing that works. Yeah.
That's sad.
Yeah, but it's not a biggie. Yeah.
December 2nd, that's the week to remember.
If you do full screen, then yeah, maybe full screen is better. But it's just 3 slides.
3 slides. That's why it doesn't work anymore. Okay. Okay. Yeah, I think full screen helps.
So we do full screen mode on this.
And I think here you can choose which presentation.
Exactly, yeah. But we're gonna do that first anyway, right? Thanking the sponsors and stuff.
Yes, and the sponsors.
And then go to do the intro.
Oh, it's already uploaded. Okay.
They're already uploaded.
Yeah. So then we're.
So how do you go from full screen to not non-full screen?
Escape.
Escape. And then to full screen is.
Here.
There we go. Ah, full screen. Okay.
Full screen.
And it looks the same here, right?
Yeah.
It doesn't matter. It's just this.
Yeah, it's on the cloud, so.
Yeah. This is just a local one.
The same thing.
But why is okay? So this is connected.
I think it's not useful at all.
No, but
So, like,
that's what
even
Steven
we have
said.
1 minute, let's not
We
touch
still
it.
want to have the shared notes. Because the shared notes are still...
Yeah, we are fine.
The shared notes are still up on the big screens. I'm not sure if you want that.
It's the Rust share notes as well.
think
It's the
so,
previous.
yes. Yeah, it's for the previous block.
Yeah, it's the previous block. Yeah, but we can.
So we should have something.
We can just copy them down and send them to the rest people.
But we can continue them afterwards, or? Oh, yeah. I don't know if someone's going to edit them out, but I don't think so. Could you say?
Oh, we don't see it here. So.
No, you can see it here, and you see it on a big screen.
Yeah.
It should be a separate one.
I wrote that.
Because you read from them. I think you know, have it all in your head anyway, so should be all right. Yes, we have a summary. It's Johannes. Okay. And then we'll do the QEMU. Yep. So it's 3 already? It's gonna be fine.
Stefan, don't ask difficult questions. Hans wanted me to speak. I don't really need to.
Well, now you do.
I still stand here, looking surprised I'm here.
Klaus is there. That's nice. I think it's time, no? Should we close the door or? All right. All right, guys. It's 3 o'clock, so I think we might as well start. So we finish up with the first round of presentations in time for snacks and coffee. We probably need it. It's been a full day already, but I hope you guys still stay in the zone for the next few hours. All right, before kicking things off properly, we have to give a handout to all of the sponsors. Without them, this thing wouldn't happen. So thanks all of you guys. And, oh, need to push the right button. We also should respect the anti-harassment policy. We'll not go into the nitty-gritty details of this, but the essence of it that we should respect each other's opinions and argue as much as we can without going into personal insults and so on. We should just be, or at least try to be excellent to each other. And with that, we can go into the MC intro. Dum, dum, dum. There we go. And should start at the first slide. We can go full screen, so then the actual arrows work. Yes. So, yeah, hi everyone again. It's really great to be back. We did a Zone Storage MC 2 years ago in Dublin. That was packed with presentations, and we're really glad to be able to do this again. So I'm running this, and I've been working on making this happen together with Johannes. And I'd just like to thank everyone who's now in the room and online. It'd be great to get your feedback on all of this. And we'll try to run things a little different from the last MC. In that MC, there was a lot of presentations and a lot of information, but it turned out to be pretty one-way. So we've divided up this into 2 halves. The first half will do a quick retrospective and try to summarize what we have today. So we'll do, I'll do a quick overview, and then we get a round of lightning updates from Damien, Johannes, and Dennis. Will present their respective areas they have sort of looked up the state on. And then we'll do some more in-depth presentations on ongoing efforts. So we'll look at QEMU development being done. I'll present what we're doing for XFS, and Slava will present SSDFS and where that is at the moment. And then we'll go into the second half, where we'll do more BOF-like things. So Slava will start off with talking about how to sort of distribute and virtualize zones, has a proposal for that. And then we will go into a number of topics that I've gathered from the community that hopefully we're going to spark a lot of discussion. So feel free to have feedback on and ask a lot of questions during the presentations, but we might have to put some of those discussions in the second half just to make sure that everything is covered before the break. And if you're connecting remote, please raise your hand or turn on video. Could you monitor, see where, yeah, to make sure that your voice will be heard as well. Cool. So let's try to round up where we are today with Zone Storage, because it's a thing we've been working on for some time. And to look where we are today, it's good to sort of go to the beginning and start from there and see how things developed. Try to dig in this just now over lunch with Damien, how it all started. And it started somewhere back in, 2015 with SMR drives, with work from Hannes and Damien to get the block layer support. And SCSI, of course. And that was followed up with F2FS support, not too far after that. And I think that was mainly Damien's work.
Yes.
Yes.
Roughly.
Yeah, and we also had some really interesting research going on around that time. Back then, Albertali Bagayev drilled a hole into a hard drive to sort of reverse engineer the operation of single magnetic drives to figure out what's going on. So he drilled a hole, put a high-speed camera in there to watch how the heads were moving. You don't need to do that anymore. Now, the operation of zone storage is pretty well known. Yeah. So that was just the first of many interesting research papers. The second one here, that's on the sort of research swim lane, is work on LSM trees, how this fit zone storage on these formats. And a lot of other research has been done since. So by now we have a pretty well-researched technology. So I think we covered most use cases, from caching to file systems to direct application integration. And these things that I've just listed in this presentation is just like a handful of interesting stuff, but there's so much more if you want to go into what has been done in the research community. So we started off with SMR, and after, I don't know, what was 5 years, we managed to also squeeze in flash support into the same sort of semantics as SMR. So we got zoned NVMe drives in the form of zone namespaces. And with that, we got a host of application and QEMU enablement, had support in SPDK. The Samsung guys released XNVMe with CNS support. ButterFS support stabilized around that time. And that was followed by distributed storage support in Ceph and this SANFS. We're supporting uBlock now, and lately we've also had the addition into the zone storage model of UFS. So we have zoned UFS. So by now we cover like 3 very big usage areas of storage. We have hard drives, we have SSDs, and now we also support storage into mobile devices in standards and in the storage stack. And there's also research has been done in all of these areas. So that's where we're coming from. So this is where we have sort of landed today, where we have, I think, pretty good tools and library support. I don't think we're missing a lot in that area. We've also done a lot of end-to-end application enablement. We can run MySQL sort of natively on zone storage, along with RocksDB and ByteDance. Invested quite a lot in making their key value database, TeraDB, work well with zone storage. And they've also continued developing new databases based on this technology. And by now, we also have pretty wide local file system support. So F2FS now supports zone mobile flash. ButterFS works very well now on both zone storage and SMR. And we're adding support into XFS. I'll talk about that later. And yeah, we have, as I mentioned in the previous slide, also like bigger storage systems supporting CNS and SMR. Like Ceph, OpenABS, and MayaStore for cloud stuff, and SPDK, and so on. And we have distribution support, so you can just install a normal distribution without any hacks and just use zone storage. Yeah, so that, I hope, gives you like a quick overview where we are today, and I'd like to just hand over to Damien, who's going to do updates on ZoneFS and IO Stack.
Yeah, so the support for zone storage in IASAC, the recent biggest change that happened, well, actually the main change since essentially the start of the zone storage support was the change to the sequential write ordering control that is necessary to get sequential writes per zone working on these devices, since the I/O stack, the block I/O layer inherently has no guarantees about the ordering of commands within the stack. So there has been since the start ordering control for writes to zone block devices. So that was before done using the MQDeadline I/O scheduler. So the write ordering was implemented within the scheduler. So kind of a completely unknown to the remaining of the block layer. So that was working fine. However, that was forcing the user to use an I/O scheduler, which has overhead, which can be a problem if you have a very fast device like an NVMe ZNS SSD. And so we worked on removing that write ordering control from the block I/O scheduler into the block layer proper. So that was done with the implementation of zone write plugging and that went into kernel 6.10. So the principle of that control is the same as before with the I/O scheduler. It is that we only allow at most one write per zone in flight at any time, so that we never get reordering of writes within a zone. The writes going to different zone may get reordered, but that's not an issue, and everything works as is. So there is essentially no change in the I/O pattern for writes that you were seeing before with MQDeadline. Zone write plugging preserve the same model, and it's been working great and stable since 6.10. We are actively testing that every week against every RC, and so far we have not found any problem, any issue. It's been very stable. So advantage of that, again, is that we can remove the dependency on the I/O scheduler, MQDeadline. So you can now essentially use your zone storage with any I/O scheduler you want, BFQ or Known or Kyber or whatever you own. There is no dependency. It's still going to work the same way. That also allowed us to move a lot of the kind of zone-specific code we had in the device mapper and SCSI layer into a generic implementation in the block layer, so that simplifies DM and SCSI. So in particular, the zone append emulation is now generically implemented in the block layer. And that the removing of the block I/O scheduler does increase performance significantly for SSDs. The single drawback so far that we have identified is that some drives, some HDDs, actually don't really like to see gaps between writes to consecutive zones when you are doing a fully sequential write I/O pattern. And some drives, depending on their internal command scheduling, will generate a seek between these two writes. So you do get some performance drop when you cross zone boundaries. Total depends on the drive, and vendors suffering that have been notified and working on firmware improvement to avoid that. So the other area which I maintain is ZoneFS. So there's not been a lot of changes recently, mostly just some small bug fixes in the error recovery path. Conversion to the new mount API and large file support. That's the main thing. So no functional change whatsoever. It's been stable. It's used in production by many users of zone storage, of SMR drive in particular. What we are looking at, however, is extending kind of the write I/O interface to be able to issue zone append operations, so append writes from user space. Since zone append writes do not go through the zone write plugging that limits the number of writes, you can actually write at high QDEPs using zone append operations, so increasing performance. However, there is no user interface to do that, and ZoneFS itself internally is not using zone append. So we are working on trying to add this interface. Most likely that is going to happen through I/O ring. So these are kind of the areas we're working on for ZoneFS. Johannes, you want?
So for Btrfs, we have the initial upstream support since 5.12, which is feels like ages ago. We added garbage collection in 5.13. There's still odd bugs here and there. NVMe ZNS support got added in 5.16. Experimental RAID support got added in 6.7. But you currently have to compile the kernel with the config option Btrfs debug and compile the user space tool with experimental features enabled. We're still in the stabilization phase, so the more users trying out, the more bugs we find, obviously. RAID support is very experimental at best. Let's put it that way. It's even worse than RAID 5 support on normal Btrfs. And the metadata overcommitting and space accounting has some odd counting bugs here and there. But I hear from some people that are using it on single SMR disks that it's pretty stable. So we're getting there. Next one's Dennis.
Okay, yeah, last but not least, cloud storage and virtualization. So we have SPDK, we have support there for ZNS since V2010. And there's still some ongoing effort with some minor bug fixes and smaller feature completions. Yeah, lately there was a paper published from Alibaba and Solidigm. They published a paper CCell, Cloud Storage Acceleration Layer, which shows benefits in the total cost of ownership for Alibaba deploying its own storage in their cloud environment. And yeah, the ZNS patches are to be upstreamed because they are just work-in-progress patches that are not yet on the list. In Ceph, with the latest release, Reef, that is stable, Crimson OSD was introduced and has also initial CBD support. However, there needs to be some active zone resources accounting to be done. This is not done at all in the code base yet, so that has to be added because otherwise we are running out of active resources on ZNS devices. For SMR disks, it's probably fine for now, but yeah. Then on Kubernetes, we have OpenEBS's storage stack via the MayaStore engine, and there is an open pull request for initial ZNS support, but we are having right now discussions if that is the right way to do or if we should utilize CCell rather, because MayaStore is also working with SPDK under the hood, so that is a natural fit maybe, so still ongoing discussion there. And yeah, Sam will talk next about QEMU. So we have initial ZNS emulation support there, and we can attach ZNS devices via VFIO and VirtIO BLK. SMR disks can also be attached via VirtIO SCSI and vhost SCSI. But because the initial emulation doesn't persist, yeah, the QCO2 support will be added. So yeah, zone storage can be emulated and persisted. But Sam will talk next about that. Yeah, if we don't have questions right now, I think we can start with Sam with the first in-depth talk. Please. Do we have to change slides?
I can
here?
just change the presentation here. Let's see. There we go. That's yours. Slide one. Maybe full screen is nicer. And you can use this one. Yeah. Okay. Takes a little bit of time to render.
Hi everyone, my name is Emily. a software engineer working at INS. Today I'm glad to talk about zone emulation support for QEMU. First off, I'd express my gratitude to Damien, Stefan, Dimitri, Harness for their guidance and support. I've gained a lot in the QEMU community as well. First, let's look at the state of zone storage in QEMU. As you may know, the zone storage concepts are standardized as ZBC, ZAC, and ZNS protocols. The versatile protocol for block devices should also be aware of the zone devices instead of taking them as regular ones. It should pass such devices to the guest. Zone block devices on Linux can be exposed to VM via versatile SCSI or versatile block emulation. You can attach a zone device to QEMU via versatile SCSI, or you can attach a zone device or a QCOW image file to QEMU via versatile block emulation. There are not much difference between versatile SCSI or versatile block emulation, except that zone append emulation is done by the guest kernel SCSI disk driver for versatile SCSI, while versatile block emulation emulates append rights for versatile block. QEMU also has its own MME device emulation. With ZNS support, it can be used for development of kernel features. You can also attach physical PCI adapters can also be attached to VMs if you don't want QEMU emulation involved. Let's play with the emulated zone device a bit and see how to store files to a zone storage using BetterFS on a QEMU VM. First, let's make sure the environment is ready. QEMU supports zone device emulation since version 8.1. The suggested version for Linux is above version 6.3. Secondly, create a zone block device on the host and boot a VM. Then you can check if the zone device in the guest through the kernel logs, or just use ls block-z. From the picture on the right, you can see there is a zone device called VDA, which is host managed with 12 zones. If you want to store files to a zone storage using BetterFS on a QEMU VM, it's pretty much like doing that in the host. First, create a BetterFS file system with VDB device and then mount it under the MNT directory. Then create a subvolume and move the text file there. You can check if the file persists by shutting down the VM and restarting it again. The same text file will be there if the device is remounted. Then let's look at the command line details for setting up the environment. There are two block backends you can pick from. The first one is now block devices. By specifying the zone option to 1, you create a very simple zone devices. You can also use the scripts on the zone storage side to create a zone device with more options like a number of zones or zone size. Likewise, you can also create a QCOW file with zone format with a few more zone options like max open zone or max append bytes. To expose the zoned block device on the host through volatile block, you should configure the driver to host the device and enable the direct cache option. This is necessary because the kernel page cache doesn't guarantee the sequential write constraints which is required for the SWR zones. If the risk condition arises, it's likely to disrupt the original order of page writes. Similarly, to expose the QCOW file with zone format through volatile block, you can use the command line as follows.
Sam, just a quick question.
Okay.
So didn't we force to on the cache direct option in the case of a zone block device? Why do we still need to specify it? It should be on by default to avoid the user making the mistake, essentially.
Is that so?
Stefan, do you remember? Do we have that?
I don't remember.
We should really, or error out if it's not turned on.
I think there will be a warning if you don't set the direct cache, but
No, but in that case, for example, it has to be on. Otherwise, you're going to see reordering, and it's not going to work for the user.
Yes.
So we have to prevent that.
Yes. For developers who want to contribute to zone emulation, QEMU, there are some tools I find useful for testing and debugging. QEMU IO can run zone commands using new block layer APIs. You can also use the QEMU IO tests called zone to check the overall functionality of zone operations. If the QEMU IO test passed, you can move on to the guest machine to where ZoneFS tools will run a more thorough test on the zone operations of a zone file system with the attached block device. FIO and block tests are optional to run if the ZoneFS tools tests are passed. If you want to issue a single request at a time, you can also use DD or block zone commands. The debugging tools are common ones, as you've known. You can use address sanitizer or Vagrant for memory errors. Or if your VM crashes or QEMU crashes, you can use the core dump control tools with GDB to see the backtrace. Ftrace, blocktrace, and strace are also very nice tools to find the root cause of the issues. Unlike device pass-through, volatile block emulation hides the device types and adds more flexibility. The storage controller emulation uses the new block layer APIs instead of directly accessing the disk image. The zone storage APIs support zone models and full zone management commands, and also append zone. the QEMU block layer has a block driver state graph which propagates the device information to the volatile block device. When volatile block device receives the block driver state, it will send the zone feature bit to the volatile block driver. The volatile block driver will recognize the zone device. When the guest OS runs the zone commands, the volatile block driver will issue the requests which will be captured by volatile block device on QEMU. Then it sends the request down to the file POSIX driver where it performs the zone operations using Linux I/O controls. There's work in progress to support emulating zones in the QCOW file for testing and bring up. The full emulation support is useful for developers who want to access a zone device environment without real zone hardware. It has a easy zone storage setup and provides persistence to the metadata. From the picture, it's the structure of in-memory data buffer when a QCOW file is attached to QEMU as a ZNS drive. The zone descriptor extension data is host-defined data that is associated with each zone. We also need to think about maintaining the zone states and guarantee the zone metadata persistence. As the layout of disk image shows, the metadata of QCOW driver is put to the end of the file. The red pointers and header will also be stored at the end of the disk image. The size of zone descriptor extension data of each zone is relatively small comparing to the overall size of the disk image. Therefore, we store the zone descriptor extension data of all zones of the device to the one place. The zone state machine depicts zone state transitions and zone resources. The read-only and offline states are device internal states, which will be ignored in full emulation for simplicity. The other states are empty, open, close, and full. Sorry, can I just look at my scripts I've written before? If the guest or QEMU crashes, the zone states are needed to recover. In real devices, open states will be lost and turn into closed state after a power cycle. The write pointer array is composed of unsigned 64-bit integers, allowing space to store zone information like zone states. When considering to store zone states or not, it turns out in-memory states are good enough without extra cost on state assignment to write pointers and writing back to disk when the state is updated. The reason is that QCal2 keeps track of open zones using doubly linked lists. When reading the state of the zone, it will first check if the zone is in each zone list and check write pointer when finding none. The calculation is straightforward. When the write pointer value is equal to the offset of that zone, the zone state is empty. When the write pointer value is equal to the offset plus the zone size, the zone state is full. Since we can induce the empty and full states on open and open zones are tracked in memory, the zone left will be in the closed states. Another kind of in-memory state is zone resources. It has open and active zone limits which affect zone operations. Write requests on zones no longer execute when any one of the zone limits is over. If there's room left for active zones, the device can implicitly close one zone to avoid exceeding open zone limits. There's also work in progress to support NVMe ZNS, which currently only offers volatile zone states and is not suitable for running production VMs yet. There have been several approaches to persistence when ZNS emulation was introduced to QEMU. One is to use separate mmap file. However, the QEMU block layer does not support mmap. A block driver state may not have a file descriptor that can be mapped. Another way is to add a separate block device, which is more suitable with the QCal2 zone support. QCal2 is better than RAW for its popularity in virtual image format. That's why we add the full emulation to QCal2 driver instead of creating another zone format driver. By taking advantage of new block layer APIs and the QCal2 image as backing file, we only need to care about the ZNS-specific metadata, such as zone attributes. When the direct memory access flag is set for NVMe device, the zone append requests are required to handle memory mapping first. NVMe device internal memory stores data directly from the guest, depending on where the IOQs are stored, host or NVMe device. Normally, the guest address will be translated to host address, but if it's direct memory access, the guest cannot map the address and will trigger a bounce buffer. The host will trap it and asking if NVMe device knows about it. Only one bounce buffer in flight is trapped. In the end, we'll discuss one of zone attributes shortly. The zone random write area is a legacy bit for adaptation. The valid bit for ZRWA is only in runtime. The old drives do not support sequential write constraints and set this bit to valid. All writes to zone random write area must be persistent while the write pointer is not advanced immediately. Finally, what have been made so far is the zone storage APIs are added to QEMU block layer. The zone storage support is implemented in Vertile block emulation. Adding full zoned emulation to the QCal2 driver and persistence to NVMe ZNS emulation are in review. To complete the zone storage picture in QEMU, there is also work to be done, such as adding full emulation to Vertile SCSI. And now with this summary slide listing what I have contributed, my talk is concluded. Thank you.
I hope it survive. It work? Okay. So I have simple question because I was confused slide something like QCal2 format or something, because zone usually is bigger than physical sector, but I see something like data sector is smaller than zone. Is it true, or maybe I'm missing something here?
Sorry.
So data sector is it physical sector? Usually smaller like zone in size, because zone is bigger usually. So is it correct, or what I'm missing here?
This data, the data sector here is just a part that I named for this chunk, not the actual sector.
It's not an on-disk sector.
Sorry?
It's not it's not a single on-disk sector.
Yeah.
Yeah. Does that answer the question? Okay. And I just have a general question. So now we're getting QCal support with states and everything. Do we have a way yet to dump out a drive state and load it into QEMU for debugging purposes? We should be able to write a tool that does that, right?
Well, yeah. I mean, it's in the QCo image. It's in the QCo image. You only need to read that file and look at the metadata at the end. So.
Yeah, but we don't have the tooling yet.
Well, no, but that would be trivial to do.
But having that would be really cool for debugging weird file system corruptions and so on. You could just dump an image and load it into QEMU. So this is really nice work.
Thank you. Thank you for bearing with me.
No, thanks a lot. Yes, just to complete.
Yeah.
All right, next, talk about zones in XFS. Yeah, this should work. Right, so if you just tune in online and you don't know who I am Hans Holmberg, and I've spent the last few years hacking on zone file systems, but in user space mainly. I worked on a user space file system for RocksDB for database workloads called ZNFS. For the last year or so, I've joined this project, that's on XFS, And I'm really happy to be able to bring over some of the research and hacking I've done on ZNFS into this project, doing a little bit, a small part of this. And there we go. So this is nothing that came like out of thin air. Zone XFS is something we've actually been talking about for a long, long, long time. But it really just kicked off last year. For 23, yeah, sorry. I know this is a week of off-by-one, sorry. Yeah. Yeah, all right. And the current state of this is that it's experimental, but it actually works across a number of different types of sort of zone layouts. So it supports SMR, CNS SSDs. We've been running tests on both, and they can handle large workloads. It should also work fine on Zone Mobile Flash, but I've only managed to emulate that and just try it out to see, sanity check to see that it should work there as well. Currently, it passes 99% of applicable XFS tests. We all know that the last percent is the hardest, right? So we're working through the last bits there, but we're not too far away from actually having all the applicable tests passing. The code is not upstream yet, it's not even RFC, but you can access the code if you go down and download this presentation and go to Infradead and check out the right branches and build this. So you can play around with it in an emulator or on hardware if you want. And this is a thing that has not been like a single-man effort. We first and foremost depend a lot on Derek J. Wong's work modernizing the XFS real-time feature. So we sort of add on top of all of that good work. And on top of that, Christoph has done most of the actual work for Zone XFS. And Damon has been helping out doing testing and tuning for SMR, make sure that things work out in that scenario. Shinshiro has also helped out with testing. Myself, I've mainly worked with the data placement parts, on space accounting, making sure that the sort of logical space we expose can actually be backed by the zones we have on the devices we have running zones on. And I spent a lot of time debugging and fixing up stuff around the garbage collection. So I'll focus on those parts. I'm not an expert on whole XFS. I only worked for it 1 year, and it's a very old file system. But I'll try to cover stuff in general and those things I've been working on in particular. So to try to grasp on to understand how this works, we have to first look at how XFS stores data and metadata. And data is stored in XFS in allocation groups. And these are virtual regions of fixed size. And each allocation group manages its own set of files and manages its own backing storage. So by splitting it up, you sort of divide and conquer the storage space you have, and you can provide scalability and parallelism and avoid choking points. So that's great, and it sort of looks like zones, doesn't it? So that looks like it shouldn't be too hard to add zones to that, to store those things in zones. Metadata, on the other hand, is a much harder problem because in XFS that's stored into B+ trees, and B+ trees are not a good fit for zone storage. They require in-place updates, so you can't do that on sequential write required zones. It's incompatible with the append-only writes we want to do. So what do? Well, the XFS real-time feature comes to the rescue. And we can utilize that to separate data from metadata into different devices. So the XFS real-time feature is a feature that's been there for a long, long, long time in XFS. And it allows you to specify one device for metadata and one for real-time sensitive data. So that's what we built for originally. You can specify a separate device that's gonna only take the stuff you really care really about the latency for the accesses on those for the specific files. So by building upon this, we can keep the B+ trees and focus on storing data on zone storage for now. And if you mount the file system with the RT-inherit1 option, you place all data from all files onto the real-time device. And we're gonna enable real-time, or have enabled real-time device data onto zone storage. And it looks something like this. So we end up with this layout, where we depend on conventional block storage for metadata, and it comes up with the limitation that we can run out of space on the metadata block device before the data device and vice versa. But this is a common problem. This is just good to be aware of. And although we need two separate block devices, doesn't mean that we can't have it on the same piece of hardware. We can have an SSD with two different namespaces, one conventional namespace for metadata, one zoned namespace for the data. Or we can use conventional zones on SMR drive for the metadata, as long as we split it up via DM linear, for example. So once we have this split, we can map the real-time allocation groups, storing data, to zones one-to-one. So it's a really nice fit. And we utilize copy and write to avoid in-place updates for data, so you can always store things append-only. We implement a new data allocator that treats zones as buckets, and we fill them up with zone appends. So that sort of provides us with the structure we need to be able to store things. But we have some opportunities with zone storage. We can actually manage data placement. And how should we design this allocator is a research question I've been looking into a lot. So zone storage allows the host to make active choices for data placement on the media. This is sort of the selling point for zone storage. You can get also higher capacity by overlapping tracks in the SMR case and forcing sequential write patterns. But you also can have better performance and better endurance if you place data in a good way. So how should we do this? How can we have a generic algorithm for doing this? That is something that I've been playing with, and we come up with a pretty generic algorithm that sort of aims to make sure once a file is deleted and that file is big enough to cover a zone, that zone can be reused without any other reclaim. So we can minimize garbage collection. So what we do by default is data placement by file. So a lot of modern workloads generate pretty big files, which are in the order of magnitude of zones. So we try to separate files into different zones, and if we can fill them up to a reasonable degree, we can get by without moving stuff around too much when reclaiming. So what we do is we keep up max n zones open for writes. And this number can be configured by the user or depend on hardware limits of the device. So it depends on the device capabilities, but we can have a handful or many open zones at the same time. And what we want to do is to separate data from different files into different zones as far as possible. And once we reach the open limit, we're gonna just pick the least recently used zone if an empty zone can't be assigned. So I made a little bit of stop motion to illustrate this. So if you first write file A, that's gonna end up in one zone, and probably the user is not gonna match the zone capacity perfectly. But in this case, this is a modern workload. It can do a long, big file write. It will fill almost the zone in a good case. And if we write file B, that might not be as big, but it's going to end up a different zone. So at least we've separated the data from file A. And we write file C. It ends up in a third zone. But now we're at the limit. And once we have to write a new file, we are forced to fill up one of the zones with that is currently open. It means that we're going to fill up a small section of the first zone and write the rest to a new one, and so on, so forth. But we end up in this, in the end, with this short example, that we have a pretty good method for keeping file data separate. And if we want to reclaim the first zone, for example, we just have to, and if file A is deleted, we just have to evacuate a small amount of data. And so that's the default, and that works quite well. And the workloads, the applications just have to write reasonably large files. And the file size, like the optimal data placement file size, is actually exposed by XFS. You can read that. So I'm planning to add that support to RocksDB, for example, saying that you should probably write files this big and things will be better for you. So that's something I'm planning to do coming month or so. And talking about RocksDB, RocksDB has an internal view, and it can sort of foresee the future for its files. It stores its key values in a sort of string table hierarchy, and it knows that some files will be living longer than others, and it actually provides write hints to the file system via an F control. This is what we have today to provide hints to file systems and blocks, block devices. So we utilize the hint that the RocksDB gives us if this data is, or this file is hot or not. And we co-locate file data if there's a good match between the expected lifetime of this data stored in an open zone with the incoming file data. So we sort of tag the open zone with a current data temperature, and we try to match that in a good way. And if there's not a good match, we just try to separate data, just like we did in the default allocation scheme. And the current algorithm, or the current matching sort of function that's illustrated here to the right, is based upon statistical analysis of RocksDB SSD tables. So that's just one use case, so we need to do a little bit more research to see if this algorithm or this heuristic is good for more use cases. But the basic idea is try to separate files as far as possible, and if we have to co-locate, we try to combine data from different files with matching temperatures. And one of the responsibilities that comes with active data placement is we also have to do the garbage collection. So to reclaim unused written space, we need to do reclaim. So we have a really simple setup at the moment, nothing fancy at all, standard stuff. We do this lazily, so we don't do any proactive garbage collection. We just start and kick off data, reclaim when we can't keep enough zones open to do this data separation in a good way. We just pick the lowest hanging fruit all the time for zones. We don't try to do any smart estimates. That works most of the time. Dennis did his thesis on this, and that's a good default method. We haven't done anything fancier than that. And the only trick we have is that we allocate move data separately from user writes. So if we have garbage collected data, we will put that in a zone that's not going to mix with new data coming in, which sort of leads to a nice hot-cold separation. So it's just a standard good trick to use in this type of algorithms. But another headache that comes with the data placements and garbage collection is that we have to make sure that garbage collection keeps up with user rights. So if you have a really heavy write user workload, we have to make sure we reclaim data at least in the same rate as data comes in from the user. And that means that we have to slow down user writes to match the reclaim rate. And to make these things worse is that the minimum reclaim unit in a zone, once we have filled up a zone, we have to evacuate all the data out of it before we can reset it. And if fragmentation is high, we actually may have to evacuate several zones before we can have one zone to give back to the user. So we might have to clean out stuff out of several zones to allow a user write. And we can't really block during that time because that can take seconds and we'll have enormous write latency hits. So what we come up with is a scheme to rate limit user writes and try to estimate how fast we do this by looking at the current level of fragmentation. So we don't have to block for several seconds when we reclaim. Yeah.
So it's nice to say we throttle, but how actually do you throttle?
This is in the next slide.
Ah, cool. Okay, yes. So present the next slides then.
Yeah, so this is a tricky problem. So what we do when we're running low on zones, we awake the garbage collection daemon and make user writes reserve free space before we allocate. So a user comes in, a write comes in and wants to allocate space to writes and 3 blocks. And then we're gonna, if we don't have that space available, the user is gonna reserve it. So it's like just making a reservation at the just to be able to write later. So if the reservation cannot be covered by existing free space, the write is actually put to sleep until enough free space has been reclaimed to cover a number of blocks for the incoming write. So it's just going to wait in a queue. And the free space is produced in the garbage collection daemon in small chunks, and that is the key to avoiding big latencies hits. We sort of continuously update an atomic counter, freeing up user writes, waking them up as we clean out a zone. So we don't wait for a full zone reclaim to wake up a bunch of users. And we can do this by estimating how long it will take to evacuate the current zone by taking the fragmentation into account. So it's sort of complicated, but please go back and look at the slide, and maybe if you have any questions on the actual implementation. It would be good to get more eyes on this. But the basic idea here is to updating sort of reclaim space counter in small increments and waking up the users who had made the reservations according, sort of matching that speed.
But if you do so, don't you increase fragmentation? Don't you increase fragmentation?
How?
Well, the user writes, and the assumption is that it's writing a large chunk.
Yeah.
Which, from the user's perspective, is pretty much sequential because it is a large chunk of data.
Yeah. Yeah.
You just happen to have not enough space to write this data.
Yes.
If you free up small bits and only write down small bits and then wait again until another bit is freed up.
Oh, yeah, but
then clearly, yes, this small piece is, but then this user might be the only one which is throttled, or the other users will be throttled too. So
yeah, but they're done in order, so we're not like round robin. We reserve the rights in the order that they come in. So if
okay. So you serve one user first and then the next one.
Yeah, if it wants to write, someone wants to write 256K, then another user thread is gonna write 16K. You're gonna serve the one first. So
have you experimented with partial writes?
Partial what?
Partial writes, because that would be the alternative way out. You could just have returned einter. I'm sorry, mate, I couldn't do it. I only wrote 4 bytes of your 20.
Yeah, but if the pressure is high, you have nothing. Like you can just, you have to wait somewhere.
Yeah, sure.
Yeah, so we have like a specialized wait queue for this. A lot of fun hacking in this area. Rarely you have to put the user to sleep yourself. Yep. So is this thing working? Looks like sort of complicated, right? But it actually, we've been beating on this for, I don't know, 6 months now, and it's fairly stable. You break it from time to time, but this seems like the method is robust enough. So I think we have time to try to show this demo. And I don't know. Yeah, you can actually see the text. This is a demo showing a sort of newly invented interface we've added to an obscure feature called mount stats. I don't know, maybe it was obscure for me anyway, where we can provide sort of introspection into how how zone XFS is allocating and what the sort of internal state of open and garbage collection zones is. So you can see what's happening via this interface. And the test here is to use a virtual non-block device with 64 zones, with max 16 open zones, 15 data zones, 1 dedicated to GC writes. And first fill up the drive with files of random size, up to 95% capacity, and then do a sort of mixed write and delete workload for those files, forcing garbage collection. So you're gonna basically fill it up with a lot of random file sizes and then deleting and writing new files, basically really fragmenting and stressing the garbage collection to be able to write new files. This has now been upstreamed in a generic XFS test, so you can run this also on all kinds of file systems. And I'll see if I can share my video. Yes. So now it should start. No, it doesn't work. Yeah. Oh, yeah, it's just a delay. So first you can see the open zones being filled up in least recently used order. And once we have reached identified capacity now, the garbage collection kicks in. And you can see that we have a flag here that states if we need reservations or not, if the user is forced to wait for a small period of time before we can serve their rights. And this has been super useful in debugging all of this. And I think that makes the whole sort of allocation scheme and sort of inner workings quite visible to the user. So if you have any questions, I think we can cover them in the end, but let's see if I can stop this and also show some benchmarks we've been running. So one of the standard things that people do when they benchmark data placement is to run RocksDB and see if we see any benefit. So that's what we've started off doing here. So these are some really early data placement benchmarks to see if we're on the right path. We should be able to provide significant advantages for this use case. And we use recent RocksDB with direct.io. We first fill up the file system to 80% using fill unique random. That's a workload that's generated by the test tool dbbench. And then we do overwrites and read while writing workloads. And we compare this sort of apples to apples with a conventional drive using vanilla XFS. This is not a bleeding edge, but it's a fairly recent iteration of our code. And what we can see here is that data placement by file, if you compare the XFS zone with the XFS conventional cases here, only just separating different files into different zones provides almost double the throughput in these cases. So we reduce the write amplification by a factor of 2 without actually modifying the application. And if we add hints support on top of that, we get another 10% on top of that. And once we have that, we can actually surpass or be on par with the performance we got with ZNFS, which was specifically built. That was a file system specifically engineered for RocksDB. So there is a way to do generic data placement. We just have to make sure it covers more and provides advantages for more workloads than just RocksDB, of course. But it's a good start. So I'm happy, maybe in the future, be able to retire ZNFS and just use XFS instead. So what comes next? Well, we have to upstream this. We have to make sure that the outstanding XFS real-time dependencies are resolved first. Derek and Christoph is hard at work with this. And then we need to get the stuff we've added to XFS. It's about 3,000 lines of code. Some changes to MKFS and XFS tests. So we're getting there, so look out for the RFC if you're interested. It should be coming. I'm not saying when, but not too far away, I hope. And in parallel to that, I'm planning to do more benchmarking, and yeah, we should start thinking about also how to do log-structured metadata, so we can put also metadata on Zone Storage. So there's some exciting work ahead for that. Yep, that was what I had.
First of all, I don't agree that B3 is not good for log-structured file system, because I'm using namely B3 in my file system. It's log-structured, pure log-structured.
Okay, so you figured out a good way to, but okay, yeah.
Yeah, it sounds.
But not in XFS, I think. Yeah, we have to do too much to XFS to,
yes.
Yeah.
And next point that you simply converting XFS in F2FS.
Pardon?
Converting XFS into F2FS, because you have in place area and copy and write. No.
Still 9 years away.
Okay, so and I'm trying to follow about garbage collector problem. So do you reserve some zone for garbage collection?
Yeah.
So why going out of the open zone, available zones?
I mean, you will need to reuse, you have to, yeah, we do have a small area reserved for garbage collection, but those zones are going to fill up too.
Okay, but if you have something like several zones opened already and you can fill data there.
Yeah, but we don't want to mix incoming with outgoing zones. Like, we don't want to mix data coming in from the user with garbage collected data.
Yeah, but we have already open zone for garbage collection.
Yeah, but then eventually we will have a lot of zones with a lot of stale data unless we slow down the user rights.
But metadata lives in conventional zone. You can update metadata at any time.
Yeah, metadata, yes, but you need then a place to put data. And if you can't keep up with the user rights, you have to slow them down. Yeah.
You simply cannot assume that you always will have conventional zones. That's one. And the other one really is that you can only wipe zones in a go. So basically, either you wipe the entire zone or nothing is ever erased. So it is a really bad idea to stuff in new with old data, which you might need to clear up. So you really want to have one zone where you always write new data, which you're guaranteed or have a reasonably good chance that you won't need to clear it up immediately afterwards, and then look for the older zones to clear them up and free up space there. So while you're technically correct, yes, this mechanism would require more open zones to be had, because we always will have an open zone, at least an open zone where we write to, and possibly at least one other open zone for cleaning up. Yes, we will increase the open zones count. That is a drawback, but really otherwise otherwise it's really hard to make a reliable garbage collection, because you will might come into a situation where you need to clean up that very zone where you are writing to, which makes reliable garbage collection nearly impossible.
Let's switch to SSDFS.
Yes. You can contrast your implementation to this.
I'm always comparing XFS and SSDFS.
Yeah, so do you want this? Now it's this one? I change it back. I'll do it full screen and then you can use this.
Ah, okay.
It's okay?
Yeah. It works. Okay. Hello, everyone. My name is Lauda Beika. I'm a Linux kernel developer, and today I will talk about SSDFS. Mostly I would like to discuss my upstreaming plans, but also Javier mentioned today that we cannot wait 10 years. Yeah, it started, for example, 10 years ago, but the problem is that life is not straightforward. You not always can be fully focused on file system and so on. My plan for today's talk, discuss upstreaming efforts, but first of all, I need to refresh what is SSDFS, because not everybody could know about SSDFS. And also, for example, I need to share current status, current issues. And for example, I have for today micro benchmarking results, because I had some questions about what about performance. So this is something like a plan for today. And briefly, I simply refresh what is SSDFS, what's the point of SSDFS. First of all, SSDFS doesn't require classical garbage collection. And for example, it's a really good point, because the main technique of SSDFS is migration scheme, but not garbage collector. Of course, SSDFS has garbage collector, but it's mostly something like hints for main threads from garbage collector subsystem. They simply try to help to main threads to manage the something like workload from application. So the main points, it's something like SSDFS can prolong SSD lifetime. SSDFS can decrease write amplification. Of course, there are many like definition what is write amplification. And of course, SSDFS, because using compression, compaction scheme, it can store something like more data than something like physical space of erase block, for example. So this is the main points of SSDFS. And architecture is pretty straightforward. So it's based on segment concept. Every segment could contain one or several erase blocks. Initially, erase blocks, something like logical one. It's not mapped in any physical space on the volume. And there is special mapping table that provides a way to map logical erase block into physical one. And finally, every erase block contains some sequence of logs. Every log contains header, some metadata, it's something like block bitmap, offset transition table, and payload. And finally, there are several types of segments and several types of erase blocks, because erase blocks are tightly related to segment. And of course, SSDFS has some metadata. First of all, superblock, then mapping tables that map logical erase block into physical one. Then it's segment bitmap that, for example, initially was designated for garbage collector and for location, because segment bitmap provides a way to see what's the state of segment. And the rest, it's B-trees, it's inodes B-tree, dentries B-tree, extends B-tree, extended attributes B-trees. It's possible to add additional metadata in the form of B-tree, and everything is worked on the like erase block concept. And for every type of metadata and for every type of metadata, there is special type of segment. Potentially, it's possible to something like dedicate several types of segment for user data, but currently it's not. It doesn't work because I don't see currently the point for this, but it's possible. So what is the current status in the recently implemented and stabilized features? First of all, I switched the whole code for on folio support because it was a request, and finally it solved problem with supporting 8 kilobytes, 16 kilobytes, 32 kilobytes logical block in SSDFS. Also, I did something like implementation of supporting compression for offset translation table and storing offset translation table in every log, because I try to decrease like amount of read I requests. Something like I implemented erase block inflation model to store more data in erase block, but currently it's not in the repository because it's not stable. Implemented deduplication on the erase block basis, fixed set of superblock segments, recover FS tool, and snapshot rules. I will explain in the next slides what here. So folio support, it's implemented, it's tested, it works pretty in predictable way. 8K, 16K, 32K works. Maybe I have some small worries because, for example, even, for example, you can try to allocate folio. So anyway, it no guarantee that we will always like receive 16K folio or 32K folio in the case of fragmentation, and file system needs to be ready to manage this situation. Also, for example, read-ahead logic doesn't take into account logical block size, and you potentially could something like have allocated folio bigger than logical block. From my point of view, it's pretty big trouble. I found some workaround, but it's some worry for me, for example.
Sorry?
So, okay. Go ahead.
No. If you go back a slide,
okay.
The answer to that question is no. If the block size is a block size, the block size is the block size. And you cannot cope with anything smaller than the block size. That's kind of the idea of block size.
So I received, during my testing, logical folio bigger than my logical block size.
You do have, of course, the problem that you will run into memory fragmentation if you switch to larger block sizes. Yes, that will happen. But this is not something which should be solved on the block layer and thereby, well, whatever, but rather should be solved where it occurs, namely where the memory fragmentation occurs. So the idea here is that if you switch to the large block size, your entire VMA will be running on that large block size, meaning you can only allocate from that VMA with these large blocks. That will reduce the memory pressure there, because there you won't have fragmentation on that VMA because everything is allocated in that block size. And the memory fragmentation on the VMM itself, sure, will occur, but we need to deal with that somehow, but not at the file system level. You really should not be, you should not try to fix it at the level, because really that wasn't the intention of it, and that really won't occur once you switch to larger block sizes.
No, I see my point is simple. So I'm using large folio, for example, and my logical block 16K, and potentially I can receive from read-ahead logic that volume will be 32K.
Yes, of course.
So
But then
I
it will be
would-
split into smaller ones. Yeah, sure. That might happen.
So I would like not to receive 32K, I would like to receive 16K or smaller one. That's all what I would like to have.
Not smaller. 16K, yes. If the block says 16K, you will receive something in increments of 16K. You might always get larger ones, but these trivially can be broken up in smaller bits and pieces on your side. I mean, if you have a large I/O coming in, no one's forcing you to store this large I/O in one go. You can as well break it up on the block layer and just store or on your file system to do something else there. No one's forcing you to store large I/Os, is it?
So here, my point is simple, not bigger than logical block size, that's all. Okay, so let's go ahead. Thank you. So when I try to estimate how many read I/O SSDFS is generated, initially I implemented logic when offset table stored in something like in distributed model. Because, for example, the whole offset table was split on something like in multiple logs. And finally, it was something like if I would like to build offset translation table for some race block, so I needed to read multiple logs. This is something like, this was not good from my point of view. I simply implemented logic when I can store offset table in every log and use compression. And then I try to estimate, is it work or not? So for smaller race blocks, something like 128K, 256K, it's mostly not big deal. It's not provide something interesting, but for bigger race blocks, it makes sense because in this case, it can decrease amount of read requests 3 times, for example. And my conclusion that, for example, if it's something like cold data, potentially it can be used a distributed model, or if it's something like smaller race block, 128, 256K. So finally, distributed model could work too. But if it's something like multiple updates, it's hot data. So in this case, storing offset table in the log makes sense because in this case, read I/O path will be faster. So this is something like conclusion. And finally, after using compression and compaction, I realized that, for example, for the case of cold data, for example, if data is not updated, so finally a race block could be not filled completely because finally when I'm trying to allocate, I tried not to allocate more than physical space. And finally, for example, I'm trying to store 100K file. And finally, I can allocate something like a 4K logical box size. So finally, I can allocate something like 25 logical blocks in this race block of, for example, 128 kilobyte. So and finally, I cannot allocate more. And finally, I store data in compact form, for example, 2AK at whole, but the rest of race blocks cannot be used for storing new data. So, and I implemented inflation model when I can store more data in a race block that something like physical number of logical blocks in this race block, and I estimated something like for different ratio compression in every logical block. It looks good. So race block simulation model can store significant amount of data in physical race block, but currently it's not fully stable. And also it needs to mention that race block doesn't mean that it's not about the whole volume because it's slightly more tricky for SSDFS. Also, deduplication for race block was implemented. Initially, I have intention to implement file-based deduplication. It's not completely finished, but currently, race block-based deduplication, it should work. How it's efficient, it's hard to say because, first of all, if you're talking about ZNS SSD, so usually zone can be huge. So in this case, for example, if a lot of replicated data, so it can work, but I didn't do some estimation of this. And also something like interesting tool, it's RecoverFS tool that's available. or SSDFS. The point here is that in every log, SSDFS keep for every piece of data information about inode ID, about logical offset and state of file, and of course something like size of piece of data. And finally, this tool simply can pass through the whole volume. It can pass through REST blocks and check every log, and finally files can be rebuilt, can be recovered. For example, it's a possible case when FSCK cannot recover the volume. And finally, this tool can, for example, let's imagine that all metadata is gone. For example, mapping table gone, segment bitmap gone, inodes 3, we haven't inodes 3, the entries 3, and so on. So in this case, SSDFS provides opportunity to recover files from the volume, because every log contains inode ID, logical offset, and center files. And this operation looks like a copy operation from corrupted volume in any other volume. And finally, every file will have something like inode ID as name. And if, for example, the entries 3 survive, potentially it's possible to try to recover names of file 2. But from my point of view, it's pretty interesting features that SSDFS provides. And finally, because recoverFS can take timestamp and can recover the state of file for some time point, so finally I added snapshot rules, and with, because, for example, snapshot rules provides a way create snapshots automatically and expire, and snapshots can expire also automatically, because in SSDFS snapshot is simply timestamp, nothing more, because all other data, for example, all other metadata are stored in every log, because headers contains timestamp of creation of the log. And this is something like, I think, interesting feature. This can work, these two features can work together. So
just we probably need to reload with some coffee before the second half. So about 5 more minutes, so you can wrap up with the notes.
5 minutes. Okay, so finally, I did micro benchmarking because I had requests what about performance, and finally used the same device, the same SSD. And I try to estimate something like how SSDFS behaves for create, read, update, and delete operation. It can be SSDFS faster, something like not faster, and so on. And finally, I did these estimations. First of all, I tried to create several size files with different sizes. It was 16K, 100K, 1 megabyte, and I created different number of files. It was 10, 100, 1000, and I tried to estimate, for example, duration, numbers I request, and finally try to estimate performance. And I compared with X4, XFS, BTRFS, BCacheFS, F2FS, and so on. And if file system support compression, I enable compression for BCacheFS, BTRFS, and F2FS. And finally, I can see that, for example, SSDFS looks pretty good for create operation, for read operations. It also looks not bad, and mostly I can something like conclude that, for example, bigger REST block size could be better, but maybe not huge REST block size, because it could be not so good. And for example, I think bigger logical block size could work also better. So, and finally, update operation, in this case, SSDFS looks good. And delete operation. So for delete operation, it also looks good from my point of view. So finally, some conclusion about micro benchmarking, that SSDFS looks good for something like data with a good compression ratio. So I need to estimate if, for example, it's not a good compression ratio, so maybe it will be not so good, but anyway, as minimum for some, for if data can be compressed, finally SSDFS can work better. And I think this is my main point. So SSDFS can prolong SSD lifetime, can decrease rate amplification and performance, not so bad. And finally, it doesn't require classical garbage collection. So, and finally, mostly the most critical features that I need to stabilize, it's erase block inflation model, shared dictionary, because currently if you're trying to create or store file with names that are longer than 13 symbols, so usually it needs to share dictionary, but shared dictionary is not stable, and this could fail. And this is the main worry for me right now. So I would like to stabilize these two features. ZNS support mostly depends on inflation model. So this is something like the main plan, make this stabilization and share patch set. So, and it will be good to have something like help with code review, with maybe testing, bug fix also. So this is something like the main request and the current status. If I will have something like some support, some help from the community, it will be not 10 years, next years. It's the main worry, so it's the main problem, that I need some help. But I believe SSDFS is pretty good. It's my belief. So yeah. I think planned feature is not so important, and I can see how FDP can be used for SSDFS. So this is the main point. May I have some support, some help? So any questions before the break?
Before we take the break, I think we have room for one question. I have lots of questions, but I think I need to discuss some things, and maybe we can look back to it in the BOF session. But I think it's time for some coffee and cake. And we can reconvene here in 20 minutes around 5. If you're 5 minutes late starting that, that's fine, but try to be back in time.
Anyway, I'm here. You can ask questions anytime.
Thanks, Slava.
Finally, we have our 5 minutes left.
Who fixed that? Yes. Yeah. We're on a break. Yeah, you got through the first half. Yeah, I'm not a memory management guy, but finally it's 26 yeah, but why oh, right, you can give it a hint saying that it's probably right.
We're not using the native resolution of this.
Maybe just
our characters.
yeah.
I think this native probably go higher or lower than this.
So you
or some of them use the character as small as this. This works, but it just looks horrible. So if we can make the resolution match the native of things, I don't know.
So you can't. We should not full screen that.
The whole projection, the whole screen here is on a different resolution than the screen. So that's why this is so bad.
Okay, I see what you're saying.
Yeah,
but I don't know who. I can ask one of my tech guys.
Yeah, I think this is maybe 4K or something.
Yeah.
We're deciding something lower resolution. Are we like mirroring or this picture? It's not my home setup.
Yes.
Yeah, you can get get what the
Yes.
problem is. Okay, yeah, I'll be back in a few minutes. I want to check other rooms too. Oh, if they have the same issue, I will go check other rooms.
Yeah.
Yeah.
Okay.
Be back.
Thank you. Ja, hätte gern die Resolution geändert, dass das nicht so pixelig ausschaut und wir versuchen, ob wir irgendwas da dahinter stellen können oder auf der Rollo oder was gibt. Ja, schon, aber man sieht den Sprecher nicht. Ja, sie hat dann anscheinend auch gleich, genau, und am 10. hat sie dann ihre. So maybe we have a screen or something? Yeah. Okay, sorry, ich muss meine Schule aufhören. Okay, cool, ciao. And the other thing that he wants to have resolved is because this is very pixelated, if we're going in with a different resolution or if we can go in with the same resolution. Some more and some less, yes. And I'm looking for, I don't know, switches or anything that actually have something.
We have the remote back here.
Oh, look at that. Okay, are all of them moving?
Only two here.
No, this one is moving too. Is it doing something over there?
Not over here, but in front of the camera, yeah.
In front of the camera?
Yeah.
You think that works?
I mean, it's definitely better. And then they might rotate.
I hope so. Although I only got like it's a touch. Like
Weird situations. Perfect.
yeah.
Look at you. Wow. I'm impressed.
Hey, very impressive.
Translator.
Stell dich mal hin, mach mal Licht dunkel. Yeah, I think it works fine. Lower it a little bit or...
Lower.
Oh, you know what? Yeah. I'll lower it. I'll do... You direct me what you want to see. You go to the screen. Nicholas, stand here.
Should get streamed.
What do you want to do? Besides that.
You can go, yeah,
Tilted anyway?
Nach vorne, ich habe circa einen halben Körper Headroom.
What?
Ich habe einen halben Körper Headroom circa.
Oh, yeah. Yeah, but some of our guys are quite tall.
Yeah, that's not a problem.
Oh yeah, they keep arranging it.
Big there.
Yes. Kind of lucky there.
Leave it there.
The people who stand here. Oh, you can see it. Cool. Go on your tippy toes. Tippy toe warrior.
Oh yeah, we still got plenty of space up above.
Is it good? Yeah, just don't make a mess.
Okay, what's that?
Oh, it says,
I know, translate.
Gosh, come on. Settings, yes. I can speak English. I like the German part very much. Oh, it lags.
No, it lacks the German.
It lags the German.
Because I don't know the German words.
Oh.
I took your list of questions and I have put together the input from other people as well to see what we can cover, and then we have a big holiday time break to sort out all of this. Yeah, you should put your prepare. Yeah, you have this. So you work with a bunch of other people on the. I saw that you had co-authors on this one.
It's appreciation. Do you mean for this one? Yeah, these guys simply raised this problem.
Okay.
For me.
All right.
And I started to think about this problem. I have idea about how this problem can be solved. They simply something like shared with me. Okay, we have some rack that has a bunch of storage devices, and for example, every storage device has some dedicated core.
Yeah.
But how we can manage this for multiple virtual machines?
Yes. Yeah, we haven't sorted that out. So start with that, and then I'll switch to a bunch of generic questions.
Yeah, but I simply decided, okay, we have some vision, let's share it.
Yeah. Well, we've also been thinking of something similar, but also maybe, combining it with, in a very distributed model over network and so on. It's, I don't know how much of that will actually be in the Linux kernel, but we'll see. I mean, it's good problem solving in this area, right?
It's not predictable what will be, what will not be.
Yeah, no, but it's good to try to figure out what the stuff we need to do, because I mean, Ceph is basically providing a bunch of zones on different media, and that's what they do. But I think we could do it in a more lightweight way and actually reuse a lot of the infrastructure in the kernel instead of reinventing it in user space. But we'll see. Yeah, see if we can get everyone in. Right, we're just waiting a couple of more minutes to get everyone back in the room, and then we'll start sort of the second half. It'll be focused on discussions with Slava's proposal on how to virtualize and distribute zones. It's gonna be, the whole second half is gonna be more like throwing this the mic around.
20 minutes yet my domination.
What?
20 minutes yet my domination.
Yeah. Or
This is SSDFS because I try to be fast.
yeah. No, it's hard to. It's hard in this format, right? I had big troubles summarizing what we've been up to in 20 minutes, and I also ran over a bit. So.
When you're preparing for the talk, you're really smart.
Yeah, no, it's a good.
Everything is ruined.
Yeah, it's hard. Storage pool. Yeah, I'll just go and close the door.
button because you.
All right. Yeah. We fixed this.
How you did this?
You just go full screen here, and it will be okay.
Okay.
All right, welcome back. Let's start again and kick off the discussion part. And I'll just hand over to Slava for him to present his ideas around a flexible scheme for space management.
Thank you. Okay, so I think it will be good to have something like. Okay, yes, something changed. Okay, so I hope we will have discussion, and for example, maybe I will echoing some ideas, or maybe it's something like guys knows that something was made before and doesn't work. So if you know something, share something. So the point of these talks, something like share the idea and like have some feedback. And so when I started to think about this idea, so my co-authors simply shared with me this problem. So the problem was, okay, we have something like a rack with a bunch of storage devices. Can we do something for virtual machines? And I simply would like to share what storage pool concept means, what something like my vision, how this problem can be solved, and something like some open questions for this. So first of all, guys shared with me, okay, we have something like multiple storage devices. Maybe it's something like rack with a bunch of storage devices, and for example, it could be ZNS, SSDs, MRGD. Even maybe we could have something like dedicated core for every storage device. And for example, we have a bunch of virtual machines. So for example, how virtual machines can use this storage space in efficient manner. So how can be implemented in some way? Because for example, virtual machines can be on multiple nodes, and storage devices can be located in multiple nodes. So what can we do here? And for example, it will be good to have something like aggregated LBA space, when, for example, we can imagine or represent the all storage devices like one big aggregated space, and this space can be distributed in some way between virtual machines. And even if you consider something like one virtual machine, so it's something like, anyway, slightly not easy problem, because if you are talking about ZNS SSDs, MRGD, we need to take into account that, for example, we need to write an append-only mode, and finally it means that the whole problems of this will be on something like file system, on rootfs file system, or virtual machine, or something else, but virtual machines needs to be aware about that, something like ZNS SSD. Also, for example, how to distribute this space of different storage devices. Again, if we don't provide some smart technique for this, it means that it's up to virtual machine or up to application how to do this. But it will be good to have some really good smart technique when, for example, virtual machine will be not aware about something is happening under hood. And for example, virtual machine doesn't need to be to manage this in somehow, and because it will be no change on virtual machine side, no change in file systems that virtual machine can use, and it looks like that, it sounds like virtual machines needs not to be aware about each other, but finally use the aggregated space in some way. And finally, I simply when I started to think about something like virtual machines needs not to be aware about another virtual machines, one idea crossed my mind, something like similarity between virtual memory. So we would like to ask question.
Well, I would like more details on what you mean by a virtual machine being aware of another virtual machine. In these days of confidential compute, how can that even be possible?
No, I mean, for example, you can create one virtual machine, and for example, you need some something like some space for rootfs. And I mean that, for example, from the something like partition point of view. That, for example, you place or you allocate some space for this partition, for this virtual machine, and for another virtual machine, you need something like to distribute a space of device.
That's not a problem for the virtual machine. That's the hypervisor and the system administrator problem. It's not the virtual machine problem.
No, I don't think about something like some from high level. That virtual machine doesn't need to know about each other. I mean, for example, that we need to distribute the space of storage devices between multiple virtual machines.
I get it.
Okay.
My point is you keep talking about the virtual machine being aware of other virtual machine. That's not a problem for the virtual machine level. That's below that hypervisor level.
No, again, I'm not talking about distribution time slices or something. So I simply...
I'm not either,
Okay,
but the hypervisor is going to provide the storage to virtual machine, and how that's set up, it's up to the hypervisor and the system administrator. It's not a VM thing. The VM just use what you give them. They don't know how that's set up. They can't. So it's just the way you describe the problem is confusing, because that's something that is lower, it's not a VM level problem. It's below that. That's the only point I wanted to make.
My point is also pretty simple. So, for example, if you are talking about storage device, for example, we can split storage device from multiple partitions. So, and finally, we can use these partitions or something like this. So it means that we can assign this partition for rootfs of one virtual machine or something. And okay, maybe I'm missing something, or maybe I'm not explaining in a clear way. But my point here is that, for example, we could have aggregated space of this storage pool, for example, and when finally we would like to assign some LBA to some particular partition or what virtual machine can see, we can something like suggest some mechanism of smart distribution of this aggregated space between these like partitions or something. It doesn't matter who managing these partitions, but finally, anyway, we need to allocate some real physical space in some way for some partitions or something. So this is my point. So, for example, it could be hypervisor or something else. The point here is that, for example, how to implement this distribution. And also, for example, one of another point of view is that how to easily change or resize this partition, for example, or for example, do maybe some on-demand allocation, or maybe, for example, to provide some different erasure coding scheme for different partitions or for different virtual machines, or maybe some replication scheme or something. This is the point, how to do this in flexible way. So this is the point. And finally, I simply started to think about, let's virtual machine sits on some block device, maybe it's user space block device, for example, and every user space block device manages something like block table, looks likewise to page table, and finally, block table simply provides for user space block device or some subsystems that, for example, we can see some number of something like logical block addresses, but finally it could be located, maybe not. And finally it looks like page table, but it could be something like block table. So, question?
Yeah, how do you envision this to look like to the VM itself? Because while you could do all sorts of mapping in the hypervisor, and we do all sorts of mapping in the hypervisor, at the end of the day, all of these things will be presented to the VM as a block device. Correct? Question one, a single or several?
So if it's something like one block device, so it's one block device from one
okay.
machine.
So but then the problem is if you have one block device, the block devices, or rather the things on the block device, tend to react very peculiar if you start resizing that thing. Or if you start unmapping chunks from within that block device. In fact, they react very aggressively negatively on that. Try to do that with a file system on it, and you're screwed. So while technically we could do all sorts of remapping, de facto, once it is a block device which is exposed to the VM, it's pretty much static. All the file systems assume they will be static. Some allow you to increase the size, but shrinking the size is horrible, horrible, horrible. And so, yes, we could do a mapping, but I can't really see how we could make this dynamic, nor why we should make this dynamic.
So I'm not, I think not for why we can do this not in dynamic way. So, okay, go ahead. He's first.
Okay, so this is not a response to what Hannes said, but when I look at the diagram, it reminds me of Ceph RBD. So I'm curious to see if is this at a different level, or would it be comparable to something like what Ceph can do, a distributed storage system?
So,
or LVM or any other solution out there that does device pool management. There are a lot of stuff out there already that allows you to get a bunch of storage devices and virtualize them into some logical block devices, and the mapping is handled automatically by whatever layer, LVM or Rados. There are other things out there as well. So it kind of looks like this.
Yeah,
so
maybe,
how is that, what you're talking about, how is that different from the solution that are already existing out there?
So my point, my vision is that what is the difference? Because in this scheme, for example, you can assign different, for example, erasure coding scheme for different block devices. Can we do this for C, for example? Or it will be for global vision? Can we do or not?
I don't know, but you can definitely set replication factors. It does have a configurable algorithm for how the data is distributed. Yeah. So I'm not sure what the specific details are with Ceph, but I do know it has a configurable algorithm. You can set the replication factor. So if you want to replicate 3 times to your storage pool or things like that, it is configurable. Yeah.
But it will be for the whole bunch of storage devices, I assume, not for example, not for particular virtual machine.
So the Ceph model is that you have a cluster of storage nodes, and all those storage nodes can play together in Ceph. Then you can create volumes. They're virtual, and they will be mapped to these storage nodes.
It's an object store, distributed object store. On top of the object store, you can create different interfaces, one of which is block devices, and how the block device that you expose to whoever uses that block device, which can be a VM, you'll get the mapping for the storage space of that block device through the object store. There is file interface, there are other, or direct also use of the object store itself. So again, there are solutions out there that does this.
I cannot say, I will try to say that there is no solution.
But the point would be, so what is it exactly you're trying to solve? Because if, compared to the solution out there, what's the problem you're trying to address here? That's kind of what is not clear here.
I'm trying to address something like flexible resize scheme, for example. I'm trying to address on-demand allocation scheme. And for example, easy migration scheme, because from my point of view, if we have something like block table, we can easily change the mapping scheme. For example, what particular, something like what virtual machine C, something like virtual LBA. So finally, where is mapped? And for example, if you have block mapping, we can easily change this mapping because it can be done under hood, and something like what virtual machine C, it will see the same virtual LBAs. And it's something like basis for copy and write policies and SSD, garbage collector, if you like to use this. So this is a point. So what I'm trying to solve, I'm trying to provide some way where, for example, virtual machine will see the same set of virtual LBAs. But on the block level, for example, if we would like to move some data from one real physical LBA to another one, so finally block table height width from virtual machine.
I mean, that is what LBM does, right? I mean, you give him arbitrary tables, remapping incoming LBAs to something other outgoing LBAs. That's what LBM does. And you can even reconfigure it on the fly. So, difference being?
I need to check.
So, aren't different hyperscalers solving this problem in their own way already? I mean, you talk about migration, and that's kind of the latest thing that is coming, like things like NVMe, and everybody has an opinion on how to do that. So I think that trying to find a general solution in Linux is going to be very painful for you if you don't have like somebody with a real use case on how, because they have complete different requirements. And you're mixing a lot of things. I mean, it's talking migration, and then before it's about block management, and then you slightly mentioned stream provisioning. So it's a lot of things at once, I believe.
Okay, I see.
Yeah, it's also hard to provide a lot of flexibility and a lot of possibilities without having like some specific use cases or some specific performance metric comparing to existing solutions to show that this is value and other people should invest in this as well. Yeah. I mean, we've been thinking on and off as like a research idea how to do the distributed zone storage in an easy way, because you have large chunks, you don't have a lot of overhead for mapping tables and so on. If not mapping by LBA, but mapping by a whole zone that could be a gigabyte or something. And then we could do something like a simpler Ceph, but that's still a very large project. That could be a cool research idea, but it would have to take a lot of like defining to make sure that we're not reinventing the wheel again.
But sometimes...
Yeah, I mean, this is the forum to pitch new ideas, right? It's just that when you do research, most of the things just stay in the idea stage, right?
I think every time when trying to invent some bike, you can find some interesting ideas.
Yep. Cool. But thanks.
Yeah.
And yeah, I'll do leave that there. Huh? Yes, next is BOFs. We have. I've listed just a bunch of topics. We gathered a new one after listening to Javier's talk on FTP, and have some from Slava and some from the rest of the community. So we can just try to work through those. But if you guys spontaneously think we should discuss something, we can bring that up as well. So yeah, we got a bunch of stuff, and we can maybe start with something that has been sort of an unresolved thing. Yes, we just need to touch upon this.
We managed to ignore that.
No, but yeah. Yeah, maybe you can, because this is a problem you raised, right?
No. My question is simple.
Yeah.
Should I do testing for SSDFS or not? Because finally, what we have, no?
The answer is pretty simple. Nobody is building CNS devices that are not a power of 2.
Yeah, but you have also Zone UFS now, so there are some patches in the Android kernel, right?
SSDFS is not targeted for UFS, as far as I know. I mean, you're not going to put this on an mbed device or on a mobile device. And F2FS already has support for non-power of 2 for Zone UFS. That's what they wanted. They tried to put it upstream in Linux based on the patches that we tried to push for several. Yeah,
UFS is a weak case.
Is the way? No, I agree. I'm not trying to open a door. I'm just saying it's already in the Android kernel. There is not going to be in Linux, at least that I'm aware of. So just drop it. I think it's a door that bleeds very much when you open it.
So what we're saying, unless you're doing stuff for Android devices, you should not care about non-power 2 zones.
Yeah.
I'd say let's revisit this once we get an actual production use case that needs it.
Yeah, I agree.
Yeah.
And I'm speaking because we were the ones that pushed for this very, very hard in the past. We backed off. We're not building these devices anymore. So unless somebody else is building them and want to speak up, I don't think there's a use case for it.
Yeah, good. That was quick and reasonably unpainful.
What is it for Zone, like, with Zone, like Zone UFS? Are we going to have anything there we might want to?
So for Zone UFS, it being SCSI, we actually changed the ZBC standard to cater to that case where your media is not rotating Rust, and you may not easily get a power of 2 alignment. So we introduced the gap zones and the jump between zones, so that we essentially created the zone capacity, zone size and zone capacity for ZBC as well, to help UFS flash media zone devices. So that's all in the standards that gave a way forward to keep the zone size being power of 2 while catering to the media and alignment to non-power of 2 erase blocks. However, it turns out that after all that work, Bart came back telling us that Zone UFS device vendors, they don't like that approach because blah, their firmware, their device, their SoC or whatnot, it's too hard to change and do that. So they wanted a non-power of 2 zone size, which ZBC allows, but Linux doesn't. And apparently from higher information, that's all supported out of 3, so we don't really care. Yeah.
This is one of the discussions it's pointless to go into. Some maintainers have made it clear that they're vehemently against. Some maintainers made it clear that they see a use case, and as long as you don't have any reliable mechanism of reconcile these 2 stances by maintainers, we are stuck. So there's literally no point in us trying to persuade. We know exactly it will be vetoed, whatever we come up with.
But that, at least we conclude that that's where we're stuck. And the users actually have a solution to put the patches in the Android kernel. And
if you ask me, it is a daft situation because that's precisely what we try to avoid when building the Linux kernel, that somewhere it goes along and does its own stuff. That's why we invented this bloody thing. And now we go along and say, oh no, we're perfectly fine with you doing your own stuff.
Yep. Oh, yeah. That's how it goes sometimes, right? All right. I think we can move on, right? Please. Okay. So, all right. We can look into something completely different, and that's testing. And we can look at benchmarking afterwards. We do quite a lot of zone storage specific testing around the kernel, right? We have tests in libcbd and libcbc.
Pass through. It's not
kernel. Okay, but yeah, okay, it's not kernel, okay, but it's okay, Linux. How do you have like a state of that? Is that fairly complete? Are things missing now, or?
So for libcbc, that's now with the new version 6 that has been released recently. It's a purely path-through library. So think of it it comes with a test suite, and that's more for device and HBA testing than the kernel test.
Yes.
It's
okay.
Just path through all the way, so it bypasses the kernel.
is there value in modifying block tests to not requiring to run on real hardware, but enabling libcbc to emulate hardware?
No, please no.
That was the question. If you say no, screw it. Okay, right, screw it.
Can run QEMU,
whatsoever.
Okay,
No,
okay,
it's a
okay,
pass-through thing.
okay, right, good, okay, fine, good, won't, then, good.
Yeah. And for ZoneFS, you also have testing, right?
Yes.
So is that well covered now? Yeah.
Yes. So yeah, every time I get a regression, I try to even cover that with new test cases. There's a fairly complete set of I/O patterns being exercised. So it's not FS test because nothing works POSIX way with ZoneFS. But I think it's fairly complete now. There's extensive testing around the error path. So we in-purpose generate errors and bad state of the drive to test the error path. It's very complete. Block tests, we've been working with Shinshiro to see how we can improve the zoned group. So I think recently the patches that went in, we had one test case that has like 20-something test cases for actually testing zone block plugging, zone right plugging, sorry, together with a combination of DM linear and DM crypt devices to test all that plugging and zone append emulation done there. I think there's a lot more we could do. Like we do have off-tree some test cases to test the entire zone state machine, for example, that we could easily add to block test as well. In the end, it's kind of tricky because it's the boundary between kernel test and device test is very blurry. Which one are you really testing? Because in the end, if you look at what the kernel does for zone block devices, it's not that much. It doesn't really care about, it doesn't track states, zone state, etc. in many cases. So,
I mean, both devices and the stack needs to work, right, in the end. So it's
but
it's good that
block test goal is not testing the device.
No,
so
it's a nice side effect, right?
So yeah, it's we can talk about it, but I'm not sure where a nice boundary is. So
yeah.
So after adding zone right plugging, for example, we did add the test cases for exercising it to try to catch regressions. There is a few tests already that exercise like report zone, done some IOs, etc. We could extend that a bit. We definitely can think about it in the context of the refactoring that is going on with block tests. Around the I/O pattern that exercise devices in different test groups that can actually and should be common between different device types and groups. So I think Daniel has been working with Shinichiro on that. So in that context, yeah, probably we can extend that as well to zone block devices. And for XFS tests, yeah, it's per file system, so that's a different story.
But now we have, or we have soon 3 file systems that support zone block devices. So what I'm thinking is maybe we can make more generic tests that specific, like, are especially hard on this type of file systems, like the one that I added, the 747, that really tortures the garbage collection path. And I made it works on F2FS and it works on the experimental XFS, but it turns out it was not fitting ButterFS properly because it had different requirements on how many zones needed to be open and like minimum size limits. So there's some work left there to make it generic enough for ButterFS as well. And it would be nice to add more of those things because zone storage file system have to do a lot more than a normal file system when it comes to space management and so on.
The big question is, what is like the generic test suite for file systems. It's garbage collection is like one point. Like we have the generic test from you. There's 2 Btrfs specific tests for garbage collection. One, but what else is there? So would it make sense to have more than that in the zoned group?
Yeah, what we're thinking of adding to, for the XFS testing is like making sure that garbage collection is not run if you have mounted read-only, for example.
But then we should be careful here, because each file system will have its own thoughts on how zones are managed, especially how many zones should be kept open, need to be kept open, blah, 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 that's whole gear.
Yes.
That's essentially up to the file system what it does with that. So we really should not impose any boundaries, any tests. Oh, you should not keep that.
Oh, no, nothing. No, low-level management. Just making sure like logical operations work, but like just adding tests that are specifically hard. And we know that would stress that sort of implementation when you have to do reclaim and tricky corner cases for space management when you punch holes and pre-allocation and things like that. So probably, and we will continue to explore that with XFS, and I hope, just to engage Btrfs and FTFS guys more in seeing if this is like applicable for those, and we make it generic then, and then share the burden of
the big question is where to draw the line between generic and XFS or Btrfs specific tests. So
yeah, but it's just a discussion we can start having, right? So
exactly. So for me, I'm not sure if it's just me, but the generic category is more like the correctness, the POSIX correctness test category. And the file system specific is like the regression testing, whatnot.
Mm-hmm. We can add new categories, right, for garbage collection, or I don't know.
But then.
Okay.
So no, but this is. I tend to agree with Johannes here. The thing is that while most tests for the file systems are actually generic because you're using generic POSIX interface to trigger it. Mm-hmm. The results of which are pretty much file system specific. So some test kits which is particularly hard on a particular file system might be a completely no-brainer for the other file system.
Yes.
So having this in a generic section is questionable, because if it's no big deal for that particular file system, why is it even there?
Mm-hmm. But I think there's more than just the garbage collection thing that is.
But you don't know. If you have a file system which, for whatever reason, doesn't even do garbage collection, it's completely...
No, then for that, no. But I'm just saying that if we have 3 file systems that needs to do these common things, right, we probably find common problem areas. And, zone group, yeah.
Or just per file system test case, but based off some generic code in like library, like code.
We shouldn't burden the rest of the file system. The new tests take time to run. Just
not a big deal as long as the test coverage improves. Whatever.
Yeah.
Yes. Exactly.
Okay. That's something I wanted to feedback on. And another thing that I think we can cover, like share the burden enough, is, let's see, I'll come to that. Data placement benchmarking. So testing is hard, but benchmarking is even harder, because you never know if you got the right number, right? And I think I spent more time benchmarking stuff than actually developing stuff over the last few years. And I mean,
do we have support for data placement in the target, in the Linux target driver?
The target? What?
NVMe target. If he doesn't do Rust stuff.
FTP batches, what's the state?
Yeah.
I mean, they are pretty close to getting in, right?
Let's say, I believe so. I don't think there's any blocker. It's very close
to getting in, right?
It's very close to, I don't know, the request would be, Christoph has been commenting today. I think the patches are, being deployed at several places. So please review them. And then, I believe it would be okay for everybody, and then you can reuse to do the. I was going to ask you here, what do you mean by data placement benchmarking? Is it write amplification? Is it performance?
All right, we can take a step back. Like we do FTP, we do zone storage for a purpose, right? We want to expose more capacity, but we also put, like the things you brought up in your presentation, less write amplification, right? But how do we assess that? And it's very workload specific, and to be able to do that, we have to run some workloads. And configuring those workloads and interpreting the results is like something that will take months to like really understand, right? Yeah. And I'm thinking if we can automate those things and people could just push a button, run a script and get a number saying that this is good or this is bad, and we can compare different solutions. Instead of having to set up all the testing yourself and like parsing the results. Because we always compare different things, right?
Yeah. So I think there are different things. So we ended up using write amplification as the metric we're after for what I explained in the morning, because it's been used as a proxy metric for latency and for the amount of garbage collection you do and bandwidth and all those things. Now, the issue with that is that you, in NVMe at least, do not have a standard way of looking at your write amplification, but you do have that on OCP.
Yes.
So OCP drives, you can measure before, do your test, measure after, and do that.
For FTP, you have that standardized.
For FTP, that's standardized. So, but if you look at OCP, then you could do the same. At the end of the day, every SSD has this. Is whether you want to make the register or the log page or whatever you're doing available is device specific, and that's typically problematic. But OCP gives you a way. So if you decide to use the same mechanism for other drives, you have a way to do that. In the context, I'm switching gears, but just bear with me. In the context of the LBS work, which has been a lot of measuring and testing, and Luis is very thorough using KDevOps. We ended up using a lot of a tooling that Danny, that I think is on the call now, has been doing for measuring, using VPF to measure a lot of the alignment and the IOs and all those things. And we thought, can we do something similar for write amplification? So Joel has a tool out there that is open sourced. And we were thinking of maybe putting it into, I don't remember the framework, but making it available so that we can automate this through KDevOps.
Right.
So that would be a possibility, because you have like the baselines, and then you can do like thousands of runs and then collect the data. And that's a possibility if you think that would help you in the right direction. Yeah, I think
all the steps in like being able to have some common ground when it comes to testing and evaluation of different algorithms would be good. I've added some simple write amplification metrics to FSPerf, which is a framework that Meta uses to evaluate. So you can, for zone file systems, it's pretty easy. You can just measure how many blocks were written by the host. Because you know that no extra blocks are going to be written by the device, right? For FTP and for conventional devices, you have to pull out that data. But we could also make that plugin into FSPerf and get that metric. So we could have something there, and so then you can measure it, and then you have to define some workloads that we care about, right? So we've been, CacheLib is one, RocksDB is one, but those are just, it would be good to evaluate more than just one or two workloads. And also being able to automate them and make it easy for more people to run them without having domain-specific knowledge about these workloads. So if it's something that we can, that's something we can work on in the future, right?
So, two things to that one. I mean, if RocksDB is such a great tool for testing, it should be possible to extract the I/O pattern from that and put it into FIO.
Yes.
Wouldn't that be a good idea? Like have an FIO profile?
I have that on my to-do list to add that FIO.
Right.
I have something simple. I just have to. It's not super simple to mimic that write pattern, because
if we have a script, that's fine.
Yes. You could make a small Python script. I think that's easier than FIO.
Yeah.
So like a SST table key value database emulator.
Something, whatever.
Yeah. Just boil RocksDB down to something that has a similar write pattern. Yeah.
And the other thing is that is the write amplification just the amplification we see on the host side, Or should we also take into account whatever the drive does internally, as we're not taking, properly looking at the erasure block size?
I think we have to measure both, right?
So how would you measure the drive internally?
OCP. So in OCP, you have something similar to SMART, where you can look at the number of bytes written to the interface and number of bytes written to the media. And then you divide those. So.
How do you know you're talking to an OCP drive?
And I agree, but what at least what we are discussing is, because I'm pretty sure that in every vendor has a way of doing this. What we're discussing is we might as well use the same mechanism as OCP for all our drives, because it makes things just like easier.
Care to bring it up to the...
Disable them.
Well, let's standardize it.
Exactly. Care to bring it up to the NVM Express committee, that we will have some sort of whatever smart value, whatever from the NVM Express that we can read from there.
I agree with you, but think of one thing. There is one reason why it is in OCP and not in NVMe. And typically, you bring to OCP the things that get pushed back on NVMe. So we can try to bring it again, but... Yeah, no, it's true. It's true. I mean, I think it's fair.
Historically, the reason it's not in NVMe is because NVMe is supposed to be media agnostic. So, I mean, when the discussions were in NVMe around this, it wasn't included because it's supposed to be media agnostic. Use persistent memory SSDs, whatever, hard drives, SSDs, whatever it is. So, I mean, while it would have been nice, it's just not there for that reason.
Had not been there. Then someone came along and invented domains and endurance, and so suddenly we finally have something where we actually could put it in legally.
In HDD LAN, you have the device statistics stuff, and it's a log page you can go and read, and then you get the information. So if we can do it on HDD, you can do it on SSDs as well.
We're kind of stuck in that we can't easily make it mandatory. We can't do in NVMe 3.0 and say, yeah, but when it's optional, no one implements it unless someone asks for it. And customers, typically, if you're selling like off the street, I mean, you're getting the bare minimum. You're not getting all the bells and whistles. You're not getting an OCP drive, for that matter. That doesn't go into the street. But a normal bare bone SSD does.
You're perfectly right, but would you do benchmarking on the street board SSD? You'll burn out in no time. No.
Not the WD drive.
No, yeah, you won't buy them off the street. So now, point is, it doesn't need to be everywhere. It just needs to be on those things we're testing with. And remember, this is testing. And this is primarily functional testing that we did not mess up. So really, it needs to be everywhere. It just needs to be there where we test upon. That's perfectly sufficient. Exactly.
At least, from the way we see that is, you care about these things, as you say, on very particular drives. And you care about these things when you need to provide this end-to-end kind of, I don't want to call it guarantee, but end-to-end contract that you do. So at least for us, when we test these things thoroughly, we go to very specific devices and they say, this device behaves this way because, as Matthias says, it is made for this customer, that is asking for these particular things, and we all do the same thing in SKUs. So can we put this out there and let people play with it? 100%, we're doing that. And then do you want to go and change the log page or whatever you're using to test on your device? Then do it if you want. So, but for OCP, I am aware that there are, there's this testing and validation framework that Meta has put out and Google has contributed to, that is about the whole left shift on testing on OCP, and it's very probable that some of these tests end up being available for OCP drives, and they can be reusable by the rest of the community.
Yeah, and weren't there some efforts in SNEA to define how to do data placement and compare different implementations?
I'm not attending.
Okay. Matthias, do you know? I heard about some work in that direction. to sort of try to define which tests we should be running, comparing.
There's NIA data placement group.
Data placement. Did that then like go for? Not currently. Okay. So I mean, we can go ahead and define our own tests in our community, right? And we can pull out the amplification out of the drives, just either using standards or specific hacks for drives, right? If you want to run it on your own drive, there's always a way to get that data out. It's just maybe not always available to everyone, right? Yeah. You could just get it out, open source, and people can start using it.
Right, Matthias.
But is write amplification the only metric that we want to keep track of? Because,
well, that was an important, like an interesting thing from your talk, Javier, and that like write amplification is one thing, but like latency or like maybe tail latencies, right? That would be interesting to measure under the different, because people really care about that as well. It's not only.
But that's easy to do.
Yeah, but it would be good to have common methodology for it.
I'm saying there's no real problem.
No, but it's. I think. I mean, maybe we agree on like it would be nice to have a set of common tests, so we not all have to reinvent this. So we could actually peer review tests and test it in different conditions, right? Because we get this wrong all the time, right? And you have to.
Definite conditions on SSDs.
Pardon?
How exactly are you going to introduce defined conditions on
Oh, you don't have to define it. You just have to measure it.
Just buy a new one every time, indeed.
Okay. Well, yeah. I mean, you can...
Yeah.
Things change over the time, right? But at least you can see it's slowly decreasing, and then you change your software, and then you have a... I mean, you can... It's useful just to see what happens, right? See if you're starting to mess things up. Or the drive is doing that. Okay. We have a bit of time left. See if we... I think I had one more topic. Yes, FTP and Zone Storage. Something we started discussing in...
So I think the general comment is, I believe we're in pretty good shape, and I think that everybody in this room, at least, it should be interested in that. So, please review the patches, see if something is missing. If we can merge something relatively soon, we can remove a lot of OF3 stuff, and then we can work on the abstraction. I think that, a lot of the discussion right now, it is, so the SCSI stuff is there. And then you have the temperatures, and then we try to reuse that. And there was some pushback because it is true that FTP does not define the semantics, and I completely get that. But we're not going back to NVMe to standardize that now. That I can assure you. So either we overload the temperatures, which is very simple because it gets contained into the NVMe layer, and then we can live with that. Or we try to move it up the stack. That's the latest patches for Kanchen, what they're doing. But then we start touching file, not only NVMe. And then in the moment we start touching file, then you start having all these questions like, what happens if I mount my file system on half of the block device, or if I use, or end-to-end, right? And then you need to start maintaining bitmaps and all these things. I think that's overly complicated. Nobody's asking for that. Most people are going to use a block device, and as I said, in the talk, we have patches to connect the IOU ring command to just go to the per IO hint, and that's probably what most people is going to use. So having some consensus, not here because here is useless. So having some consensus in the mailing list, right in the mailing list, review the patches, and then we get it merged, and then we can all move on. So,
yeah, just what I'm raising here is that it would be really good to have a common, well-defined semantics for databases, applications to rely on to try to get better performance out of their storage systems. Right?
But back to Javier's point, it's really going to depend on how we can standardize with quote marks, because it's not a standard, or at least agree on a definition for data lifetime hints or temperature or whatever the name you want to call them.
Yeah.
If there is a set of these hints, well-defined with a well-defined semantic for each of them, then sure, we can go and map that to FTP or to some zone allocator using them to choose zones.
Yeah, exactly. So we need to know what the
and that's
what
up to the file
means,
system.
Right? Yeah. No.
We are talking about a problem at the API
Yes.
API level, system call level
Yeah.
definition.
But that's for the future. I think that's my point. We cannot make those decisions now.
I think if you're adding an interface, we should think hard about the semantics, right?
Be very, very careful here. So it is not the first time we did that, right? That's now the third attempt, fourth attempt, something along these areas. And we always have used the very same way. First, defining what will be done in the spec, and then trying to figure out how on earth are you going to use this in the upper layers. And seeing that it's now the fourth attempt, which implies that the three attempts previous didn't really work out. Did it? Otherwise, we would be there now. And now we are going down the very same road in the hope that it works now. Why?
That's a very good question. The only thing that I see different, I'm going to shoot myself in the foot here, is a lot of the previous approaches were vendor-based approaches where we tried to come with ideas to make the device better in several ways, and it didn't work out. This approach is hyperscale-based. So they're coming with drives they're buying, and with use cases they are mapping, so it's top-down. And we might not agree on how FTP turned out to be standardized, but that's how these hyperscalers wanted it, and that's how they're buying the devices. And I think the argument we're putting here is the use case they define, that's what we're trying to cover now. The rest of the semantics of temperature and all that, for other use cases might be there, but why don't we cover what we can sell today and put in the street today? And on top of that, I want to add, these patches are already deployed at 3 enterprise people, so we really want to remove them off 3.
So I'm not doubt that it's implemented and in use or something. Yeah, sure. Obviously they are, and yeah, sure, fine. Again, I guess we are slightly the wrong audience here because we are not actually generating the data, we are just dealing with that. And it's those who generate the data who need to set the appropriate hints such that the device can make do with
this is classic chicken and egg. If you don't have it available, you're not going to get adoption,
exactly. So
right?
essentially, we should ask, say, a file system people to ask them, right, can you deal with it? Can you do something sensible with it?
Maybe.
But this is not, if you go to the use case these people are looking at, so one main use case, and Meta has been very open about this, is cache sleep. The code is upstream, so you can use it. It goes through.
Yeah, but that's all pass through, right? By passing, they don't need VFS interface
exactly.
for that.
So that was passed through because that's what we had at the moment, and these guys wanted to deploy it very quickly. But I believe that more things will happen in the future because there are other use cases. Most of what I know is user space file systems. That's what I mentioned before, that the block layer is the ones that are going to get used. So at this moment in time, all this discussion we have in the kernel around file system being the owner, I think it's madness. Yeah, it would be very nice, but that's just spinning the wheels on a use case that is non-existent.
So essentially what we rather should be looking at is to map the FTP semantics over into IOU ring, that you can feed it from there, and also map it into Fuse, that Fuse has an interface to allow it to set these values.
Right.
And that would be actually more useful because then we write, okay, so this is the interface to use it from your test environment, whatever, experimental file system, whatever you have, use it. Have fun.
But we still have to define.
We really don't care. And then we would have a sensible interface for them. And then we can talk with the next LSF to the file system folks saying, right, okay, this is the interface, see what you can do with that.
But we need to put before, we have the patches for that. That's what I commented before. But we see that as a second set of patches because the first thing is to connect the block layer. The only thing we care is the block layer. That's why the first set of patches that were based on the temperatures reuse the whole infrastructure. Just to cover this. But now that we're getting into the weeds of, hey, now I'll create a new FNCTL and then creating a new way of doing things, then all these questions comes. Hey, if the file system owns it, then the file system needs to do like a lot of stuff, and then you need to think about device mappers and blah, blah. That's like completely spinning the wheels. We only care about, at the moment, the use case is block devices for people either building a specific application, in this case, Castle, or a user space file system.
Well, you do.
The ones that I know of.
Yes. So, but we really, I mean, we as the community really should look at, okay, how we make this work throughout the entire stack. There might be bits and pieces which are rather complicated, not really easy to deal with, so we can leave it out. But we should definitely avoid getting to the situation where we had been with the whole integrity stuff, where it took us decades to come up with a user space interface, which is really, really sad. So that's really not we should be going at, but rather should think of, right, a simple way, right, okay, say, like the fuse interface or IOU ring, right, okay, here IOU ring, that's the bits you need to set there, and then you have it.
I think, I think everybody here is willing to put the work, and then, we can do that. But I think you mentioned, why are we in the third attempt? And then we touch slightly on the power of two stuff. And, there is a very polite way to tell you to F off by coming and saying, hey, can you do all this work? And then, continue doing that and continue, and then the next thing, and it never gets merged. And then your customer gets pissed off and the technology gets dropped. And we've all seen the painful part of that here. So what I'm trying to say is, now we have an opportunity to align on something that is actually being bought by people. Why don't we get this thing in, get that use case, and then we can continue doing the work. We all see once something is in, is much easier to build on top, and then we can actually, I have no idea about file systems, and I came to that conclusion. So why don't we put it in so that file system experts actually try to do the work? When we were at LSF and talked to Shinner, he was like, just separate the metadata. It's not that easy, because you can end up doing more damage than you're trying to help with. So, please review the patches. And
yeah. But what I'm not quite sure of, do they even map to zone devices? Can you, or rather, does it make sense to have? So
the right hint, I agree with Javier. You need for the right hint, you need the block layer wired. If you even want to consider file systems, because file system will call into that. For zones, it would be everything is there already. It's just an LBA-based hinting, because you choose a zone and then you just write or read that LBA. So it's a file system problem already. We are past the stage that FTP is now trying to get to. So, and if we get the data temperature, lifetime, whatever it's called, well defined, then the file system can either, if it's a zone file system, use zones to implement that hint, or FDP, or whatever other underlying device feature
and we should really get in the next round of discussions. We should really get the SSDFS guys in the room, because they've been working on this on and off for a long time, right? They have experience in this. So just see what because they have been going back and forth between different models of lifetime hinting and data placement. So yeah, I probably need to bring them in.
I like to understand why streams didn't take off, because I know a lot of drives had that support for many years in the kernel, and the support and the way I see it with FTP, the way it's been implemented in the kernel isn't that it'll provide the same benefits as.
It's very simple.
Yes, but then why are we discussing FTP?
I can answer that. I'll tell you why streams.
Okay.
But then why does this not apply to FTP then?
So streams. Semantic of streams was EL defined, and there was too much variability between devices, between vendors. The API, was defined, but the result of using it on the device was just.
What makes FTP different?
I think it's better defined. I'm not entirely sure. I mean, the expert is there. Don't ask me. But I know streams failed because of that.
There are two reasons. First, streams came at a time where we were building the whole open channel stuff, and it collided very much head to head with it. That the politics side of streams was way, not the streams, so many vendors ignored that. Then second, on streams, people struggle a lot in getting alignment on the sizes of what today we call reclaim unit. And that was also very painful for people deploying that. And we tried to learn from those mistakes, and believe me, we still do streams. So we try to learn from those mistakes, and now having the sizes help, having the feedback loop helps. So it's an extension to, you can see it as an extension to streams, yeah. But I think it addresses the concerns of the people that were actually deploying streams at scale.
But adding these placement IDs or hints is basically streams, right? In interface, user
it's the same.
It's the same, but they're also like more lower level control, right? You can have more control of the reclaim units and so on.
Yeah.
Is that something that you consider adding infrastructure into the kernel for?
What do you mean by that?
Like knowing more about the sizes of the reclaim units and see where they are. And,
it is. Know where you are, because in FTP it's not about, you don't have like a right pointer where you are. You have the log page. It's a different mechanism.
But is that something you're considering making available to like file systems, or is that just passed through?
So from my perspective, you have the log page, so you can query the log page and then you can look into that. Typically, that's made more as a control plane kind of thing. So when we talk to customers and then they say, why don't we make this like an IO command and look at it? And the people said, we cannot use real-time statistics on what you're doing because it's way too complex. So, so the way people are looking at it is, we're going to deploy this, run it in the workload for several months, and then we're going to look on the side and say, hey, how good are we aligning?
So it's just for analytics. It's nothing that you will use real-time feedback?
No, because the real-time is very difficult to measure. Like, how well aligned are you in real-time?
So we will like stop at just providing hints from file systems.
You have hints, and then you have the contractual guarantee that the allocation, the DSM command, is going to be served, which in normally, I know in an enterprise drive, you typically guarantee that, but in NVMe is advisory, so you don't need to do the discard or the DSM command deallocate. On FTP, you will honor the DSM command deallocate because it will effectively like an erase, but of the LBA range. And if you follow those rules, then you can, with a high level of confidence, remove the garbage collection on the device. And then you go and test it on the side. Because keep in mind, this is all about backwards compatibility. A lot of these people say, I do not have the engineering resources to fully port my application or my application to FTP. So I'm just going to do a little bit of the work, whatever I can, and then I'll do a little bit later, but I can still buy the drive today. And that is driving a lot of the early adoption.
That was the same thing with streams. You buy the drive, you can attach to it over time.
Yeah, but timing is important. At the time, streams did not catch, and at the time, streams was something that I was not part of Samsung, but it was something that a guy called JU published on and put in a drive, and nobody cared. And at the time, there was no proper support for Linux until Jens put it in. Now we're in a different world.
I think I'm not disputing whether it's technology. I'm just saying.
Take the mic so everyone hears.
The community
having a hard time because they've been through this.
There's only one person having a hard time. I don't see anybody in the community complaining. Yeah.
Yeah. Yes. Maybe, we have a bit of time left. Is there anything else we should bring up today before we round up? Are we all good? Want to head out to the evening event? All right. I think we can just wrap up. And I'd like to thank you guys for coming and for all the good discussions. And I'm sure we will continue discussing these things in the coming days and weeks and months and years. Yep. Thanks all. we got some, we had a proper discussion. Or an argument, I don't know.
Access mute.
Believing that you can hold the key to the Linux kernel, that's like nonsense. Reality. Yeah.